we will be learn in this topic Module 1 Introduction to Natural Language Processing. Module 2 Text Representation and Feature Engineering. Module 3 Text Classification. Module 4 Named Entity Recognition and Parts of Speech Tagging. Module 5 Syntax and Parsing. Module 6 Sentiment Analysis and Opinion Mining. Module 7 Machine Translation and Language Generation. Module 8 Text Summarization and Question Answering. Module 9 Advanced Topic in NLP. Module 10 NLP Applications and Future Trends. Module 11 Capstone Project. For this course, we did some basic requirements that will be you should have an interest in natural language processing and its application, and interested in text representation and feature engineering, text classification, name entity recognition, and parts of speech tagging. Syntax and parsing, sentiment analysis and opinion mining, machine translation and language generation. Text summarization and question answering, advanced topic in NLP, NLP application and future trends, capstone project. Be interested in getting the knowledge of sentiment analysis and opinion mining, machine translation and language generation, text summarization and question answering. Have an interest in understanding NLP application and future trends, advanced topic in NLP and capstone project. It will be dedicatedly mentioned for professionals with a deep understanding of NLP application, advanced topic in NLP, and a desire to excel in the field of natural language processing. New professionals aiming for success in NLP application and economic environment of business. Existing executive managers, team leads, developers who are seeking greater engagement and innovation in the field of NLP and their organization. Take the next step in your career as data science professional, whether you are an upcoming data scientist and experienced data analyst, aspiring machine learning engineer or budding AI researcher. This course is an opportunity to sharpen your data management and analytical capabilities, increase your efficiency and professional growth, and make a positive and lasting impact in the field of data science and analytics. With this course, all the fundamental function and skill are you will learn based on natural language processing. Part we will be discussing about natural language processing fundamentals. Module 1 Introduction to Natural Language Processing. Lesson 1 Overview of NLP. Sublesson Definition and Importance. Sublesson Application of NLP. It's mentioned over here as natural language processing. NLP is a subfield of artificial intelligence AI and computational linguistics that focus on the interaction between computers and human language. It involves developing algorithms and techniques to enable computer to understand, interpret and generate human language in a way that is both meaningful and useful. Here's an overview of key concepts and components in NLP. Based on these mentioned details, we can say that natural language processing is a branch of computational linguistics and artificial intelligence that study how computers can communicate using human language. NLP is essential concerned with making computers capable of comprehensive, interpretable, and producing human language. Interaction of computer and human language. Natural language processing studied how computer can successfully connect with people through language. This entails a number of duties including comprehending user, providing text, producing coherent natural language output or answer, and shifting through massive volume of text data to retrieve patient's information. Developing algorithm and method, natural language processing including the development and improving of algorithm and made that enable computers to perform tasks linked to language from straightforward rule-based system to interact machine learning model trained on massive. NLP play a crucial role in making possible for computer to understand human language. This entails being able to identify words as well as comprehend and relationship, context and meaning of various words and phrases within a particular task. Interpretation, natural language processing encompass not only language understanding but also meaningful and patient interpretation of textual input. This could involve using a computer to extract certain data or insight from the text such as sentiment analysis, name entity recognition and semantic parsing. NLP plays a crucial role in making it possible for computers to understand human language. This entails being able to identify words as well as comprehend and relationship, context and meaningful of various words and phrase within a particular text. Generation, the capacity of computers to produce linguistic output that resemble that of a human is also including in NLP. This might include job like language translation, text summarization and natural language creation, in which the computer generate content that is grammatically accurate and coherent depending on input or persist criteria. The capacity of computer to produce linguistic output that resemble that of a human is also included in NLP. This might include job like language translation, text summarization and natural language creation, in which the computer generates context that is grammatically accurate and coherent depending on the input or present criteria. Meaningful and useful, making computer language processing meaningful and practice is the ultimate object of natural language processing. This entails giving computers an ability to interact with people in an efficient manner, help with activities involve the creation or interpretation of language, and offer a conclusion or solution based on analysis of text data. It's beneficial to break down each idea in paragraph and give examples to show how NLP technique and using variety of real world context including machine translation, virtual assistance and sentiment analysis in social media and information extraction from documents. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about text processing. It's mentioned over here as tokenization, breaking down text into smaller units such as word or sentence, stemming and lemmatization, reducing word to their base or root from to normalize text. Stop word removal, removing common words that carry little semantic meaning, example the, is, and. Parts of switch tagging, assigning grammatical tags to words, example noun, verb, adjective. Syntax and grammar, parsing, analyzing the grammatical structure of sentence to understand their syntax. Dependency parsing, identifying synectic relationship between words in a sentence. Continuancy parsing, parsing sentence into their grammatical constituents, phrase clause. Semantics, name entity recognition, identifying and categorizing name entities such as people, organization, and location. Word sense disambiguations, determine the correct meaning of a word based on its context. Semantic role labeling, identifying the role played by words in a sentence, example agent, patient, instrument. Based on these mentioned details, we can say that in natural language processing activities, tokenization is an essential step that divides text data into a smaller unit such as word or sentence. This makes it possible for algorithm to work on specific textual component, enhancing the efficiency of NLP jobs later on. In order to normalize the text stemming and lemmatization, remove suffix and prefix and stored a word base or dictionary from by understanding language and minimization word variant. These enhance the efficiency of NLP jobs that comes after another method that enhance text analyzing task accuracy and help concentrate on more significant material is stop word elimination. By removing stop word, the enable algorithm to give priority to word that provide crucial information. Word in text are given grammatical tag using parts of speech tagging defining their category and syntactic function inside the phrase. Information extracting, sentiment analysis and machine translation are just a few of the NLP application that might benefit from this technique, which is useful for phrase structure and meaning. All things considered, those text processing methods are critical for organizing and evaluating text data. Syntax and grammar. In natural language processing activities, tokenization is an essential step that divides text data into smaller units such as word or sentence. It makes it possible for algorithm to work on specific textual component, enhancing the efficiency of NLP jobs later on. Technique like stemming and lemmatization try to normalize the text by breaking word down to their most basic or root form. Lemmatization use vocabulary and morphological analysis to yield a word's base of dictionary form, where stemming remove suffix or prefix from word to reach the root form. The elimination of stop word is another crucial NLP approach that enhance text analysis task accuracy and help focus on a more valuable content. Algorithm can prioritize word that communication significantly information by eliminating stop word. Word in a text are given grammatical tags using parts of speech tagging which indicate their syntactic function and category inside sentence. This is helpful for comprehending the composition and meaning of phrase and many be applied to a number of NLP tasks, including machine translation, sentiment analysis, and information extraction. Parsing, consistency parsing, and dependency parsing are three key ideas in NLP that are connected to the comprehending the syntax and structure of sentence. In order to understand the syntax of sentence, parsing entailing examination their grammatical structure. This is necessary for tasks like information extraction, question answering, and machine translation. By representing word as node in a graph and their relationship as direct edge, dependency parsing finds syntactic link between words in phrase. Constituency parsing identify bigger syntax structure component inside sentence by breaking sentence down into a constituent such as phrase and clause. To summarize, NLP techniques such as dependency parsing, consistency parsing, and parsing are crucial for comprehending phrase structure and syntax, since they offer significant insight into the arrangement and relationship word inside a sentence. Semantic, this section developed into three key components in natural language processing that help understand the semantic and structure of text. Firstly, named entity recognition is a crucial task in NLP, which involves identifying and categorizing name entities within a text into a predefined categories. Name entities are specific entities with names such as person, organization, location, and dates. In-year is essential for tasks like information extraction, question answering, and named entity linking. Secondly, word sense disambiguous is a sentence WSG is a crucial for tasks like machine translation, information retrieval, and semantic analysis. Lastly, semantic role labeling is a task in NLP that identify the semantic role played by word or phrase in a sentence. Semantic role represent the function that word or phrase fulfill in a relationship to predict of a sentence such as agent, the doer of an action, patience, the entity affected by an action, an instrument, the meaning which can action is performed. Those tasks enable computer to better understand and process natural language text. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about discourage and programmatics. It's mentioned over here as co-reference resolution, resolving reference to the same entity across a text. Anaphora resolution, identifying pronouns and their reference in a text. Discourse analysis, understanding the structure and coherence of a larger unit of text, such as paragraphs and documents. Machine learning in NLP, supervised learning training model on label data to perform tasks such as classification, sequence labeling, and machine translation. Unsupervised learning, learning pattern and structure in data without explicit supervision. Used for tasks such as clustering and topic modeling. Deep learning, leveraging neural network architectures to learn complex patterns in the text data, such as recurrent neural networks and transformer model, BERT GTP. Based on these mentioned details, we can say that coherence resolution is a crucial task in NLP language processing that involve identifying and resolving reference to the same entity across a text. This is essential for tasks like information extraction, questions answering, and text summarization, where it is crucial to understand their mention in a text referred to the same entity. Anaphora resolution is a specific type of co-reference resolution that focus on identifying pronouns and their referent in the text anaphora. Resolution is important for understanding the relationship between pronouns and the accent in a sentence or text. Discourage analysis is the study of larger unit of text such as paragraphs, documents, or conversational to understand their structure, coherence, and meaning. It goes beyond analyzing individual sentence and focus on how sentences are organized and connected to the coherent units of discourse. This task is important for understanding the flow of information, the development of ideas, and overall meaning of conveyed by a piece of text. In summary, co-reference resolution, anaphora resolution, and discourse analysis are essential tasks in natural language processing for understanding the coherence structure of a text, different level of granularity. Supervised learning is a machine learning diagram where models are trained on label data to perform specific tasks. It involves pairing each example with a corresponding label or target indication that correct output or categories for that example. This is commonly used for tasks such as classification, sequence labeling, and machine translation. Example of supervised learning algorithm including support vector machine, decision tree, and deep neural networks. Unsupervised learning is a machine learning paradigm where model is learned pattern and structure in data without explicit supervision or label example. It is commonly used for tasks like clustering and topic modeling. Example of unsupervised learning algorithms including k-means clustering, hierarchical clustering, and latent Dirichlet allocation (LDA). Deep learning is a subset of machine learning that leverage neural network architecture with multiple layers to learn complex pattern and representation from data. It has shown remarkable success in tasks such as sentiment analysis, named entities recognition, machine translation, and text generation. Deep learning model for NLP often utilize architectures such as recurrent neural network (RNN), long short-term memory (LSTM) network, convolution neural network (CNN), and transformer model. Those models can capture interact pattern and dependencies in text data, leading to state-of-art performance on various NLP tasks. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about application of NLP. It's mentioned over here as information retrieval, finding relevant document or passages based on user queries. Sentiment analysis, determine the sentiment or opinion expressed in text. Example, positive, negative, neutral. Machine translation, translating text from one language to another. Question answering, automatically answering questions posed in natural language. Text generation, generating human like text such as chatbot and language modeling. Challenge in NLP. Ambiguity word and phrases can have multiple meaning depending on context. Out of vocabulary words, dealing with words that were not seen during training. Domain adaptability, adapting model training on one domain to perform well in another domain. Ethical and bias considerations, addressing issue of fairness, privacy, and bias in NLP system. Based on these mentioned details, we can say that information retrieval is the process of finding relevant document or passages from text data based on user queries, often used in search engine technique like indexing, ranking, and retrieval model are used to efficiently find the present relevant information. Sentiment analysis, also known as opinion mining, determines the sentiment or opinion expression in text, which is used in various applications such as social media monitoring, customer feedback analysis, and brand sentiment analysis. Machine translation is the process of automatically translating text from one language to another, preserving the machine and context of the original text. Techniques like statistical modeling, rule-based approaches, and natural machine translation are used to produce accurate translation across different language pairs. Question answering is the process of automatically generating answer to question posed in natural language involve understanding the meaning and intent of the question and retrieving relevant information. Text generation is a task of producing human-like text automatically, which can involve generating coherent and contextual relevant responses in conversation system, creating summaries of long document or articles, or generating creative and expressive prose. Text generation models such as recurrent neural network or transformer architecture are trained on large text corpora or mimic human language patterns and style. In summary, information retrieval, sentiment analysis, machine translation, and question answering and text generation are crucial tasks in natural language processing with application in search engine, social media analysis, language translation, customer support, and content generation. Ambiguity of out of vocabulary word, domain adaptation, and ethical and bias consideration are crucial aspects in natural language processing. Ambiguity refers to a multiple meaning of word and phrases in natural language, which can be challenging for NLP system to interrupt. And disambiguate out of vocabulary word are word that are not seen during training of a language model or NLP system, which can arise due to various in language use, new term or slang, or domain specific terminology. Addressing OOV words is crucial for ensuring the robustness and generalization of NLP system, as they must be able to handle unseen words encountered in real-world application without comprehensive performance. Domain adaptation is the process of adjusting model train one domain to perform well in another domain. In NLP, domain specific language use, vocabulary and terminology can vary significantly across different domains, leading to performance degradation. Domain adaptation technique aim to mitigate the issue by fine-tune or adapting pre-trained model to new domain, improving their performance and applicability across diverse domains. Ethical and bias consideration are critical aspect of building and deploying NLP system responsible. NLP system can biases in the data they are trained on, leading to unfair discriminatory outcomes. Addressing those considerations involves identifying and mitigation biases in training data, designing fair evaluation metrics, and incorporating principle of fairness, accountability, and transparency into the development and deployment of NLP system. After reading out this part, we will learn about the application of NLP. Now we will go to next particular discussion. In this particular part, we will be discussing about NLP is a rapidly evolving field with application. It's mentioned over here as NLP is a rapidly evolving field with application in various industries such as healthcare, finance, customer service, and entertainment. Advance in deep learning and large scale language model have led to significant progress in many NLP tasks, but challenges such as understanding context, reasoning, and common sense knowledge remain areas of active research. Based on these mentioned details, we can say that NLP or natural language processing is rapidly evolving field that has gained importance across various industries including healthcare, finance, customer service, and entertainment. It uses technique and algorithm to automate tasks, extract insight from text data, and enhance the user experience. NLP technologies are used in healthcare for tasks like clinical documentation, electronic health record analysis, and medical image analysis. In finance, NLP is used for sentiment analysis, fraud detection, and automated trading in customer service. NLP powered chatbot and virtual assistant handle inquiries, provide personalized recommendation, and generate content. Advance in deep learning and large scale language model have revolutionary NLP with model like recurrent neural network, convolution neural network, and transformer architecture demonstration remarkable performance improving in various NLP tasks. Those models leverage large amount of text data and sophisticated learning algorithm to capture complex pattern and relationship in language. However, challenges remain in understanding context, reasoning, and common sense knowledge. Contextual understanding require model to comprehend the meaning of text in a relation to its surrounding context, while reasoning involves inferring logical relationship and drawing conclusion from text data. Common sense knowledge, which refer to the implicit knowledge and understanding of world's humans process, is often difficult to capture in NLP system. Addressing those challenges require advance in model architecture, data representation, and training methodology, and remain area of active research in the field. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about basic of text pre-processing with Python. It's mentioned over here as text processing with Python involves manipulating and analyzing textual data using various library and technique. Below are those basic of text processing with Python. Reading and writing text file. Reading text file use Python's built-in open function to read file line by line or in one go. Python copy code with open text underscore file dot txt in between inverted comma r as file colon text equals to file dot read function. Writing text files use open with the mode w to write text to a file. Based on these mentioned details, we can say that Python is a powerful tool for text processing, enabling user to clean, transformer analysis, and extract insight from textual data. These include tasks like sentiment analysis, named entity recognition, and text summarization. Python's ecosystem of library and tool including NLTK, SPACY, text, blob, scikit-learn, and GenZim provide pre-built function and algorithm for tasks like tokenization, stemming, lemmatization, and parts of speech tagging. The basic of text processing in Python involve understanding, implementing fundamental technique like tokenization, stemming, and lemmatization. Stopword removal as a part of speech tagging. Those techniques serve as foundation for more advanced tasks and help prepare text data for analysis and modeling. Text processing with Python is essential for various domains such as natural language processing, data mining, information retrieval, and computational linguistics. By leveraging Python library and technique, practitioners can efficiently manipulate and analyze textual data, extracting valuable insight and knowledge from text source. Reading this entire content, you can use open function with r mode to read the entire context of a text file into a single string or variable. This approach is suitable when you need to process the entire text file as a whole reading line by line. Alternatively, you can read and text file line by line. This achieved by either using the readline function method to read one line at a time by iteration over the file object directly, which automatically read the file line by line closing the file. After reading from the file, it's important to close it properly to release system resource. This can be done manually using the close function or automatically by using the statement which ensure that the file is closed even if an error occurs during reading. Overall, Python's open function provide a flexible and convenient way to read text file, allow you to access their content effectively for various processing tasks. Python code, this code uses Python built-in open function, read and content of text file name text underscore file dot txt in read mode are the with statement ensure proper handling of resource like file ensuring the file is automatically closed after the code block. The open function is called with two argument the file bar text underscore file dot txt and the mode R which allow the file to be open for reading its content. The open function return a file object which are assigned to the variable file representing the open text file and providing methods and attribute for interacting with it. The read method reads the entire content of a text file as a string and assign it to the variable text. The with sentiment automatically close the file after reading the storing the content, ensuring that the system resource associated with the file are properly released. Python open function is a built-in method for performing file operation like reading and writing to file. It takes to main argument the file path, the mode in which the file should be opened in W mode, The file is open for writing, creating. It is does not exist or overwriting existing content if it already exists. Writing text to a file can be done using method like write or write lines, write a single string, while write line write multiple string. It's crucial to close the file properly after writing to release system resource and ensure data integrity. This can be done manually using the close method or automatically using with a statement. In summary, using open function with a method mode W or allow you to write a file in Python commonly used to creating or overwriting the file content. The new text data properly file closure is essential for data integrity and efficient use of system resource. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about Python code with open in between bracket output.txt in between inverted comma w as file semicolon file write hello worlds output hello worlds. Tokenization, word tokenization, splitting text into individual word or token. Import NLTK download punkt from nldk.tokenize. Import word underscore tokenize text equals to tokenization is an important step in NLP. Tokens equals to word underscore tokenize in between bracket text print tokens. Output tokenization is an important step in NLP. Sentence tokenize splitting text into sentence. Python code from NLTK tokenize import send tokenized text equals to sentence 1 dot sentence 2 dot sentence 3 sentence equal to send underscore tokenized in between bracket text print sentence 1 comma sentence 2 comma sentence 3. Based on these mentioned details, we can say that the code begins with the statement of a Python construct used for handling file and ensuring proper file handling. The open function is called with two arguments, the file path output.txt and write mode w. The open function return a file object that represent the open text file and provide method and attribute for interacting it. The write method is called on the file object to write the string hello world to the file. This method make a single argument which is the string to return to the file. The with statement automatically close to the file after writing ensure that system resources associated with the file are properly closed. The code snap effectively write the string hello world to a text file named output.txt using Python's open function and write method. Tokenization, the code import the NLTK library and download the necessary resources for tokenization, including the punkt tokenizer model. It then import the word tokenize function from the nltk.tokenize model, which tokenize text into individual word or tokens. The input text is the text to be tokenized and the word tokenize function is called with the text as its argument. The function tokenizes the text into individual word or tokens based on white space and punctuation. The tokens obtained from tokenization are then printed using the print function. This code snap demonstrates the fundamental step of word tokenization in natural language processing (NLP), which is crucial for text analysis, information retrieval, and machine learning. Sentence tokenization is the process of splitting a text into individual sentences. This is commonly done by identifying punctuation marks that typically denote the end of a sentence, such as periods, exclamation mark, and question mark. However, sentence tokenized can be more complex in language with punctuation convention that differ from English. In natural language processing, sentence tokenization is essential pre-processing step before performing tasks such as text analysis, sentiment analysis, and machine translation. It allows algorithm to process text on a sentiment by sentence basis, enabling more accurate analysis and understanding the next text meaning and structure. Import the send tokenization function. The code import the send tokenize function from the NLTK.tokenize model. This function is specifically designed to tokenize text into a sentence. Input text, the variable text contain the input text that we want to tokenize into sentence. In this example, the text is sentence 1, sentence 2, sentence 3. Perform sentence tokenization. The same tokenized function is called with the input text as its argument. The function tokenization the text into individual sentence based on punctuation marks such as period, exclamation marks, and question mark. Shortened tokenization sentence, the tokenized sentence are stored in the variable sentence, printing tokenized sentence. Finally, the tokenized sentence are used the print function in summary. This code snap demonstrates how tokenize text into the individual sentence using NLTK same underscore tokenize function, which is common processing step in natural language processing task. It's splitting the input text into sentence based on punctuation marks, providing a structured preparation of the text for further analysis and processing. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about text cleaning. It's mentioned over here as lowercasing converting text a lowercase for standardization. Python copy code text equals to clean this text dot inverted comma close clean underscore text equal to text dot lower print clean underscore text. Output is clean this text in a lower format. Removing punctuation, stripping punctuation marks from the text. Python copy code input string text equals to remove comma punctuation exclamatory sign in bracket comma close clean underscore text equals to text dot translate string dot make trans in between bracket inverted comma inverted comma string dot punctuation bracket close print clean text remove punctuation stopword removal stopword common word that often do not carry significant meaning example the is and based on these mentioned details we can say that input text the variable text contain the input text that we want to convert the lowercase. This is the example the text is clean this text dot lowercasing the lower method is called on the input text in between bracket text. This method converts all uppercase character into the text to their corresponding lowercase counterparts. Any characters that are already lowercasing remaining unchanged storing. Lowercase text, the lowercasing text is storing in the variable clean text or print lowercase text. Finally, the lowercase text is print using the print function. In summary, this code snap demonstrates how to convert text to a lowercase using Python built-in function lower. Lowercasing is a common preprocessing step in language processing task to standardize text and improve consistency in text analysis and modeling. Step for removing punctuation. Import the string module to access the predefined list of punctuation characteristics. Create a string that contain the text you want to clean, including any punctuation marks. Creating a translation table, use a function to create a translation table that maps each punctuation character to none, indicating that those characters should be removed from the text. Applying translation, table to the text using a method that replaces each punctuation character with nothing, effectively removing it from the text. Store and print the cleanest text. Store the resulting text without punctuation in a new variable and print it to see the clean text. Explanation: you are the string model because it contains a constant that holds all punctuation character. The translation table tells a method which characters to remove. The resulting text will have all punctuation characters removed. Mark it more suitable for tasks like text analysis where punctuation may not be needed. By following those steps, you can easily remove punctuation from any given text, resulting in cleaner version of the text for further processing. Stop word removal refer to a common word in a language that often do not carry significant meaning on their own, such as the is and an. Those words frequently appear in text but contributed little to semantic content or meaning of a text. Why remove short word? Noise reduce removing stopword can help reducing the noise in textual data, making it easier to focus on more meaningful word efficiency by filtering out stopword. The text processing become more efficient and text are fewer words to analyze, improve result. Many natural language processing tasks such as text classification and sentiment analysis yield better result when the stopword are removed, as it allow the algorithm to concentrate on the word that carry more significant meaning. How to handle stop word library? Many NLP libraries such as NLTK Natural Language Toolkit and Spasai provide a predefined list of stop word for different language. Custom lists depend on the specific application. You might create a stop word refer to a common word in a language that often do not carry significant meaning on their own, such as the, is, and an. Those words frequently appear in the text but contributed little to the semantic content or meaning of the text. Noise reduction: removing stopword can help reduce the noise in the textual data, making it easier to focus meaningful words. By filtering out stopword, the text pre-processing become more efficiency as there are fewer words to analyze. If you have a sentiment like the quick brown fox jumps over the lazy dog, removing stopword would result like quick brown fox jumps lazy dog, which retain the essential meaning while eliminating the important words. By removing stopword, you can streamline the text processing and focus on text that contribute the most understanding and analyze the text. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about Python code from nldk.corpus import stopword nldk.download stopword text equals to remove stopwords from this text. Words equals to word underscore tokenized text stopword list equals to set stopword dot words English. Filtered underscore words equals to word for word in word if word dot lower not in a stopword underscore list. Printed filter words. Remove stopword text. Stemming and lemmatization. Reducing words to their root from by removing suffix. From nldk.stem import portster stemmer. Stemmer equals to port stemmer. Word equals to running, comma, plays, comma, happier. Stem words. Stemming dot stem words for word in words. Print stemmed underscore words. Output run, play, happier. Based on these mentioned details, we can say that this code snap demonstrates how to remove stored from a text using the natural language toolkit in Python. Here is an example of each part of this code. Importing stopword. The stopword module from NLTK corpus is important. This module provides access to predefined list of stopword, downloading stopword, the NLTK.download stopword common ensure that the stopword dataset is downloaded and variable for use. This step is necessary only in the stopword dataset is not already downloaded. Input text, the variable text contain the input text from which stopword will be removed. In this example, the text is remove stopword from this text. Tokenization text, the word tokenization function is used to split the text into individual word or tokens. The result of a list word in a text. Creating stopword list. The stopword English function retrieve the list of English stopword. The list is converted to a set for faster lookup. Filtering stopword. A stopword comprehensive is used to filter out the stopword for each word in a tokenized text. The word is included in filtered word list only if it is not in the stopword list. The lower method is used to ensure the compromise in case of insensitive. Painting filter word, the final list of word with stopword removing is printed. Here is the code and its explanation without using code. Import stopword. Import the stopword from the NLTK corpus to access the predefined list of common words that are considered insignificantly. Download stopword. Ensure that the stopword dataset is downloaded any available for use. This step is necessary for the code to function correctly if the dataset is not already present. Input text. Define the input text that you want to process and remove stopword from tokenized text. Split the input data text to individual word or tokens using tokenization function. Create stopword list. Retrieve the list of English stopword and converted it to set for more efficient checking. Filter stopword used a list of comprehension to filter out the word that are in the stopword list. Compare each word in case of insensitive manner to ensure accuracy. Print filter word output the list of words that remain after stopword have been removed. This process effectively removes common significantly words from the input text, leaving only the more meaningful word for further analysis or processing. Stemming and lemmatization course NAM demonstrate how to perform stemming using natural language toolkit in Python. Stemming is the process of reducing word to their root form by removing suffix and other morphological variants. Here's a detailing explanation of each part of this code. Import the porter stemmer. The porter stemmer class from the nltk.stem module is import. The porter stemmer is a popular stemming algorithm used to reduce words to their base or roots form. Creating an instance of stemmer. An instance of port stemmer is a create as stored in the variable stemmer. This instance will be used to perform stemming on the words. Defining the list of word. A list of words that needed to be stemmed is defined in example the words are running, place and happier. A list of comprehension is used to apply stemming process to each word in the list. The stemming method of Porter stemmer instance is called for each word and the result is stored in the stem word list. Printing the stem word, the list of stem word is printed. Each word is original list is transformed into its root from removing suffix. Here is a code and explanation without. Import the porter stemmer class from the NLTK.stem module which provides the implementation of a porter stemmer algorithm. Creating stemmer instance of porter stemmer to create an object that can be used to stem word. Defining words, a list of words that you want to reduce to their roots form. Those words typically have different suffix or morphological variant. Applying stemming use a comprehension to apply a stem method of the Porter stemmer to each word in the list. These methods remove suffix and reduce each word to its base form, outputting the result, printing the list of stemming word to see the result of the stemming process. Given words running, plays, happier. The stemming process will reduce them to run, play, happier. The word running is to reduce run by removing ing suffix. Plays is reduced to play by removing s suffix. And happier is stemmed to happier as it is already in its simplest form according to the Porter Stemmer rules. Stemming helps standardization word to their root form, which can be useful in various NLP tasks like text normalization, search engine, and information retrieval system. Particular part we will be discussing about lemmatization. It's mentioned over here as lemmatization reducing words to their base from using lexical knowledge. Python code from nltk.stem import wordnet lemmatizer nltk.downloads in between bracket inverted comma wordnet. Lemmatizer equals to wordnet lemmatizer function words equals to in between bracket inverted comma running comma plays comma happier lemmatized underscore word lemmatizer dot lemmatized in between bracket word for word in word print lemmatized underscore word output of this code running play happier bag of words representation count vectorized converting text document into a numerical feature vector Python code from sklearn feature underscore extraction dot text import count vectorized corpus equals to in between third bracket inverted comma this is the first document dot inverted comma close comma inverted comma open this document is the second document dot inverted comma close comma inverted comma open and this is the third one dot inverted comma close comma inverted comma open is this the first document inverted comma close comma bracket close vectorized equals to count vectorized function x equals to vectorized dot feed underscore transform in between bracket corpus print x dot to array function here is the output array in between bracket third bracket 0 1 1 1 0 0 1 0 1 comma 0 2 0 1 0 1 1 0 1 comma 1 comma 0 comma 0 1 1 0 1 1 1 comma 0 1 1 1 comma 0 0 1 0 1. Based on these mentioned details, we can say that this course NAP demonstrate how to perform lemmatization using the natural language toolkit in Python. Lemmatization is the process of reducing word to their base or directory from known as the lemma. Using lexical knowledge, here is a detailed explanation of each part of this code. Import the wordnet lemmatizer. The wordnet lemmatizer class from the nltk.stem module is import. The WordNet lemmatizer uses the WordNet lexical database to find the base form of words. Downloading the WordNet data, the nltk.download in between bracket inverted comma WordNet function is a call to download the WordNet data which is necessary for the lemmatizer to work. Creating an instance of the lemmatizer. An instance of the WordNet lemmatizer is created and stored in the variable lemmatizer. This instance will be used to perform lemmatization on the words. Defining the list of words, a list of words that need to be lemmatized is defined in the example. The words are running, play, and happier. Lemmatization, the words, a list of comprehensive is used to apply the lemmatization process to each word in the list. The lemmatized method of a wordnet lemmatizer instance is called for each word, and the result is stored in the lemmatized word list. The list of lemmatized word is printed. Each word in original list of transform into its base form of lexical knowledge. Example, given the word running plays happier, the lemmatization process will be reduce the running unchanged without pause. Play happier, unchanged without pause. Lemmatization is a context aware and use lexical knowledge to convert word their base form. Unlike stemming, which simply cut off word ending, lemmatization can handle more complex cases generally produce more meaningful result. Explanation with code. Import the lemmatizer. You use a lemmatizer from a lexical database like WordNet, which provide the base form of word based on their meaning and context. Download lexical data. Ensure that the necessary lexical data such as WordNet is available for lemmatizer to reference. Created the lemmatizer. Instantiate the lemmatizer to create an object that can be useful to find the base form of words. Defining words. Provide a list of words that you want to reduce to their base form. Apply lemmatization. Use the lemmatizer to convert each word in the list to its base form, considering the word meaning and context. Output result. Print or store the list of lemmatized word to see the result of lemmatization process. Additional details. POS tagging for more accurate lemmatization is often useful to provide the part of speech tag of each word. For example, the word running can be lemmatized to run if it's identifying as a verb. Difference from stemming. Unlike stemming, which only cuts off suffix, lemmatization use a deeper understanding of word form and meaning to provide more accurate base form. Here is how you might modify the code to include pause tagging for better lemmatization result. In this enhanced version, the lemmatizer take into account the part of speech of each word for more accurate result. Bag of words representation. This code demonstrate how to use the count vectorized form, the scikit-learn library to convert a collection of text document into a matrix of token counts, also known as a bag of words representations. Here an explanation of each part of the code. Explanation. Import count vectorized. The count vectorized class is the import from sklearn features extraction text module. This class is used to convert a collection of text document into a matrix of token counts. Defining the corpus. A corpus of a text document is defined as a list of string. Each string in the list represents a document. In this example, the corpus consists of four sample sentence initialize, the count vectorize, and instance of count vectorize is created and stored in variable vectorized. This instance will be used to feed and transform the corpus into numerical feature vectors. Feeding the transforming the corpus. The feeding transform method of the count vectorized instance is called with the corpus as an argument. This method performs two tasks. Feed, it is learn the vocabulary of a corpus so that it build a dictionary of all the unique word in the corpus. Transform, it converts the corpus into a sparse matrix where each row corresponds to a document and each column corresponds to a word from the vocabulary. The values in the matrix represent the count of each word in each document. Converting the sparse matrix on an array. The to array method is called on resulting sparse matrix X to convert it into a dense array format. which is easier to print and understand. Printing the array. The dense array representation of a document term matrix is printed. Each now represent a document of each column represent a word. The values in the array we are the counts of the words in the corresponding documents. Example given the corpus. This is the first documents. These documents is the second documents, and this is the third one. Is this the first document? The count vectorize will produce a matrix where each row corresponding to a documents, each column corresponding to a unique word from the corpus. The value in the matrix represent the frequency of the word in each document. Converted text to number. The process involves transforming text data into a numerical form so that the machine algorithm can process it. Build vocabulary vectorizations can through the entire text corpus and build a vocabulary of all the unique words encounters. Count vectorize occurrence for each document in the corpus, the vectorize count and the occurrence of each word from the vocabulary and store those count vectors in matrix format. Sparse matrix. The resulting matrix is typically sparse so that the contents may zero because of most words do not appear in most document. Converted dense array. For better visualization and understanding, the sparse matrix can be converted to a dense array format which show the actual count of each word in the document. Additional details tokenization, the vectorized split each document into individual token words based on white space and punctuation. Lowercasing by default, the vectorize convert all the character to a lowercase before tokenize. Remove the stop word, common word like is, the, etc. can be excluded by the setting a parameter in count vectorized. Using this approach, the textual data is transformed into a numerical format. The machine learning algorithm can work with enabling various NLP tasks such as text classification, cluster, and more. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about TF-IDF. It's mentioned over here as TF-IDF vectorization. TF-IDF vectorized converting text document into a TF-IDF feature vectors. Python code from sklearn.feature underscore extraction.text import TF-IDF vectorize equals to TF-IDF vectorize function x equals to vectorize.feed underscore transform in between bracket corpus print x to array. Text pre-processing is a fundamental aspect of natural language processing NLP, and it's crucial for tasks such as text classification, sentiment analysis, and information retrieval. Python provides various libraries such as NLTK, scikit-learn, and SPACY to perform text pre-processing efficiently. Based on these mentioned details, we can say that the TF-IDF vectorize is a Python library that transforms text data into TF-IDF feature vector. It is imported from the sklearn feature extraction text module and is used to feed the transform a corpus of text document into TF-IDF feature vectors. The TF-IDF vectors instance is created and stored in a variable vectorize which perform two tasks, fitting and transforming the corpus. The fit transform method and the TF-IDF vectorized instance is called with the corpus as an argument performing two tasks, fitting and computing the IDF. Inverse document frequency. Values for the word in the corpus. It then transforms the corpus into a sparse matrix where each row corresponds to a document and each column corresponding to a word from the vocabulary. The values in the matrix represent the TF-IDF score of the words in the document. The process involved transforming text data into a numerical form using the TF-IDF approaches to show The machine learning algorithm can process it. The vectorized scan through the entire text corpus, build an vocabulary of all unique word, compute the IDF inverse document frequency for each word and compute the TF crumb frequency of each document and multiplies it by the IDF to get the TF IDF score. The resulting spots matrix is typically spots because most words do not appear in most documents. To better visualize and understand the result, the spots matrix can be converted to a dense array format, showing the actual TF-IDF score of each word in each document. Text processing is a fundamental aspect of natural language processing (NLP) and is crucial for tasks such as text classification, sentiment analysis, and information retrieval. Python provides a various library for text reprocessing, including NLTK Natural Language Toolkit, Scikit-learn Machine Learning Library, and SPACY Industrial Strength of NLP Library with support for advanced text processing tasks like name entity recognition and dependency parsing. Those libraries often robust functionality to preprocess text data, converted it into numerical format, and apply various machine learning and deep learning algorithms for NLP tasks. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about text representation and feature engineering. It's mentioned over here as the bag of words BOW model is a fundamental technique in natural language processing NLP used to represent text data as a numerical feature vector. It is a simple and effective way to convert text data into a numerical format for machine learning algorithm. Here's an overview of bag of words model. Based on these mentioned details, we can say that the bag of word model is a fundamental technique in natural language processing (NLP) used to represent text data as a numerical feature vector. It's a simple and effective way to convert text document into a format that machine learning algorithm can process. Here's an overview of the bag of word model. The basic concept: the BOW model transforms text into fixed length numerical vectors. The key idea is to represent each document by a vector that counts the occurrence of each word in the document. The model ignores grammar and word order, focusing slowly on the word's frequency. Vocabulary creation corpus A collection of documents. Vocabulary a set of all unique words in the corpus. Vectorized representation. Each document represented as a vector with the same length of as a vocabulary. Each element of the vector corresponds to a count of vector in the document's step to create a BOW model. Text pre-browsing, cleaning and tokenize the text. Example: lowercasing, removing and punctuation. Building the vocabulary, identify all unique words in the corpus. Creating document vector, count the occurrence of each word in each document to create vectors. Advantages: simplicity, easy to understand and implemented. Efficiently first computes for text representation. Limitations: loss of context, ignore word order and context. High dimensionality can result in a very large vector, especially with a large vocabulary. Sparsity: many elements in the vector are zero, making them sparse. Application of text classification: categorize the document into a predefined categories. Sentiment analysis: analyzing the sentiment expression in the text. Information retrieval: retrieving the document relevant to a query. The bag of word model is a fundamental technique of NLP for text representation despite its simplicity and limitations. It provides a solid baseline for many text processing tasks and serves as a stepstone to more advanced techniques like TF-IDF and word embeddings. Understanding the implementing the BOW model is a crucial first step in working with the text data in machine learning and NLP. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about tokenization. It is mentioned over here as tokenization, the process of splitting text into individual word or tokens. Example, the quick brown fox jumps over the lazy dog becomes the quick brown fox jumps over the lazy dog. Vocabulary building. Vocabulary is a set of unique words found in the corpus. Example, the quick brown fox jumps over the lazy dog. Feature extraction. Count vectorization representing each document as a numerical vector where each element corresponds to the count of word in a vocabulary. Example, document 1. The quick brown fox jumps over the lazy dog. 1 comma 1 comma 1 comma 1 comma 1 comma 1 2 comma 1 comma 1 counts of each word in a vocabulary. The document 2, the dog barks loudly. 1 comma 0 comma 0 comma 0 comma 0 comma 0 comma 1 comma 0 comma 1. Based on these mentioned details, we can say that tokenized is the process of breaking down a text into smaller units, which are typically words or subwords. In your example, the sentence, the quick brown fox jumps over the lazy dog, is tokenized into individual word. Vocabulary building. After tokenization, you can collect all unique tokens from your corpus collecting of text. The set of those unique words constitute your vocabulary. In your example, the vocabulary consists of the quick brown fox jumps over the lazy dog. Feature extension, count vectorization. Once you have your vocabulary, you can represent each document in your corpus as a numerical vector. In count vectorization, the vectors element correspond to the count of each word in the vocabulary. Within the document, for example, if we had another sentence, the quick fox jumps over the lazy dog, its count vector representation would be 1 comma 1 comma 0 comma 1 comma 1 comma 1 comma 2 comma 2 comma 1, where each element corresponds to the count of the represented word in the vocabulary. The is 1, quick is 1, brown is 0, fox is 1, jump is 1, over is 1, the is 2, lazy is 2, and the dog is 1. This count vectorization representation is commonly used in various machine learning algorithms for text classification, clustering, and the NLP task. Each document is represented as a high dimensional vector where each document corresponds to a unique word in a vocabulary, and the value represents the frequency of the word in the document. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about vectorization process. It's mentioned over here as create vocabulary, collect all unique words from the corpus and assign each word a unique index. Count occurrence, count the number of occurrence of each word in each document. Generate future vector, represent each document as a numerical vector based on the word counts. Sparse representation. Sparsity, the most documents contain only a small subset of words from the entire vocabulary, leading to a sparse feature vector with the many zero entries. Sparse matrix, representing the feature vector as a sparse matrix to efficiently store and manipulate the data. Based on these mentioned details, we can say that building a vocabulary, gathering every distinct word in the corpus, then giving a distinct index. Count occurrence, determine how many times each word appears in the document. Create feature vector using the count as a guide. Create a numerical vector representation of each document. Every component in the vector match the number of that word in the document. Sparse representation, sparsity in a natural language processing, especially when dealing with the large vocabularies. Most documents contain only a small subset of words from the entire vocabulary. This result in feature vector where the majority of entries are zero, making the vector space, for instance, in the corpus with thousands of words, each document may only contain a few dozen of hundred unique and words from the vocabulary. Sparse matrix to efficiently store and manipulate those parts features vector, we use a data structure called a sparse matrix. Unlike dense matrix which store all elements, sparse matrix only store non-zero element along with their indicates. This helps converts memory and speeds the computations, especially for large data set with many zero entities. Sparse matrix representations are commonly used in NLP tasks like classification and clustering, where the feature vector tend to be highly sparse due to the large vector size. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about bag of words representation. It's mentioned over here as advantages, simple and easy to implement, preserves the order of words within documents, suitable for many NLP tasks such as text classification and clustering. Limitations, ignore the order of structure of words in the text, treats each word independently, disregarding semantic relationship. Based on these mentioned details, we can say that advantages are simply and easy to implement. The bag of words model, which is based on count, vectorization, and sparse matrix, is straightforward to understand and implement. It involves basic operations such as tokenization, counting occurrence, and constructing feature vectors, making it accessible even for beginners in natural language processing. Preserve the order of within document despite its simplicity count vectorization, maintaining the order of word within document, each word count in the feature vectors correspond to its position in the vector vocabulary, ensuring that the relative order of word is preserved. Suitable for many NLP tasks, count vectorization is versatile and applicable for various NLP tasks, including text classification, clustering, sentiment analysis, and information retrieval. It's simple and efficient, make it popular choice for the task, especially when dealing with a large dataset and high dimensional feature space. Limitation, ignore and order the structure of words in the text, while count vectorization preserves the order of word within document. It overlooks the sequential and structural information represented in the text. The limitation becomes significant in tasks with the word and context are crucial, such as language generation, machine translation, and name entity recognition. Treats each word independently, discretely, semantic relationship. Count vectorization treat each word independently and assign a unique index to it. Disgradation, any semantic relationship are independence between words. Consequently, words with a similar meaning of semantic connection may be treated as distinct entities, leading to a loss of semantic information and representation. In summary, while count vectorization offers simplicity, efficiency, and applicability to various NLP tasks, its limitations such as ignoring word and semantic relationship necessity more sophisticated approaches for tasks requiring deeper linguistic understanding and context awareness. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about example code using scikit-learn. It's mentioned over here as Python code from sklearn.feature underscore extraction .txt import count vectorizer hashtag sample corpus equals to in between bracket inverted comma the quick brown fox jump over the lazy dog comma the dogs barks loudly. Initialize count vectorizer equals to count vectorize Feed and transform the corpus x equals to vectorizer dot feed underscore transform in between bracket corpus. Converted to dense array for better visualization, sparse matrix is used in practice. Print x dot to array function. The expected output is array in between bracket third bracket 0 comma 1 comma 1 comma 1 comma 1 comma 1 comma 0 comma 1 comma 1 comma 0 2 1 comma 0 comma 1 comma 0 comma 0 comma 0 1 comma 0 comma 0 1. In the printed array, each row represented a document and each column represents a word in a vocabulary. The values indicate the count of each word in the representative document. Based on these mentioned details, we can say that the code snap demonstrates how to use the count vectorizer from a scikit-learn to perform count vectorization on a corpus of text data. Here is a breakdown of a code. Import the libraries. The code imports the count vectorizer class from the scikit-learn feature extraction.txt module. The class is used to convert a collection of text document into a matrix of token counts. Defining the corpus variable is defining which contain a list of two text documents. Initialize count vectorization. An instance of count vectorize is created and stored in a variable vectorizer. This initialize the vectorize with default setting. Feeding and transforming the corpus. The feed transform method of count vectorizer is called with the corpus as input. This method feeds the vectorizer and the corpus. Example, it learns the vocabulary. The transforms the corpus into a matrix of tokens counts. The resulting matrix X is in sparse format. Converting to a dense array, although the X matrix is typically stored in a sparse format, for efficiency, the code used to the to array method to convert it into a dense array. This is done for better visualization purpose in the example. Print the result, the dense array represent the transform corpus is printed to the console of printx or to array. Each row of the array corresponds to a document in the corpus, and each columns represent unique words in the vocabulary. The values in the array indicate the each of word in the respective documents. Overall, this is the code demonstration of basic uses of count vectorization to perform a count vectorization on a text data, which is common pre-processing step in natural language processing tasks such as text classification, clustering, and information retrieval. Each row in the print array represented a document from the corpus and each column represent a word from a vocabulary. The values in the array indicate the count of each word in the respective document. For instance, if we have a corpus, two documents and the vocabulary with four words, the quick brown fox, and the count vectorization result in the following array. Example 1 comma 1 comma 1 comma 1 1 comma 0 comma 0 comma 0. This means the first document all four words from the vocabulary appear once each. In the second document only the first word the appear once while the other words do not appear at all. This representation captures the frequency of each other in the each document, forming the basis of further analysis or modeling in natural language processing task. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about word embeddings. It's mentioned over here as word embeddings are distributed representation of word in a continuous vector space. In natural language processing, NLP, word embedding are used to capture semantic relationship between word and are widely used in various NLP tasks such as text classification, sentiment analysis, and machine translation. Here an overview of word embeddings. Based on these mentioned details, we can say that an overview of our word embeddings, which is a fundamental concept in natural language processing (NLP). Here's a detailed explanation. What are the word embedding? Word embedding are a type of word representations that allow word to be represented as continuous vector in a high dimensional space. Unlike traditional one-hot encoding, which represent the word as a sparse binary vector, word embedding provide a dense and distributed representation where the similar words are closer together in the vector space. Key characteristics of word embedding continuous vector space. Words are mapped to a continuous vector space where each word is represented by a point in this space. The position of each word is determined in such a way that words with similar meaning are located close to each other. Capturing semantic relationship, word embedding capture semantic relationship between words. For example, in a well-trained embedding space, the vector difference between the king and queen would be similar to the difference between the man and woman. Application in NLP word embedding are widely used in various NLP tasks due to their ability to capture semantic meaning. Some of the common application including text classification, word embedding are used to convert text data into numerical vectors, which can be used as an input to machine learning model for tasks like document classification, spam detection, etc. Sentiment analysis by capturing the context and meaning of words, embedding help in determining the sentiment convey in text, such as identifying position or negative sentiments in review or social media post. Machine translation word embeddings enable model to understand and translate text from one language to another by capturing the meaning of words and their relationship in different language. Example model. Some popular models used for generating word embedding including word2vec developed by Google. This model use neural networks to learn word representation in a continuous vector space. Global vector for word representation developed by a Stanford. This model created embeddings by aggregating global words to word to occurrence statistical from a corpus. First text, an extension of a word2vec by Facebook that considers subword information, making it more effective for morphologically rich language. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about distributed representation. It is mentioned over here as sparse versus dense representation. Traditional one-hot encoding result in high-dimensional sparse vectors, where word embedding represents the word as dense vector of much lower dimensionality. Semantic similarity word with similar meaning are represented by the vector that are closely together in the embedding space. Training word embedding vector to word to vec, a popular model for learning word embedding developed by a Milclove et al. It learns word embeddings by predicting the context word given the target word or vice versa. Skip grams predict context word given a target word. Continuous bag of words predicts a target word given its context word. Global vectors for word representation. Another popular word embedding technique that learns word vector by factorizing the co-occurrence matrix of words. Based on these mentioned details, we can say that key point about the word embedding in natural language processing. Let's break down each concept mentioned. Sparse versus dense representation. Sparse representation, one hot encoding. High dimensionality, each word is represented by a vector as long as the size of a vocabulary. For example, if a vocabulary has 1000 words, Each word is represented by a thousand dimensional vector. Binary values. Only one element in the vector is one, indicated the presence of the word, and all other elements are zero. For example, the word cat might be represented as 0, 0, 0, dot 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 1, 0, 0. Sparse mostly element in the vector are zero, making it sparse and inefficient in terms of storage and computation dense representation. Word embeddings. Lower dimensionality words are represented by dense vector of much lower dimensionality. Typically in the range of 50 to 300 dimension, real valued number of each word is represented by a vector of real number. For example, cat might be represented as 0.1, comma, minus 0.2, comma, 0.3, dot 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 minus 0.5. Efficiently, the dense vector are more compact and efficient for storing and computing semantic similarity proximity. In embedding space, in the word embedding, words with similar meaning are represented by vectors that are close together in embedding space. For example, the vector for king and queen will be close to each other, reflected their similarity meaning, capturing relationship. The embedding capture various semantic relationship and analogies. For instance, the relationship between man and woman is a similar to the relationship between king and queen. This can be expressed mathematically: weak king minus weak man plus weak woman equals to weak queen. Treating the word, an overview of a popular word embedding model and technique used in natural language processing. Here's an explanation of the each term. Word to wake overview. Word to wake is a widely used model for generating word embeddings developed by Thomas Milkov and his colleagues at Google. It transforms word into continuous vector by predicting the context of a word within a text mechanism. The model uses natural network and to learn words associated with a large corpus of text. It operates in two modes: skip games and continuous bag of words. Skip games function. The skip games model predict context words given a target words. For instance, given the word cat, it might predict it like its pet, whisker, meow, etc. Object, it maximizes the probability of context word appear within the certain window around the target word. This helps the model learn embedding that capture the context in the which are used. Continuous back of words function. The CBOW model does the reverse of skip grams. It predicts a target word given the surrounding context. Word, for example, given the context word pet, whisker, meow, it would predict the target word cat objective. It use the surrounding word to predict the central word, which helps in learning embedding that effectively summarize and context around the each word. Global vector for word representation. Overview of globe is another popular word embedding technique developed by researcher at Stanford. Unlike word-to-vec, which relies predicting word within a context, globe focusing on statistical information of word co-occurrence mechanism. Globe construct a co-occurrence matrix where each entry represented how frequently a pair of words appear together within a certain window. It then factorizes this matrix to obtain word vector objective. The key idea is to find word vectors such that their dot product equals the algorithm of a word's probability of co-occurrence. These approaches leverages global statistical information to produce meaningful word embeddings. Summary: word to wake a neural networks based model that learns embedding by predicting word context using skip grams or target word using CBW. Skipruns predicts context word from a given target word, focusing on capturing the use of words in different contexts. CBW predicts a target word from its surrounding context word, capturing the summary of context in which a word can appear. Globe learns word vector by factorizing a word co-occurrence matrix, incorporating global statistical information from the entire text corpus. This model and technique are fundamental in creating effective word embedding that are utilized in various NLP tasks, enhancing the performance of model by providing rich and contextual ever word representation. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about properties of word embedding. It's mentioned over here as word similarity. Word with similar meaning have similar embeddings. Semantic relationships. Embedding vector captures semantic relationships such as synonyms and antonyms. Analogies. Word embeddings can be used to solve analogy tasks like king minus man plus woman equals to queen. Pre-trained word embeddings, word embedding models. Pre-trained word embeddings are available for download. Train on large corpora of text data. Word to make. Pre-trained models trained on a large corpora such as Google News. Globe. Pre-trained word vector trained on Wikipedia or Common Crawl. Fast text, word embedding that consider subword information. Based on these mentioned details, we can say that word similarity refers to how closely related the meaning of two words are. In the context of word embedding, similar words are represented by vectors that are close to each other in embedding space. Example, consider the words happy and joyful. If we use a word embedding model like word to wake or glow, those words will have vectors that are very close to each other because they share similar meaning. Conversely, happy and sad would have vectors that are further apart due to their opposite meaning. Visual example, imagine a 2D space where each word is a point. Happy might be at zero point 0.7, zero point 0.8. Joyful might be at zero point 0.8, zero point 0.7. Sad might be at minus zero point 0.7, minus zero point 0.8. The Euclidean distance between happy and joyful is a small indication similarity. Semantic relationship word embedding capture various semantic relationships. This means that they can repeat both synonyms and antonyms as well as more complex relationship between words. Example, synonyms big and large with have similar vectors. Antonyms big and small will have vectors that show their opposite, but not necessarily close to each other. Contextual relationship doctor and hospital might have a relationship showing that they are contextually related. Visual example in a high dimensional space, vector or doctor and hospital might be aligned in a way that reflect their co-occurrence in medical context. Analogies are about finding a word that related to given word pair in the same way another word related to the second word pair. Word embeddings can solve those tasks by using vector arithmetic. The famous example king minus man plus woman equals to queen illustrate this. The vector for king minus for vector for man give a vector that represent the concept of royalty. Adding the vector for woman to this result yield a vector close to queen. Visual example like let's denoted the vector as follow. King, we king. Man, we man. Woman, we woman. queen. The relationship can be written as V king minus V man plus V woman near equal to V king minus V man plus V woman equals to V queen. Practical example like let's take another example using word to vec. Paris minus France plus Italy equals to Rome. Vector arithmetic V Paris minus V France plus V Italy near about V Rome. Application synonym detection, thresholds creation, context aware spell checkers, contextual search engine, sentiment analysis, sentiment text similarity, example finding similar documents. Analogies, language translation, automated reasoning, knowledge based completion. Summary, measure how close to word are in meaning using their embedding vectors. Capture the various relationship between words beyond mere similarity including context based relationship. Analogy solve analogy problem by leveraging vector arithmetic to find words that fit given relationship pattern. Pretend word embedding an overview of different word embedding model. Let's explain each model and their unique characteristics. Word embedding models are a type of word representations that allow words with similar meaning to have a similar representation. Those embedding are typically pre-trained on large corpora of text and can download for various NLP tasks. Word to vec is a group of related words that are used to produce word embeddings. Those models are trained to map word into a vector space where words that share common context are located close to one another. Training data, pre-trained models are available that have been trained on large corpora such as Google News, about 100 million words. Mechanism. Word to vec uses two main approaches. Continuous bag of words predicts that the target word based on its context. Skip jumps predict the context word given the target word. Use cases. Word to vec embedding are commonly used for tasks such as word similarity, clustering, and text classification. Glove is another popular word embedding technique. It is based on the factorization of the word co-occurrence matrix, capturing global statistical information of corpus. Training data pre-trained vector are available that have been trained on large dataset like Wikipedia or Common Clause, a web corpus. Mechanism of globe using a matrix factorization approaches to learn word embeddings where the ratio of probabilities of co-occurrence of words in the corpus is preserved. Use case globe embeddings are widely used for semantic analysis, analogy tasks, and various NLP applications where capturing the global context is beneficial. The first text is an extension of a word-to-vec development by Facebook AI Researcher Lab. It takes into account the subword information which allows it to generate embeddings for words that were not seen during training out of vocabulary word. Training data fast text model are trained on large dataset can also be pre-trained on various corpora. Mechanism, unlike word to vec fast text, represents each word as a bag of character and engrams. This means that the vector of for a word is a made up of some of the vectors of its engrams. Use case fast text is particularly useful for language which rich morphology, handling misspellings, and generating embedding of or rear or out of vocabulary words. Predict a word from its context or vice versa. Train on large corpora like Google News, ideal for capturing local context. Factorized the word co-occurrence matrix trained on dataset like Wikipedia and common crawls capture global statistical information. Consider subword character enhance information useful for out of vocabulary word and language with complex morphology. Developed by Facebook AI researcher. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about using word embeddings. It's mentioned over here as integration with NLP models. Word embedding are used as input feature in various NLP models such as neural networks, recurrent neural networks, and convolutional neural networks. Transfer learning. Pretend word embedding can be fine-tuned or used as fixed feature in downstream NLP tasks. Example code using Genzim for word to wake code from Genzim.model import word to wake sample corpus equals to in between third bracket the quick brown fox jumps over the lazy dog, the dog barks loudly. Train word to wake model equals to word to wake sentence equals to corpus vector size equals to 100 window is equal to 5 mean underscore count equals to 1 sg equals to 1. Get the embedding vector for a word print model dot wv in between bracket inverted comma dog. Find the similar word print model dot wv dot most underscore similar in between bracket dog. The output will look like some of the vector format. This is the embedding vector for the word like dog barks. There is a certain vector parameters. Loudly there is also certain vector parameters. The for the another vector parameters quick there is also for a vector format brown fox jumps so on. In this the code have a vector size specifics the dimensionality of a word vector window specific the context window size minimum count sets the minimum frequency of a word to consider and sg selected the training algorithm 1 for skips gram 0 for cbow. Based on these mentioned details, we can say that word embeddings are dense vector representation of words that capture their meaning, relationship, and context. Those embeddings are used as input feature in various types of neural networks model for different NLP tasks. Those network can use word embedding as input favorite for tasks like text classification or sentiment analysis. Example, a simple neural network might take the average of the embedding of all words in the sentence and use this vector to predict the sentiment of this sentence. Recurrent neural network RNN as well suited for sequential data and can capture temporal dependency in text. RNNs with the word embedding are commonly used for tasks like language modeling, machine translation, and text generation. In a language model, each word in a sentence is converted to its embedding and passes through the RNN to predict the next word in the sequence. CNN can capture local pattern and feature in the text data. Use case of CNNs with the word embedding are often used for tasks like text classification and sentence modeling. Example, for text classification, a CNN might take a matrix of word embedding for a sentence, apply convolutional filters to capture local n-grams feature and use those features for classification. Visual example, image in a sentence that the cat sat on the mat. Each word is converted to a embedding vector. Those vectors are fed into a neural networks, RNN or CNN, to perform the desired task such as prediction, the next word, or the classification, the sentiment of the sentence. Transfer learning in NLP involve using pre-trained word embedding in downstream tasks. Those embedding are pre-trained on large corpora and either be fine-tuned on specific task or used as specific feature. The pre-trained embedding are updated during the training of a downstream task. Fine-tune is useful when the downstream task has a sufficient amount of level data to further refine the embeddings. Example, fine-tune pre-trained model embedding on a specific domain. Example, medical text to improve performance on a medical text classification task using as a fixed feature. Description, the pre-trained embeddings are kept fixed as a directly as input feature without further updating. This approach is beneficial when the downstreaming task has limited level data and general purpose embeddings are sufficient. Example, using a pre-trained glove embeddings as fixed feature for text classification model in a low data scenario. Visual example like pre-trained embeddings, example word-to-way glove are downloaded. Those embeddings are used in a neural networks model for a new task, example sentiment analysis, name entity recognition. Depending on the approaches, the embeddings are either fine-tuned or used as fixed feature during the training of a new model. Word embeddings are used as input feature in various neural networks architecture, enhancing their ability to understand and the process of text data. Common model including feed-forward neural networks, RNN and CNN. Transfer learning is a pre-trained word embedding can be fine-tuned or used as a fixed feature in downstream. NLP task leveraging prior knowledge from the large corporate to improve performance on specific tasks. The Genzim library, specifically the word-to-vec class, is used to create and manage word-to-vec model. Preparing data, a small sample corpus is defined the sample of consistency of two sentences, each represent a list of words. The sentence including words like the quick brown fox, dogs, etc. Training the word-to-vec model is created a train using sample corpus. Key parameters for training including the size of a word vector set to 100 dimensions, the window size which determines how many words before and after a given word are considered for context, the minimum count of a word occurrence to be considered in the training set to 1 so all words are included. The use of a skip grams method for training which is effective for smaller dataset and capturing more semantic relationship. Getting embedding vector for word, the train model is used to retrieve the embedding vector for word dog. The vector is a numerical representation of a word in a 100 dimension space defined during training. The model is required to find words the most similar to dog based on their embedding vectors. The similarity is calculated based on the proximity of their vectors in an embedding space. In summary, this process involves loading and text corpus, training a vector of a word-to-vec model to generate the embedding and then using the model obtain word vector and find the similar vectors. Embedding vector for dogs, the first part of the output is a numerical array that represents the embedding vector for the dog is a vector is a high dimensional representation in case 100 dimensions that captures the semantic meaning of a word based on the context it appears in within the training corpus. Each number in the array corresponding to the specific dimension is the 100 dimensional space. List of similar words. The second part of the output is the list of tuples. Each contain a word and a similar score. Birds, the with the similar scores, this indicate that the birds is the most similar word to dog. In the training model, with the similarity score approximately 0.7732. Loudly, the word is also similar to dog with score approximately 0.6542. The word is a similar score of approximately 0.06224. Quick. The word has similarity score approximate 0.6130. Brown. The word has similarity score of approximately 0.6043. Fox. The fox has a similarity score of approximately 0.5864. Jumps word has a similarity score approximately 0.5843. Those similarity score indicate how closely each other dog word in dog based on their learned word embedding. A high score means a strong semantic similarity between the word. Here's an example of parameters using word-to-vec training model. The parameter specification dimensionality of a word vector, it determines the number of dimensions in which each word represent. For example, if a vector size set to 100, each word represent by a 100 dimensional vector. Higher dimensional can capture more nuanced meaning but also require more computational resource. Windows is the parameter defined as a context of window size. It defines the maximum distance between the current word and the predicted word within a sentence. For example, if Windows says site for 5, model will consider up to 5 word before and 5 of after the target word to predict the context word. A large window size can capture broader context while a smaller window size capture more local context. Mean count is the parameter that sets the minimum frequency of a word to consider. Words that appear less frequently than the minimum count value in the corpus will have ignored and not included the training. For instance, if mean count is set to 1, all the word in the corpus will consider. If the set to 5, only word that appear at least 5 times in the corpus are included. This help in ignoring rare word that might not be useful for training process. This parameter selected the training algorithm. It determines whether to the scheme grams model or the continuous bag of words model for training. Use the skipgrams model which predict the context word given a target word. This model work well with smaller dataset and capture rare word better. Uses the CBOW model which predict the target word based on the context word. This model is faster and work well with a large data set. So the sets how many numerical dimensions the word vector will have controls how many words around the target word are considered as context. Determines the minimum number of occurrence a word must be used including the training. Decided whether to use keepgrams or CWO training algorithm. These parameters help tailor to the word-to-vec model to specific need and characteristics of the training corpus. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about document embeddings. It's mentioned over here as document embeddings, also known as paragraph embeddings or document vectors, are dense representations of entire document in a continuous vector space. They capture the semantic meaning and the context of a document, enabling various natural language processing NLP tasks such as document classification, clustering, and retrieval. Here is an overview of a document embedding. Based on these mentioned details, we can say that document embedding is also known as a paragraph embedding or document vectors are a way to represent the entire document as numerical vector in a continuous vector space. Those embeddings capture the semantic meaning and the context of a document which allow them to be used effectively in various natural language processing tasks. Document embedding provide a dense, low-dimensional representation of text documentation, unlike sparse representation such as bag of words or TF-IDF, dense vector encoding information in compact for typically with hundreds of dimensions. By embedding a document into a continuous vector space, the model captures not just the frequency of a word but also their meaning and relationship within the document. This allows for a richer and more nuanced understanding of the document context. The vector space is continuous, meaning that the small similar documents are located near each other in the space. The proximity of a vector reflects the similarity in meaning and the context between the document. The document embedding can be used to classify document into predefined categories. For example, a classify can be trained on document vector to categorize news article into topics like sports, politics, and technology. Clustering is a similar document can be grouped together using clustering algorithms applied to their embedding. This is useful for organized large collection of documents such as grouping similar customer review or research papers. In the information of retrieval system, document embedding allow for more effective such as retrieval of document. A query can be embedded into the same vector space and document can be ranked by their similarity to the query vector. An extension of a word to vec, doc to vec, or paragraph vector learns fixed length feature representation from various length pieces of text such as sentence, paragraph, and document. TF-IDF weighted average, a simpler approaches involve averaging word embeddings weighted by their TF-IDF score. This method considers the importance of each word within the document. Models such as BERT, GPT, and the other transformer-based architectures can generate embedding for document by processing the entire text and capturing contextual information. Document embedding provides a way to represent the large text compactly, making it easier to handle and process large dataset. The capture of a semantic relationship between document and making it possible to perform sophisticated NLP tasks that require understanding of context and meaning. Those embedding are versatile and can be used for wide range of NLP tasks, improving performance in application like sentiment analysis, summarization, and recommendation system. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about purpose of document embedding. It is mentioned over here as representation document embedding represent the semantic context of entire document in a compact vector space. Dimensional reduction, they provide a low dimensional representation of a high dimensional document data. Semantic similarity document embedding enable measuring the semantic similarity between document. Technique for document embedding. Averaging word embedding, compute the average of word embedding in a document to obtain the document vector. TF-IDF weighted average weighted word embedding by their TF-IDF score before averaging. Doc to vec, an extension of a word vec, the learned fixed length vector representation for variable length pieces of text, paragraph, sentence, and documents. But viridianation encoding representation for transformers. Pre-trained language model that can be fine-tuned for various NLP tasks including document classification and similarity. Based on these mentioned details, we can say that document embedding represents the semantic context of entire document in a compact vector space. Document embedding are vectors that capture the meaning of the context of whole document unlike individual word embeddings which represent a single word. Document embedding provides us summary of an entire document context in a single vector. These vectors include information about the encapsulation the semantic context effectively by representing the document in a compact vector, it becomes easier to process the analyze large volume of text data computationally. Text data, when they represent in a traditional format like a bag of word or TF-IDF, can extremely high dimensional because each word in the vocabulary become a dimension. Document embedding reduce the complexity by mapping document into a lower dimensional space, including consists of a few hundred dimensions. This reduce the dimensionality, preserve the essential semantic information while discarding redundant or less important details. The result is more manageable and computationally efficient presentation of the document. Because of document embedding capture the meaning of a context of a document, they can be used to measure how similar two documents are in terms of their context. This is done by compare the respective vector in the embedding space. Technique such as coincident similarity or Euclidean distance can be used to quantify the similarity between two document vector space. High similarity score indicate that the document shares similar themes to topics, while low score suggests that they are different. The capability is crucial for tasks like clustering when the similar documents are grouped together and inform the retrieval where document relevant to query and rank and retrieved based on their semantic similarity. In this method, each word in the document represented as a word embedding vector typically obtained from a pretend word embedding model like Word2Vec or Glove. To obtain the document vector, the embedding of all words in the document are averaged component wise. TYDF weight averaging this method building upon the averaging word embeddings approach but add a weight factor based on TF-IDF from frequency inverse document frequency score. TF-IDF measure the importance of a word in a document relative to collection of document. Words that appear frequently in a document but rarely in the other document are given higher TF-IDF score. Instead of simple averaging the word embedding, each word embedding is multiplied by its TF-IDF score before leveraging. Word-to-vec paragraph is an extension of a word-to-vec model which learns fixed length vector representation for variable length pieces of text such as paragraph, sentence, or documents. Dog to wakes typically involves training a neural networks to predict word in a context window similarly to the word to wake, but it also learned a separate vector represented for each document. Those document vector capture the semantic meaning of the entire document and can be used for tasks like document similarity or classification. Word is a pretend language model based on the transformer architecture. Unlike word to wake or dog to wake, Bird consider the viridial context of word in a sentence, capture both preceding and the following word to understand the meaning of each word. Bird can be fine-tuned for specific NLP tasks like document classification, question answering, or name entity recognition. Document vector can be obtained from Word by feeding the entire document into the model and attract a fixed length of vector representation from one of the model's layer. Each of those method has its advantage and limitation, and the choice depends on the factors such as size of the dataset, computational resource available, and the specific NLP task at hand. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about training document embedding. Supervised learning. train document embedding in conjunction with a supervised NLP task such as document classification or sentiment analysis. Unsupervised learning learn document embedding from unlabeled text data using technique like word to vec. Properties of a document embedding: semantic similarity: document with a similar meaning have similar embeddings. Contextual information: document embedding capture the context and semantic relationship between word in the document. Generalization: document embedding generalize well to new document with a similar context. Based on these mentioned details, we can say that in supervised learning, the model learns to map input data to output data based on the label training data. When the training document embedding in a conjunction with a supervised NLP task like document classification or sentiment analysis, the model learn to generate document embedding that are optimized for the specific task. During training, both the document embeddings and the parameters of the model for the NLP task are adjusted to minimize a loss function which measure the disparity between the predicted output and the true levels. Supervised learning approaches for document embedding are useful when the level data is available for the task require learning representation that are tailored to specific the downstreaming the task. In this unsupervised learning, the model learn pattern and the structure from the input data without explicitly supervised or label. Example: learn document embedding from unlabeled text data using technique like word to vec falls under unsupervised learning. Word to vec learn to represent the document to continue the vector space by predicting the surrounding of context given the document itself. The model is trained to generate document embedding that capture the semantic meaning of an entire document with the rely on explicit labels or annotation. Unsupervised learning approaches for document embedding are valuable when the label data is scarce or expensive to obtain. They can be used for tasks like clustering, similarity, search, or the pre-trained representation for downstreaming tasks where label data is limited. Documents with a similar meaning are exposed to have similar embedding with a technique like word to vec, dog to vec, or bird. This similarity arises because of the word phrases appear similar context into similar embedding. Therefore, if two document contexts are the combination of two word phrases, their embedding are likely to be close in the in embedding space. The document embeddings, especially those generated by the model like BERT, capture not only the individual word but also their surrounding context within the document. This contextual information is crucial for understanding the nounced meaning of word and phrases in the different context. Document embedding are expected to generalize well to new document with similar context, especially when the training on the diverse and representation the dataset. This generalization ability to enable document embedding to useful for a wide range of downstream tasks such as document classification, clustering, or similar search, even when the specific document were not seen during a training. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about using document embeddings. It's mentioned over here as document classification. Use document embeddings as input feature for classifiers to predict document labels or categories. Document clustering. Cluster documents based on their embeddings to discover similar documents. Information retrieval. Compute similarity between query vector and document embeddings for document retrieval. Recommendation system use document embeddings to recommend similar documents or content to users. Example code using GenSim for doc2vec. Python code for gensim.model doc2vec import doc2vec, tag document sample corpus corpus equals to in between third bracket inverted comma, this is the first document dot inverted comma close comma, this is document is the second document dot inverted comma close comma inverted comma open, and this is the third one full stop inverted comma close comma inverted comma open, is this the first document question mark inverted comma close bracket close, preprocess the corpus tag underscore data equals to tag document in between bracket words equals to doc dot lower function dot split function comma tags equals to inverted comma string I inverted comma third bracket close for I doc in enumerate corpus train dog to wake model equals to dog to wake in between bracket vector underscore size equals to 100 window size equals to 5 minimum count equals to 1 epochs equals to 10 model dot build underscore vocab in between bracket tagged underscore data model dot training tagged underscore data comma total examples equals to model dot corpus underscore count comma epochs epoch equals to model dot epochs, get the embedding vector for a document vector equals to model dot infer underscore vector in between bracket inverted comma, this is a new document inverted comma close dot lower dot split function print vector, output will be 0.0136938 minus 0.034294005 0.04736962 third bracket close, this is the embedding vector for the new document. Based on these mentioned details, we can say that document embedding can be used as input feature for classifiers such as logistic regression, support vector machine, or neural networks to predict document labels or categories. By representing documents as dense vector in a continuous vector space, document embedding captures semantic information about the document's content. This allows classifier to learn discussion boundaries that separate documents into different classes or categories based on their semantic similarity or content. For example, in a semantic analysis task, document embedding could be used to classify document as positive, negative, or neutral based on the sentiment expressed in the text. Document embedding can also be used for clustering documents based on their semantic similarity. Technique like k-means clustering or hierarchical clustering can be applied to group document into cluster based on the distance or similarity between their embeddings. Documents that are close to each other in the embedding space are likely to be semantically similar while documents in different clusters are more dissimilar. Document clustering can be used for tasks like topic modeling where documents on similar topic are grouped together to discover underlying themes or pattern in the dataset. Information retrieval document embedding can be used to capture similarity between query vectors and document embeddings for document retrieval. When a user submitted a query, the query text can be converted into a query vector using the same embedding model used for generating document embeddings. By measuring the similarity between the query vector and the embeddings of document in a database, relevant document can be retrieved and ranked based on their similarity to the query. This approach is often used in search engines and information retrieval system to retrieve documents that are most relevant to a given query. Recommendation system document embedding can also be leveraged in recommendation systems to recommend similar document or content to user. By capturing similarities between the embeddings of documents, recommendations can be made based on documents that are semantically similar to those that a user has interact with. shown interest in. Document embedding can capture the underlying semantic of documents, allow recommendation system to recommend content that match user interested or preference. This approach is commonly used in content-based recommendation system where recommendations are made based on their content feature of item rather than explicit user item interaction. In summary, document embedding are versatile representation of document content that can be applied to various tasks such as classification, clustering, information retrieval, and recommendation system, enabling system to understand the process textual data effectively. Example of a code like Dog to Wake is an extension of the word to wake model that learn fixed length vector representation from variable length price of text, such as paragraphs, sentence, or documents. It was introduced by researcher at Google in 2024. Similarity to word to wake, like word to wake and dog to wake employs the skipgrams or continuous bag of words architectures to learn vector representation for words in a corpus. In the skipgrams architecture, the model predict the context words given the target word, while in CBOW it predict the target word given the context word. However, in addition to learn word embeddings, dot to vec also learn a fixed length vector representation, often refers to as a document vector or paragraph vector for each document in the corpus. Incorporating the document context, word2vec incorporates document context into the learning process by training each document as a special word in the training data. During training, the model is presented with a pair of context and target sequence where the context can including word from the document as well as the word from the surrounding context. The model learned to predict the target word given the context, including the document word, thereby capturing the semantic meaning of the entire document in the learned document vector. Two algorithm doc to wake including two main algorithm for generating document embedding PVDM distributed memory. This algorithm is similar to the CBOW model of word to wake. It predicts that target word given the context including the document words and learn document vector by treating them as additional context. PVDBOW distributed bag of word. This algorithm is similar to the skipgrams model of word to vec. It predicts word in the context window given the document vector, treating the document vector as a fixed feature. Training. During training, the parameter of the model, including word embeddings and document vector, are optimized to minimize a loss function, typically the negative log likelihood of prediction the context word given the target word or vice versa. Doc2Vec model are trained using stochastic gradient descent or similar optimization algorithm. Application document embedding generated by Doc2Vec can be used for various natural language processing tasks, including document classification, clustering, similarity search, and recommendation system. By representing documents as dense vector in a continuous vector space, Doc2Vec captures semantic information about the document content, enabling downstream tasks to operate effectively even with high dimensional and sparse document representation. In summary, Doc2Vec is a powerful technique for generating fixed length vector representations of documents, allow for effective model of document semantic and enabling a wide range of application in natural language processing and machine learning. Explanation of output in the embedding vector you can provide is a numerical representation of document obtained from a doc to vec model. These vector encapsulate semantic information about the document content in the continuous high dimensional space. The vector is a one-dimensional array of a number where each number represents a feature of dimension of the document embeddings. Each element in the array corresponds to a specific aspect of the document's semantic meaning of or context. These aspects are learned during the training of the dog-to-vec model. The length of the vector, example, the number of element typically corresponding to the chosen dimensionality of the document embedding when the model was trained. The values of an element in the vector encoding information about the document's context and relationship with the other document in the corpus. Interpreting the individual element of the embedding vector directly might not be straightforward as they represent the abstract semantic feature learned by the model. However, the vector as a whole can be used for various downstreaming tasks such as similarity search, document classification, or clustering. For instance, you can compute the similarity between the embedding vector and the other document embedding vector to find document with a similar context or context. Alternatively, you can use the embedding as input to a classifier to predict the category or level of document. This can be said after reading out this part. Now we will go to next particular discussion. Continuation of previous chapter. It's mentioned over here as in the code above, vector underscore size specifies the dimensionality of the document vector window, specifies the context window size, mean underscore count sets the minimum frequency of words to consider, and epoch sets the number of training epochs. The infer underscore vector method computes the embedding vector for a new document based on the trained doc to vec model. We can say that after reading out this part, these parameters specify the dimensionality of the document vector or the embedding that the doc2vec model will learn. In the provided code, snap vector underscore size equals to 100 indicate that the each document will represent by a vector of length 100. The window parameter defines the maximum distance between the current and predicted word within a sentence or context window. During training, the model considers word within this window around the target word to capture contextual information. In the code, window equals to 5 means that the model will consider 5 words before and 5 words after the current word when learning word embeddings. Mean underscore count, this parameter sets the minimum frequency of threshold for the word to be included in the vocabulary. Words that occurs less frequently than the specific mean underscore count values will be ignored and not included in the vocabulary. In the provided code, mean underscore count equals to 1 means that all words regardless of their frequency will be considered for training. The epochs parameter determines the number of iterations epochs over the entire corpus during the training. Each epoch involves presenting the training data to be the model for learn and updating its parameter. In the code snap, epochs equals to 10 specifying that the training process will be iterate over the corpus 10 times. Infer vector method. The infer vector method computes the embedding vector for a new document based on the trained doc2vec model. It takes a list of words as input representation, the new document, and return the corresponding document vector. This method is used to generate embedding for documents that were not part of this training data. In the code, model.infer underscore vector in between bracket inverted comma, this is a new document inverted comma close dot lower function dot speed function computes the embedding vector for a new document. This is the new document after converting to the lowercase and splitting it into an individual word. In the summary, provided code, initiate and train a dog-to-vec model with a specific parameter including dimensionality of document vector, vector underscore size, the context of window size, the minimum frequency of word to consider, mean underscore count, and the number of training epochs. It then use the train model to generate embeddings for new document using the infer vector method. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about text classification. It's mentioned over here as supervised learning for text classification in natural language processing NLP involve training machine learning model to classify text document into a predefined categories or levels. Here's an overview of the step involving in supervised learning for text classification. Data preparation, dataset, collect or create a dataset of label text document where each document is associated with one or most predefined categories or level. Preprocessing clean and preprocess the text data by removing noise such as HTML tags, punctuation, and stop word. Perform tokenization, stemming, lemmatization, and vectorization. Example using bag of word or TF-IDF to convert text into numerical feature. Based on these mentioned details, we can say that here is an overview of the step involving in the supervised learning for text classification in natural language processing. The first step in any supervised learning task is to collect a level data of text document. This dataset should consist of a collection of text document along with their corresponding labels or categories. The document can be obtained from various sources such as website, databases, or curated dataset. Once the dataset is collected, it needs to be preprocessed to make it suitable for training a machine learning model. Preprocessing step may be including tokenization, splitting the text into individual word or tokens. Lowercasing, converting all words to a lowercase to ensure consistency. Removing stop word, removing common words. Example the is that is do not contribute much to the meaning of the text. Stemming or lemmatization reduce the words to their base or root form to normalize the vocabulary. Feature extraction data cannot be directly used as input to machine learning algorithm. It need to convert it into a numerical feature. Common technique for feature extraction in NLP including bag of word representing each document as a vector of word counts. TF-IDF term frequency inverse document frequency weighting word count by their importance in the corpus. Word embeddings learn dense vector representations of words or documents using technique like word to vec or doc to vec. Model selection once the model feature are extracted, a machine learning model need to be selected for classification. Common model for classification including logistic regression, naive bias, support vector machine, decision tree, random forest, neural networks. Example, convolution neural network, recurrent neural network. Training the model after selecting the model, it need to train on the label dataset. During training, the model learned the underlying pattern in the dataset to make prediction. The model separate the adjusted iteratively using optimization algorithm to minimize the loss function that measure the disparity between predicted and true levels. Model evaluation once the model is trained, it need to evaluate to access its performance on unseen data. Evaluation metrics for text classification tasks including accuracy, precision, recall, F1 score and area under the curve, the ROC curve, AUC ROC. Cross validation techniques such as k-fold cross validation can be used to obtain more reliable estimates of the model's performance. Hyperparameter tuning are parameters that are not only learned by the model but are set before training. Hyperparameter tuning involves selecting the optimal values for those parameters to improve the model's performance. Techniques such as grid search or random search can be used to search the hyperparameter space and find the best combination. Once a satisfactory model is obtained, it can be deployed into a production for making prediction on new unseen text data. The deployed model should be monitored and periodically retrained to maintain its performance as the underlying data distribution may change over time. In summary, supervised learning for text classification involves collecting label data, prepose the text, extraction numerical features, selecting and training a machine learning model, evaluating its performance, tuning hyperparameters, and deploying the model for making prediction on new unseen data. This step involves gathering a dataset for text document where each document is associated with one or more predefined categories or level. The dataset can be collected from various sources such as online repository databases or manual level dataset. For example, if you are building a sentiment analysis model, you might collect a dataset of customer review level as positive, negative, or neutral. Pre-processing technique cleaning remove any noise from the text data such as HTML tag, special character or punctuation marks. This ensure that the text is clean in a standard format before further process. Then use tokenization to split the text into individual word or tokens. This step divides the text into meaningful units, make it easier to analyze and process. After that, we are doing lowercasing to convert all words to lowercase to ensure consistency in the text data. This prevents the model from treating words with different capitalization as string entities. To stop word removal, we need to use remove common words that do not carry much more meaning or significance known as stop word. Stop word including word like the, is and etc. which occur frequently in the text but do not contribute to overall meaning. Stemming and lemmatization reduce the word to their base or root form to normalize the vocabulary. Stemming involves removing suffix from the word to obtain their root form. Example, running become run. Lemmatization involves to reducing words to their canonical form based on their dictionary definition. Example, better becomes good. Vectorization converts the processed text into numerical features that can be used as input to machine learning model. Common technique for vectorization including backward representing each document as a vector of word count. TFIDF, term frequency inverse document frequency, weighted word count by their importance in the corpus. By performing those pre-processing steps, the text data is clean, standardized, and transformed into a format that is suitable for training machine learning model. This ensures that the model can effectively learn from the textual information and make accurate prediction or classification based on the input data. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about model selection. It's mentioned over here as choosing a model, selected a suitable machine learning model for text classification such as naive Bayes, logistic regression, support vector machine, decision tree, random forest, gradient boosting models, neural networks, example CNN, RNN. Feature engineering, feature representation represent text document as numerical feature vector using techniques such as bag of word, TF-IDF, word embedding or document embedding. Feature selection optionally perform feature selection technique, example chi-square test, mutual information to select the most relevant features for classification. Based on these mentioned details, we can say that each of those machine learning model and their suitability for text classification task Naive bias is a simple probabilistic classifier based on bias theorem with a strong independence assumptions between features. It is a particular well situated for text classification task, especially when the feature space is high dimensional, such as the bag of word or TF-IDF representation. NIB-bias model are computationally efficient and require relatively small amount of training data, making them suitable for large text dataset. Logistic regression is a linear model that estimates the probability of the binary outcome based on one or more independent variable. In the text classification, logistic regression can be used for binary or multi-class classification tasks. It is a simple and interpretable model that performs well when there is a linear relationship between the feature and the target variable. Logistic regression is easy to implement and interpret, making it popular choice for text classification, especially in scenario where interpretability is important. Support vector machine SVM is a powerful supervised learning algorithm used for classification and regression tasks. SVM finds the optimal hyperplane that separates the data point into different classes in a high dimensional space. SVM are effective for text classification tasks, especially when the feature space is space, such as with bag of words or TF-IDF representation, and when there is complex decision boundaries between classes. SVM can handle large feature space efficiently and are robust against overfitting. Decision tree are non-parametric supervised learning model that recursively partition the feature space into a subset based on feature values. They are intuitive and easy to interpret as they represent decision as a tree-like structure. Decision tree can handle both numerical and categorical data and are capable of capturing complex interaction between features. However, they are prone to overfitting, especially with the deep trees, and may not perform well on high dimensional data like text. Random forests are ensemble learning methods that build multiple decision trees during training and aggregate their prediction to make final classification. They improve upon the limitation of individual decision trees by reducing overfitting and increasing robustness. Random forests are suitable for text classification tasks where there are high dimensional feature space and the noisy data. The provided feature importance score, which can be useful for understanding which word contributed most to the classification. Gradient boosting models such as gradient boosting trees or XGBoost are ensemble learning technique that build a sequence of decision trees to improve model performance. They iteratively feed new models to the residuals of previous models, gradually reducing prediction errors. Gradient boosting models are powerful and often yearly state of the art performance on text classification tasks. However, they can be computationally expensive and may require more tuning compared to simpler models like nib bias or logistic regression. Neural networks, including convolution neural networks and recurrent neural networks, have gained popularity for text classification tasks due to their ability to learn complex patterns and representations for raw text data. CNNs are effective for tasks like sentiment analysis or text categorization, where local patterns in the text are important. RNNs include variants like long short-term memory (LSTM) and gated recurrent unit (GRU) are suitable for sequential data and tasks require modeling for long-range dependencies such as document classification or machine translation. Neural networks can handle large and complex datasets but may require substantial computational resource and data for training. Feature engineering is a bag of word text representation as a numerical feature vector by counting the occurrence of each word in a document. Each document is represented as a vector where each element corresponds to the frequency of a particular word in the vocabulary. Bag of word is a simple and effective but does not capture semantic relationship between words. TF-IDF represent text document as a numerical feature vector by weighting the word count based on their performance in the corpus. Words that are common in particular document but rare in the entire corpus are given a higher weight, indicating their significant. TF-IDF helps in reducing their influence of common words while highlighting the importance of rare words. Word embedding represents the word as dense low-dimensional vector in a continuous vector space. Those embeddings are learned from large text corpus using technique like word-to-vec, glove, or fast text. Word embedding captures semantic relationship between words, allows similar words to have similar representation in the embedding space. Document embedding represent entire text document as a dense vector in a continuous vector space. Those embedding can be learned using technique like doc2vec, which extend word2vec to learn document level representation. Document embedding captures the semantic meaning of the entire document, enabling downstream tasks like classification or clustering. Chi-square test is a statistical test used to determine the independence of two categorical variables. In the context of feature selection or text classification, it can be used to identify words that are most strongly associated with the class level. Words with high chi-square score are considered informative feature for classification. Mutual information measure that the amount of the information that one random variable in between bracket word occurrence contains about another random variable in between bracket class level. It quantifies the dependency between the word occurrence and the class levels. Words with high mutual information score are considered relevant feature for classification. Other technique feature selection technique including information gain ratio and feature importance score from the tree-based model like random forest or gradient boosting. Those techniques help in selecting the most informative and discriminative feature for classification, reducing the dimensionality of the feature space and improving model performance. In the summary, feature representation involves the transforming text document into a numerical feature vector using technique like bag of word, TF-IDF, word embedding or document embedding. Feature selection technique can then be applied optionally to select the most relevant feature for classification, reducing noise and improving the efficient and effectiveness of classification model. Those steps are crucial in preparing text data for machine learning model and extracting meaningful patterns and relationship from the text. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about model training. It's mentioned over here as splitting data, split the data set into training, validation and test set to evaluate the model performance. Training model, train the selected machine learning model on the training data, use techniques such as cross validation to tune hyperparameter and preventing overfitting. Evaluation matrix, choose an appropriate evaluation matrix for text classification such as accuracy, precision, recall, F1 score and area under the curve, ROC curve, AUC ROC. Model evaluation, validation, evaluate the trained model on the validation set to access its performance and make necessary adjustment. Hyperparameter tuning, fine tune the model hyperparameters based on validation performance to optimize classification performance. Final evaluation, evaluate the final model on the test set to obtain unbiased estimation of its performance. Based on these mentioned details, we can say that the dataset is typically divided into three subsets: training, validation, and test set. The training set is used to train the machine learning model, and the validation set is used to tune hyperparameters and monitor the model's performance during training and test set is used to evaluate the final performance of the trained model. The data splitting process should ensure that each subset is representative of overall dataset and maintain the distribution of classes across subset. Common splitting ratio including 60-20-20, 70-15-15 or 80-10-10 depending on the size of a dataset and the desired trade-off between training and evaluation set. Once the data is splitted, the selected machine learning model is trained on the training dataset. During training, the model learned the underlying patterns and relationship in the data to make predictions. Techniques such as cross validation can be used to access the model performance and generalize well to unseen data. Cross validation involves splitting the training set into multiple subsets in between bracket folds, training the model on each fold while using the remaining fold for validation, and averaging the performance matrix across fold. Hyperparameters such as regularization, strength, or learning rates can be tuned using technique like grid search or random search to optimize the model performance. Evaluate metrics are used to access the performance of the trained model on a evaluation or test set. Common evaluation metrics for text classification tasks including the proportion of correct classification instance of out of all instance, the proportion of true positive instance out of all instance predicted as positive, the proportion of true positive instance out of all actual positive instance. F1 scored the harmonic mean of a precision and recall, providing a balanced measure of the model performance. Area under the curve, ROC curve, the area under the receiver operating characteristics curve, which plots the true positive rate gains the false positive rate. Those metrics provided insights into different aspects of the model's performance, such as its ability to correctly classify instances of different classes, balance between precision and recall, and overall discriminative power. The choice of evaluation matrix depending on the specific requirements of the classification task, such as the importance of minimization, false positive, or false negative. Model evaluation after training the model on the training set, it's crucial to evaluate its performance on separate validation set. The validation set serve a proxy unseen data helps accessing how well the model generalize to unseen new data. The validation performance guide adjustment to the model architecture hyperparameter to or pre-processing step to improve overall performance. Hyperparameter tuning are parameters that given the to learn process of a model such as learning rate, regularization strength, or the number of hidden unit in a neural networks. Hyperparameter tuning involves searching for optimal combination of hyperparameters that maximize the model performance on the validation set. Technique such as grid search, random search, or Bayesian optimization can be used to systematically explore the hyperparameter space and find the best configuration. The goal is to find hyperparameters that balance model complexity and generalization performance, effectively optimizing the model for the specific task at hand. Once the hyperparameters are tuned based on the validation performance, the final model is evaluated on the test set to obtain unbiased estimation of its performance. The test set provides an independent measure of how well the model generalizes to unseen data. It's essential to avoid any adjustment to the model based on the test set performance to prevent overfitting to the test set. The test set evaluation given a realistic assessment of a model performance and its ability to make prediction on new unseen example. The evaluation matrix obtained the test set provided insight into the model's effectiveness and guided decision about the deploying the model in real world application. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about model deployment. It's mentioned over here as deployment. Deploy the trained model into a production for making prediction on new unseen text data. Monitor the model's performance over time and update it as needed to maintain its effectiveness. Feedback loop. Incorporate feedback from user to domain expert to continuously improve the model's performance. Example code using scikit-learn in between bracket logistic regression. Python code from scikit-learn dot model selection import train test split from sklearn dot feature extraction dot txt import count vectorizer from sklearn.linear underscore model import logistic regression from sklearn.matrix import accuracy underscore score split data into training and test set x underscore train x underscore test comma y underscore train comma y underscore test equals to train test split x comma y comma test underscore size equals to 0.2 comma random underscore state equals to 42. Initialize the count vectorizer equals to count vectorizer function feed and transform the training data x underscore train underscore vec equals to vectorizer dot feed underscore transform x train. Transform test data x underscore test underscore vec equals to vectorizer dot transform x underscore test. Initialize and train logistic regression model. Model equals to logistic regression function model dot feed in between bracket x underscore train underscore vec comma y underscore train. Make predictions y underscore pred equals to model dot predict in between bracket x underscore test underscore vec. Evaluate accuracy equals to accuracy underscore score x underscore test comma y underscore pred. Print accuracy in after inverted comma accuracy. The output will be look like something like this. Accuracy is 85. Based on these mentioned details, we can say that this is involved taking the training machine learning model and making operational in a production environment. This step including setting up the infrastructure needed for the model to receive input data, make prediction and return result. The deployment process ensures the model can handle real world data and the integrated into the application or service where it is needed. Once the model is deployed, it is crucial to continuously monitor its performance. Monitor involve tracking various metrics such as accuracy, latency, and error rates to ensure the model performance as expected. This step helps identify and degradation in performance over time due to changes in the data distribution or external factors. Regular monitoring will allow for timely updates and maintains to keep the model effective and reliable. Incorporate the feedback from the user or the domain expert is essential for continuous improvement of the model. This feedback can highlight an area where the model may be underperforming or suggested enhancing based on the real world uses. By integrating this feedback into the development process, the model can be retrained, fine-tuned and updated to improve its performance and better meet user needs. Example code using scikit-learn to provide code is a typical example of a machine learning workflow for text classification using the scikit-learn library in Python. Here's a step of explanation of what each part of the code does. Train this split from sklearn.model selection. This function used to split the dataset into training and testing set. Count vectorizer from sklearn.feature underscore extraction dot text. This tool converts a collection of text document to a matrix of token counts. Logistic regression from sklearn.linear model. This is the machine learning model used for classification. Accuracy underscore score from scalar.matrix. This function calculates the accuracy of the model prediction. Splitting data. The dataset X features and the Y levels are split into training and testing sets. 80% of the data is used for training X underscore train and Y underscore train, and the 20% is used for testing X underscore test and Y underscore test. The random state parameter ensures the reproducibility. Initializing the count vectorizer is initialized to convert the text data into a format that can be used by the machine learning model. It is essential to create a matrix where each row represents a document and each column represents a unique word from the entire sets of documents. Fitting and transforming training data. The fit underscore transformer method of count vectorizer is applied to the training data x underscore train to learn the vocabulary and converted the training text data into a matrix of token counts x underscore train underscore wake. Transforming test data. The transform method is used on the test data x underscore test to convert it into the same matrix format using the learned vocabulary from the training dataset x underscore test underscore wake. Initializing and training logistic regression model. A logistic regression model is initialized and trained using the vectorization training data x underscore train underscore vec and the corresponding labels y underscore train. Making prediction. The train model is used to make prediction on the vectorized test data x underscore test underscore vec, resulting in the predicted models y underscore train. Evaluation accuracy. The accuracy of the model prediction is evaluated by comparing the predicted levels y underscore pred with the actual levels y underscore test using the accuracy underscore test function. This result is printed to show the model performance. In summary, this code demonstrates the process of splitting the data, transforming text into a numerical format, training a logistic regression model, make prediction and evaluate the model accuracy. This can be said after reading out this part. Now we will go to next particular discussion. This is the continuation of previous chapter. It's mentioned over here as in the code above, X represent the future matrix of text data, Y represent the target labels, and count vectorizer is used to convert text data into numerical features vector. The logistic regression model is trained on the training data x underscore train underscore wake, comma y underscore train. The evaluated on the test data x underscore test underscore wake, comma y underscore test. Finally, the accuracy of the model is computed using scikit-learn's accuracy score function. Based on these details, we can say that X represents the future matrix which consists of the text data that will be used as input for the machine learning model. Y represent the target labels which are the output classes or categories that the model will learn to predict. Count vectorizer is a tool from scikit-learn that transforms the text data into a numerical feature vector. It converts the text into a matrix of token counts where each row corresponding to a document text instance and each column corresponding to a unique word from the entire set of documents. Training and testing data. The dataset is split into training and testing set. The training set is used to train the logistic regression model. The test set is used to evaluate the model performance on unseen data. Logistic regression model is initialized and trained using the vectorized training data x underscore train underscore wake and the corresponding target levels y underscore train. The model learned the relationship between the input feature, word counts, and the target levels during this training process. Evaluation. After training, the model is used to make prediction on the vectorized test data x underscore test underscore wake. The accuracy of this prediction is calculated using the accuracy underscore function from the scikit-learn. This function compares the prediction levels with the actual levels to determine the proportion of correct prediction. In summary, the explanation highlights the following step: converting the text data into numerical feature using count vectorizer, splitting the data into training and testing sets, training a logistic regression model on the training data, evaluate the model performance on the test data by computing its accuracy. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about deep learning for text classification. It's mentioned over here as deep learning for the text classification involve using neural networks architecture to automatically learn hierarchical representation of text data for classification tasks. Here's an overview of how deep learning can be applied to text classification. Word embeddings, word representation, convert word into dense vector representations using pre-trained word embeddings, example, word to wake glow, or learn word embeddings from scratch using embedding layers in neural networks. Capturing semantic words embedding capture semantic relationship between word allow the model to understand the meaning of the word in the context of the task. Based on these details, we can say that deep learning for text classification involve using neural network architecture to automatically learn hierarchical representation of text data for classification tasks. Here is an overview of the process. Text pre-processing is breaking down the text into individual word or subword in tokens. Converting text to understand formats such as lowercasing, removing punctuation, and handling special character. Stop word removal, eliminating common words that may not be contributed significantly to the meaning, like and, the, etc. Optional based on the model. Stemming lemmatization reduce word to their base or root form optional. Text representation converting tokenize into dense vector that capture semantic meaning popular method including produce vector representation of the word by training on a large corpus. Globe learn word vectors by aggregating global word co-occurrence statistics familiar to word to wake but include subword information to handle out of vocabulary word. Pre-trained embedding using pre-trained embedding like those from word GPT or other large scale model. Neural network architecture effective for capturing local patterns in text by applying convolutional filters over word embeddings can detect n-grams feature and hierarchical patterns. Good for sequential data as they maintain information about previous word in the sequence. Variants like LSTM long short-term memory and GRU graded recurrent units are used to handle long-range dependencies and mitigate the vanishing gradient problem. Attention mechanism and transformer allow model to focus on different parts of the text, selective providing better context handling. Transformer completely rely on self-attention mechanism enabling parallelization and handling longer context efficiently. Models like BERT and GPT are based on transformer architecture and have achieved state-of-the-art result in many text classification tasks. Model training dividing data into training validation and test set. Typically categorical cross entropy is used for multi-class classification. Optimizer algorithms like ADAM, RMS from or SGD are used to minimize the loss function and update model parameters. Regularization technique like dropout, weight decay or early stop to prevent overfitting. Evaluation model performance using metrics like accuracy, precision, recall, F1 score, ROC, AUC, etc. Confusion metric to understand the type of errors the model is making Deployment and monitoring integrate the trained model into a production environment where it can process new text data and make prediction. Monitoring continuously monitoring the model performance in real world setting to ensure its maintain accuracy and relevance over time. Retraining may be required as new data become available or data distribution changes. In summary, deep learning model for text classification leverage neural network to automatically learn and extract feature from the new text data, achieving higher performance and flexibility compared to traditional method. The key step involve pre-processing text representation, choosing appropriate neural networks architecture, training, evaluation, and development. Word embedding and word representation, dense vector representation word in text are converted into numerical format as dense vector, example vector where most elements are non-zero. That can be produced by neural networks method pretend word embedding. The method developed by the Google create word embedding by training on a large corpus of text. It's used either the continuous bag of words or skip grams model to predict word given the context or vice versa. Globe development by Stanford Globe creates the word embedding by analyzing word co-occurrence statistics from a large corpus. It results in word vector that capture global statistical information. First text, an extension of a word2vec developed by a Facebook, it represents words as bags of character and engrams, which helps in handling rare words and those not seen during training. Out of vocabulary word. Learning embedding from a sketch when training a neural network for a specific task, embedding layer can be used to learn word embedding directly from the training data. This allows the embedding to be tailored to the specific task and dataset. Capturing semantic relationship word embedding are designed to capture the semantic meaning and relationship between words. For example, words with similar meaning are placed closer together in the vector space. Contextual understanding word embedding are trained to understand the context in which word appears. This means the vector are not just random or arbitrary, but reflected the meaning and the uses pattern of word in a given language. Analogies a common way to demonstrate the power of a word embeddings in through analogies. For example, in a well-trained embedding space, the vector operation king minus man plus woman should result in a vector close to queen. Benefits in a text classification by converting word into dense vector neural network can process the text data more efficiently and effectively. The embedding enable the model to capture complex pattern and relationship within the text. Transfer learning pre-trained embedding like word2vec and Glove can be used to leverage large amount of external data, improving the model's performance on tasks with limited training data. Contextual understanding the embedding helps the model to understand the meaning of word in context, which is crucial for tasks like sentiment analysis, topic classification, and name entity recognition. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about convolutional neural networks CNN. It's mentioned over here as fixed convolutional apply convolutional operation over word embeddings to capture local patterns and feature in the text. Pooling layers use pooling layers example max pooling to downsampling the output of convolutional layers while preserving important features. Hierarchical feature extraction, stacking convolutional layer, learn hierarchical representation of text data, capturing both local and global features. Recurrent neural networks and long short-term memory, sequential modeling RNN and LSTM process text data sequentially, allow them to capture sequential dependencies and long-term dependencies in the text. Temporal encoding RNNs and LSTM maintain an internal state that encoded information about the previous word in the sequence. Attention mechanism In RNN and LSTM, focus on relevant parts of the input sequence, improving performance on long text. Based on these mentioned details, we can say that convolutional operation involve applying convolutional filter over the word embedding of the text. Those operations help to capture local pattern and feature within the text. A convolutional filter sites over the input text represent as word embeddings perform element-wise multiplication and summing the result. They produce the feature map that highlights certain patterns or feature in the text. For instance, a filter might learn to detect bigrams or trigrams sequence of two or three words that are significant for the classification task. Pooling layers are used to downsampling the output of a convolutional, reducing and spiral dimensions with height and weight of the feature maps. Types max pooling the most common types which selected the maximum value from the set of values in the feature map. This helps to retain the most important feature while reducing the size of the data. Pooling reduces the computational load and the number of parameters in the model, making it more efficient. Feature preserving by keeping the most prominent features pooling layers ensure that important information is not losing during the downsampling process. Variance pooling provides some degree of translation invariance, meaning the model can categorize patterns regardless of their position in the input text. CNNs offer use multiple convolutional layers stacked on the top of each other to learn increasingly complex features. This initial convolutional layer focuses on capturing local patterns such as specific engrams or short phase. As the data phases through more layers, the models start to capture more abstract and global features, such as the overall structure or sentiment of the text. Each layer in the CNN build upon the feature learning by the previous layer, creating a hierarchical of features. The hierarchical learning process allows the model to understand both fine-grained details and broader patterns within the text. In summary, using CNN for text classification involves three key steps. Text convolution, applying convolutional filter over word embeddings to capture local pattern and feature in the text. Pooling layer, using pooling layers such as max pooling to downsample the feature map while preserving important features. Hierarchical feature extraction, stacking multiple convolution layers to learn hierarchical representation of the text data, computing both local and global features. Those processes enable CNN to effectively analyze classified text by progressively extracting and combining relevant features at different level of abstraction. Recurrent neural network and long short-term memory. Let's break down the key component of sequential model, temporal encoding and attention mechanism in the context of recurrent neural networks and long short-term memory networks. Sequential model involves processing data in a specific order, step by step. This is particularly important for the text data where the order of the words significantly affected meaning of sentence. RNN are designed to handle sequential data. They process one element of a sequence at a time while the maintaining an internal memory that captures the information about previous element. Function at each step, and RNN takes the current input and the hidden state from the previous step to produce the current hidden state. This allows the RNN to remember information from earlier in the sequence. Temporal encoding refers to the process of maintaining information about the order and timing of inputs. In this context, RNN and LSTM, this is done using the hidden state. The hidden state acts as a dynamic memory that gets updated at each step of a sequence. It captures information about the sequence up to the current point. RNN challenges standard RNN struggle with the long-term dependencies due to issue like vanishing gradients, which make it more difficult to maintain relevant information over long sequence. Long short-term memory network (LSTM) are specially kind of RNN designed to better capture long short-term dependencies. Structure and function LSTM introduce memory cells that can store information across many time steps. Those cells are controlled by a gates, input for gate and the output gates that regulate the flow of information. Control how much of a new input should be added to the memory cell. Decided how much of the exist memory should be retained. Determines how much of a memory cells contained should be output to the current step. By effectively managing those gates, LSTM can preserve important information over longer sequence, addressing the limitation of the standard RNN. Attention mechanism enhance the performance of RNN and LSTM, especially when detailing with long text or sequential. Instead of processing the entire sequence uniformly, attention mechanism allow the model to focus on specific part of the input sequence that are more relevant to the current context. Calculation: the attention mechanism calculate a set of attention weight that highlighted the importance of each element in the sequence relevant to the current processing step. Those weights are then used to create weighted sum of the input element which provide a context vector. This context vector helps the model make more informed decision by the emphasize the most relevant part of the input sequence. By focusing on relevant part of the input, attention mechanism help RNN and LSTM handle long short sequence more effectively, leading to the better performance on in tasks like machine translation, text summarization and more. Sequential modeling: RNN and LSTM process the data sequential, maintaining an internal state to capture dependencies. Temporal encoding: the internal state encoding information about the previous word, helping the model understanding the sequence. Attention allow the model to focus on important part of the sequence, improving performance on tasks involving long text. Those elements collectively enable RNNs and LSTM to understand and generate complex sequence of a text by capturing both short-term and long-term dependencies. This can be said after reading out this part. Now we will go to next particular discussion. This part we will be discussing about transformer based model. It's mentioned over here as self attention mechanism. Transformer model example BERT GPT use self attention mechanism to capture global dependencies and relationship between word in the text. Contextualize embedding: transformer model produce contextualize word embedding that capture the meaning of the word in the context of the entire document. Pre-trained transformer model can be fine-tuned on specific text classification tasks, achieving taste of the art performance with the minimal task specific data. Model training: data preparation: prepare the text data by tokenizing, padding, sequence, and converting them into a numerical representation. Model architecture: choose an appropriate neural network architecture CNN RNN transformer for the text classification task. Loss function: using appropriate loss function, example cross entropy loss for classification task. Optimization: train the model using optimization algorithms such as ADAM, RNSPROM, or SGD with appropriate learning rates and regulation technique. Based on these mentioned details, we can say that self-attention mechanism contextualize embedding and pre-trained model in the context of transformer models such as BERT and GTP. Self-attention mechanism is a core component of a transformer model, allow them to capture global dependencies and relationship between word in a text. Self-attention calculate attention score for each pair of word in the input sequence. Those score determines how much focus each word should have on every other word. By considering all words in the sequence, simultaneously self-attention can capture relationship regardless of their distance from each other in the text. The process involves creating three vectors, query, key, and values. For each word, the attention score for a word pair is obtained by taking the dot product of the query and the key vector. Following the softmax operation to the normalize the score, those score are then used to weight the value vector, producing a contextually aware representation of each word. Contextualized embedding transformer models generate contextualized word embedding which capture the meaning of a word in the context of an entire document rather than treating each word in isolation. Unlike traditional word embedding, example word to vec, globe, which assigned a fixed vector to each word regardless of a context, contextualized embedding vary depending on the surrounding word. Rich representation, this context aware representation allow the model to distinguish between different sense of a word and understand nounced meaning based on the context. Pre-trained model, transformer model is like bird and GPT have been trained on large corpora of text and can be fine-tuned for specific tasks. Pre-trained involve training a model on a broad dataset to learn general language representation. Those models can be fine-tuned on smaller task specific dataset, significantly improving performance with minimal additional data. State of the art performance pre-trained model achieving high accuracy on various NLP tasks, example text classification, sentiment analysis, and question answering because they have already trained rich generalizable feature from the large scale pre-trained phase. Fine-tune the pre-trained model is further trained on a specific dataset tailored to a particular task. This process adjusts the model weight silently to optimize performance on the new task. Efficiently fine-tuned require most less data and computational resource compared to the training a model from scratch, making it an efficient approach to achieving high performance on specific tasks. Model training in preparing text data and setting up a neural network for text classification. Tokenization is the process of splitting text into individual units such as word, subword, or character. It transforms the raw text into a format that can be processed by a neural network. Tools are used for these library like NLTK, sparse UI, or tokenizer specific to the model like BERT, example word, piece, byte, pair encoding. Pattern sequence involve adjusting the length of tokenized sequence so that they are all the same length. Purpose of neural networks often require input sequence of the same length for efficient batch processing. Implementation shorter sequence are padded with a special token example pad while longer sequence are truncated. Converting to the numerical representation, this step involves mapping each token to numerical values. Neural network operate on numerical data, so text data must be converted to numbers. Written embedding like word to vec, globe map, words to dense vector. Each unique tokens is assigned an index in a vocabulary list. Good for capturing local patterns and spiral hierarchy in text data. Can be used for sentence classification tasks where n-grams feature are important. RNN suitable for the sequential data where data matters capturing temporal dependencies including LSTM and GRU which handle long-term dependencies better. excellent for the capturing global dependencies and relationship within the text. Example model like BERT and GPT, which use self-attention mechanism. Measure the difference between the true level distribution and the predicted probability distribution. Use commonly used for classification tasks as it's penalize incorrect prediction more heavily when the predicted probability is far from the true level. Combines the benefit of both aggregate and RMS from adjusting learning rates based on the first and second moment of gradients, widely used due to its effectiveness and efficiency. Adam draw the learning rate for each parameter useful for handling non-stationary object, often used in deep learning application. Simple and effective, especially with the large dataset, can be enhanced with the momentum or learning rate schedule. The learning rate determines the step size during each update of the model rate. Proper tuning is crucial for converging to high can cause overshooting, to low can lead to slow convergence. Regularization technique purpose to prevent overfitting and improve generalization method randomly zeroes out numerous during the training to prevent rely on the specific neurons. Added a penalty to the loss function proportional to the squared value of a weight. Tokenize text into manageable unit, pad sequence to ensure uniform length, convert text to numerical representation for neural network processing. Choosing a suitable architecture, CNN, RNN transformer based on the nature of the text classification task. Use cross entropy loss for classification tasks to measure prediction accuracy. Training the model with the optimization algorithm like ADAM, RMS from or SGD. Set appropriate learning rates. Apply regularization technique like dropout or L2 regularization to improve model generalization. By following those steps, you can effectively prepare text data and set up a neural network model for text classification tasks. This can be said after reading out this part. Now we will go to next particular discussion. In this part, we will be discussing about model evaluation and fine tune. It's mentioned over here as validation set. Evaluate the training model on a validation set to monitor performance and prevent overfitting. Hyperparameter tuning, fine tune hyperparameters such as learning rate, batch size, and the model architecture based on the validation performance. Early stop to prevent overfitting by monitoring validation loss and stop trend when it start to increase. Example code using TensorFlow keras. Python code import TensorFlow as ETF from TensorFlow.keras model, import sequential from TensorFlow.keras.layer, import embedding convod 1D, global max pooling 1D dense, define CNN model equals to sequential in bracket embedding look vocab underscore size, embedding underscore dimension, comma input underscore length equals to max underscore length. Convo 1D in between bracket filter equals to 128, comma kernel size equals to 5. Activation equals to value global max pooling 1D function tens in between bracket 10 activation equals to value tens equals to 1, comma activation is equal to sigmoid matrix in between bracket accuracy train model dot feed x underscore train comma y underscore train epochs equals to 10 validation underscore data in between bracket x underscore val comma y underscore val evaluate matrix loss accuracy equals to model evaluation between bracket x underscore test y underscore test print test loss print test accuracy accuracy. The output is the test loss 0.35, accuracy 0.85. Based on these mentioned details, we can say that a validation set is proportional to the data set that is set aside during training to evaluate the model performance. It serves an unbiased measure of how well the model generalizes to unseen data. Monitoring performance by evaluating the model on a validation set during training, you can monitor its performance and detect issues like overfitting. Hyperparameter tuning, the validation set helps in tune hyperparameter and selecting the best performing model configuration. Splitting data, the dataset is typically divided into training, validation, and test set. The training set is used to train the model. The validation set is used to tune the hyperparameter, and the test set is used for final evaluation. Evaluation metrics, common metrics for evaluation model performance on the validation set, including accuracy, precision, recall, F1 score, and area under the curve, ROC curve. AUC ROC depends on the nature of the classification task. Hyperparameters are parameters that are set before the training process begins, such as learning rate, batch size, and the model architecture. Hyperparameter tuning involves finding an optimal values for those parameters to improve model performance. Optimization proper tuning hyperparameter can significantly improve the model performance and convergence speed. Generalization well-tuned hyperparameter help the model generalization better to unseen data, reducing the risk of overfitting. Grid search excessively search through a predefined set of hyperparameter combination. Random search is sample hyperparameter combination for predefined range. Early stop is the regularization technique used to prevent overfitting by the model training process when the model performance on the validation set start to degrade. Used to monitor model performance and prevent overfitting during training helps in tuning hyperparameter and selecting the best performance model configuration. Hyperparameter tuning involves optimal values and hyperparameters to improve model performance and generalization. Technique including grid search, random search, and Bayesian optimization. Early stop or regularization technique used to prevent by stopping training process within the model performance on the validation set deterioration. Monitor the validation loss and stop the training when it starts to increase the consistently. Example of code using the TensorFlow. Import library TensorFlow is import as TF and specify the model from the TensorFlow.keras are imported. Sequential model allow you to create new layer by layer sequential. During the CNN model, the model architecture is defined using sequential by stacking layer. Embedding layer is the first layer which converts input text into dense vector of fixed size. Embedding dimension and maps each word to high dimensional vector space. Convo 1D layer applies one dimensional convolution operation across the sequential to capture local patterns. Global max pooling 1D layer perform max pooling operation across the entire sequence, extracting the most important features. Dense layer are fully connected layer with a specific activation function. The last layer has a single neuron with a sigmoid activation function for binary classification. The model is compiled using the compile method, specifying the optimizer in this case Adam loss function binary cross entropy for binary classification and evaluation matrix accuracy to monitor model performance during training. The feed method is used to train the model on the training data x underscore train, y underscore train for a specified number of epochs in this case. The validation data x underscore val, y underscore val is provided to evaluate the model's performance after each epoch to prevent the overfitting. This can be said after reading out this part. Now we will go to next particular discussion. This is the continuation of previous chapter. It's mentioned over here as in the app code above vocab size, embedding dimension, and max length are hyperparameter representing vocabulary size, embedding dimensionality, and maximum sequence length. Respectively, the CNN model is defined with embeddings. Convolutional. pooling, and dense layer, following by compilation, training, and evaluation steps. Based on these mentioned details, we can say that vocab size represent the size of vocabulary so that the total number of unique words in the dataset. Specifies the dimensionality of the embedding vectors. Each word in the vocabulary will be represented as a dense vector of this size. Max length denotes the maximum length of input sequence. Text sequence longer than this length will be truncated and shorter sequence will be padded to match this length. CNN model is constructed using sequential API from Keras which allow for creating model layers by layers sequentially. The model comprises several layers embedding converts input text into dense vector of fixed size embedding underscore dimension and maps each word to high dimensional word space. This layer is crucial for representing word in a continuous vector space, capturing semantic relationship. Convo 1D applies one-dimensional convolutional operation across the sequence. This layer is effective in capturing local patterns in the text data similar to image processing convolutional filter. Global max pooling 1D perform max pooling operation across the entire sequence, extracting the most important features. This layer helps in reducing the dimensionality of the feature representation while retraining the most relevant information. Dense fully connected layer with a specific activation function. The last dense layer has a single neuron with a sigmoid activation function suitable for binary classification task. Compilation, the model is a compile using the compile method where the optimization loss function and the evaluation matrix are specified. Optimizer equals to Adam indicates the Adam optimization algorithm which is an efficient gradient based optimization algorithm. Loss equals to binary cross entropy specifies the loss function and used during training for binary classification task. Binary cross entropy is commonly used. Matrix equals to accuracy defines the evaluation matrix to monitor during training. In this case, accuracy is used to measure the model's performance. The fit method is called to train the model on training data x underscore train y underscore train for specified number of epochs, in this case train. Validation data x underscore val y underscore val it provided to evaluate the model performance after each epoch and prevent overfitting. After training, the model performance is evaluated on the test data x underscore test y underscore test using the evaluate method. The test loss and the accuracy are printed to access the model performance on unseen data. In summary, this code snap demonstrates the construction, compilation, training, and evaluation of the CNN model for text classification with the necessary hyperparameter specification for configuration, the model architecture, and training process. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about name entity recognition, NER, and parts of speech POS tagging. Lesson 1, Introduction to NER and POS tagging. It's mentioned over here as name entity recognition, NER, and parts of speech POS tagging are essential tasks in natural language processing NLP that involve analyzing and categorizing word within text. Based on these mentioned details, we can say that name entity recognition and parts of speech tagging are fundamental tasks in natural language processing that involve analyzing and categorizing words within a text to extract valuable linguistic information. Name entity recognition is the process of identifying and classifying name entities such as name of person, organization, location, date, etc. within our text. The task involved identifying span of text that represent entities and categorizing them into predefined categories. Information extraction in here helps in extracting relevant information from text such as identifying key entities in new articles, research paper or social media post. Entity linking in here facilitating linking recognized entities to knowledge base or database, enabling deeper understanding and analysis of text. Example in the sentence Apple Inc. is a headquarter in Cupertine, California. Any would identify Apple Inc. as an organization and Cupertino, California as a location. Rule-based system utilize predefined rules and patterns to identify name entities based on linguistic features. Machine learning models train supervised model example conditional random field build LSTM CRF on annotated data to predict name entity labels. Parts of speech tagging is a small process of assigning grammatical categories such as noun, verb, adjective, etc. to the word within a text. Each word in the text is assigned as pause, tag indication, its semantic role and function within the text. Semantic analysis pause tagging provides insight into a grammatical structure of a sentence, facilitating semantic analysis and understanding. Semantic analysis POS tag can be used to disambiguate word meaning and resolve ambiguity in language. In sentence, the quick brown fox jumps over the lazy dog. POS tagging would assign tags like DT determined to the JJ adjective to the quick NN noun to fox and so on. Approach is rule-based system employ handcraft rule and linguistic pattern to assign POS tags based on word context and morphology. Machine learning model, trained supervised model, hidden Markov models, conditional random fields, neural network on annotated data to predict POS tag. Importance in NLP, NER and POS tagging are essential components of many NLP applications, including information extraction, identifying name entities and their relationships from understand text, question answering, understanding the semantic structure of questions and document to extract relevant answer. Machine translation improves translation quality by considering POS information and name entities. Sentiment analysis analyze sentiment based bearing entities and their associated sentiment in text data. In summary, entity recognition and personal speech tagging play a crucial role in NLP tasks by providing valuable linguistic information about entities, grammatical structure, and word role within text data. They serve as fundamental tasks in various NLP applications, enhancing the understanding and analysis of natural language text. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about named entity recognition NER. It's mentioned over here as definition. Named entity recognition is the process of identifying and categorizing name entities. Example: person names, organization names, locals date within a text. Purpose: NER helps in extracting structured information from unstructured text data, enabling various downstream NLP tasks such as information extraction, question answering, and entity linking. Example in the sentence Apple is headquartered in Cupertino, California. NER would identify Apple as an organization and Cupertino, California as a location. Approaches NER can be approached using rule-based method, statistical method, example, conditional random fields, or deep learning technique, example, bidirectional LSTMs transformer. Based on these mentioned details, we can say that name entity recognition is a key task in NLP process that involve identifying and categorizing name entities within a text. Linear is a process of location and classifying name entities within a text into predefined categories such as person name, organization name, location, dates, etc. The purpose of linear assist in extracting structured information from unstructured data by identifying and categorizing name entities. Downstream NLP tasks, the output of NER can be used as input for various downstream NLP tasks such as information extraction, question answering, sentiment analysis, and entity linking. Example, Apple is headquartered in Cupertino, California. Name entity identified Apple as organization, Cupertino, California as location. Approaches those methods utilize handcraft rule and pattern to identify name entities based on linguistic features such as capitalization, part of speech tagging, and context. Statistical model techniques such as conditional random fields use probabilistic model and predict name entity label based on feature extracted from the input text and surrounding context. Deep learning technique recent advances in deep learning such as bidirectional long short-term memory networks, BILSTM, and transformer have shown promising result in any task by capturing complex contextual information and sequential dependencies in data. Structured information extraction. NER facilitates the extract of structured information from unstructured text, enabling machine learning to understand and processing human language more effectively. Enhanced NLP application. The output of NER can be utilized in various downstream NLP tasks, enhancing the performance and capabilities of applications such as information retrieval, question answering system, and entity linking. In summary, name entity recognition plays a crucial role in NLP by identifying and categorizing name entity within text data, thereby enabling the extraction of structured information and enhancing the capabilities of downstream NLP application. It can be approached using rule-based methods, statistical model, or deep learning technique, depending on the complexity and requirements of the task. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about parts of speech, POS tagging. It's mentioned over here as definition. Parts of speech tagging is the process of assigning grammatical tags to word in a sentence, indicating their syntactic roles. Example, noun, verb, adjective, adverb. Purpose. POS tagging helps in analyzing the grammatical structure of sentence, disambiguating word meaning, and enabling high-level NLP tasks such as parsing and machine translation. Example, in the sentence, the quick brown fox jumps over the lazy dogs. POS tagging would assign the tags such as DT, determinator, to the JJ adjective, to quick NN nouns, to fox, etc. Approaches. POS tagging can be performed using rule-based methods, statistical method, example, hidden Markov model or deep learning model, bidirectional LSTM transformer. Based on these mentioned details, we can say that parts of speech tagging is a crucial task in natural language processing that involve assigning grammatical tags to words in a sentence, indicating their semantic roles and relationship within the sentence. Parts of speech tagging is the process of assigning specific grammatical tags to each word in a sentence, such as noun, verb, adjective, adverb, etc. Those tags provide information about the word's syntactic functions and grammatical properties in the sentence. Analyzing grammatical structure, POS tagging helps in analyzing the grammatical structure of sentence by categorizing words into different syntactic categories. POS tags is aid to disambiguating word meaning and resolving ambiguities in language by providing information about a word's syntactic role in the context of the sentence. Enabling high level NLP tasks, POS tagging serves as crucial pre-processing step for various high level NLP tasks such as parsing, machine translation, information retrieval, and sentiment analysis. Example: the quick brown fox jumps over the lazy dogs. The DJ determinator, quick JJ adjective, brown JJ adjective, fox NN noun, jumps VBZ verb, over in preposition, the DT determiner, lazy JJ adjective, dog NN noun. Rule-based approaches use handcraft linguistic rules and patterns to assign POS tag based on syntactic and morphological features of words. Statistical models such as hidden Markov model HMMS and conditional random fields CRFS learn from annotated data to probabilistically predict POS tags based on contextual information. Deep learning models recent advances in deep learning include bidirectional long short-term memory network BILSTM and transformer have demonstrated significant improvement in POS tagging accuracy by capturing complex contextual dependencies and sequential pattern in the text. Importance syntactic analysis, POS tagging, enabling syntactic analysis of the text by providing insight into the grammatical structure and syntactic relationship between words in syntactic. Enhanced NLP tasks, the output of POS tagging serve as valuable input for various high-level NLP tasks, improving their accuracy and performance by incorporating syntactic information. In summary, spatial switch tagging play a crucial role in NLP by assigning grammatical tags to words in sentence, aiding in syntactic analysis, disambiguating meaning, and enabling high-level NLP tasks. It can be performed using rule-based methods, statistical model, or deep learning technique, depending on the complexity and requirement of the task at hand. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about relationship between NER and POS tagging. Overlap. NER often relies on POS tagging as a part of its pre-pausing or feature extraction step. Pause tags can provide useful contextual information for identifying name entities. Dependency POS tagging is a prerequisite for many NER systems since understanding the grammatical structure of sentence is crucial for accurately identifying name entities. Integration, NER and POS tagging are often integrated into larger NLP pipeline for tasks such as information extraction where both name entities and their grammatical roles are important. Application, information extraction, insight linking, question answering, name entities, disambiguating, parts of speech tagging, syntax analysis, parsing, machine translation, sentiment analysis. Both NER and POS tagging play crucial roles in various NLP applications, enabling machine to understand and process human language more effectively. They serve as fundamental component in many NLP systems and are essential for building more sophisticated language understanding capabilities. Based on these mentioned details, we can say that relationship between NER and POS tagging, the relationship between name entities recognition and parts of speech tagging in natural language processing. Here is an example of this point mentioned in the image. POS tagging identify the parts of speech, noun, verb, adjective, etc. for each word in sentence This information is often used in NER to provide contextual clues about the words, helping to identify name entities such as name of people, organization, location, etc. For example, if a word is tagged as a proper noun, it might be like to be a name entities. Dependencies many in your system require POS tagging as an essential preposing step. Understanding the grammatical structure of a sentence, which is provided by POS tagging, is crucial for accurately identifying name entities. For instance, knowing that a word is noun or proper noun can be aid in distinguish between general terms and specific name entities. Integration explanation of NER and POS tagging are often combined with larger NLP pipelines, especially for tasks like information extraction. In those pipelines, both the identification of name entities and the understand of their grammatical roles are important. For example, in a sentence where name entities in written bracket Microsoft function as a subject or an object, knowing its POS tag can be help in extracting relevant information more accurately. In summary, NER and POS tagging are closely related tasks in NLP that often together work enhance the accurate and functionality of language processing system. Name entity recognition and parser speech tagging in natural language processing and highlights their importance in various tasks. Here is an example explanation of the points. Name entity recognition application information extraction in here helps extract specific information such as name of people, organization, location, dates, etc. from large text dataset. Entity linking NER aids in linking entity mentioned in the text to their corresponding entries in a knowledge base, improving the understanding of the text. Questioning answering NER identifies relevant entities within a question, enabling the system to provide accurate answer. Name entity disambiguation NER helps distinguish between different entities that have similar name by using contextual information. Application of those POS tagging provides the grammatical structure of a sentence, which is essential for syntactic parsing and understanding the role of words. Parsing POS tagging is a crucial step in parsing sentence to analyze their grammatical structure and relationship between words. Machine translation POS tagging help in understanding the source language structure which aids in translation it accurately into the target language. Sentiment analysis POS tagging assisting in identifying sentiment bearing words, improving the accuracy of sentiment analysis system. Importance of NER and POS tagging. Both NER and POS tagging are fundamental components in many NLP systems. They enable machine to understand and process human language more effectively by providing essential information about the structure and meaning of text. This understanding is critical for building more sophisticated language understanding capabilities which can be applied to various NLP tasks such as information extraction, machine translation, sentiment analysis, and more. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about syntax and parsing. Syntax and grammar in NLP. It's mentioned over here as syntax and grammar in natural language processing refers to the rules and structure that govern the formatting of sentence and phrases in human languages. Understanding syntax and grammar is essential for NLP tasks such as parsing, sentiment analysis, and machine translation. Here's an overview of syntax and grammar in NLP. Based on these mentioned details, we can say that syntax and grammar in NLP refer to the set of rules and structure that dedicated how sentence and perhaps are constructed in human languages. Grasping those concepts is crucial for numerous NLP tasks. Here is a detailed explanation of syntax involving the arrangement of words and phrases to create a well-formed sentence in a language. It encompasses the rules that govern sentence structure. Role in NLP parsing involving analyzing a sentence to determine its grammatical structure. Syntax help in identifying the relationship between word and the role they play in sentence. Example subject, object, verb. Dependencies pursuing this technique identify the dependencies between words in a sentence, establish a tree structure that represent the grammatical relationship. Constituency pursuing these break down a sentence into a subphrases or constituents such as noun phrases or verb phrases, helping in understanding the hierarchical structure of a sentence. Grammar definition. Grammar is a broader concept that includes syntax as well as other rules and conventions for using a language correctly. It encompasses morphology, the structure of words and syntax. Role in NLP, morphological analysis, understanding the structure and formation of words such as prefix, suffix, and root words, which is vital for tasks like stemming and lemmatization. Grammar checking tool that automatically detect the correct grammatical errors in a text rely on the grammar rules. Parser switch tagging identify the grammatical categories of each word in a sentence. Example noun, verb, adjective, which is essential for many NLP tasks. Application in parsing, syntax analysis determine the syntax structure of a sentence, which is fundamental for understanding and processing text. Grammar check correcting syntactic and grammatical errors in a text. Sentiment analysis, context understanding syntax help in understanding context and the sentiment expressed in sentence by analyzing the structure and relationship between words. Polarity detection, proper syntactic analysis help in accurately determine the sentiment positive, negative, neutral of a complex sentence. Machine translation, accurately translation, understanding the syntax and grammar of both the source and target language improves the accuracy of translation. Structural mapping, syntax help in mapping the grammatical structure of sentence from the language to another, ensuring the translation preserve the original meaning. Important understand the syntax and grammar is crucial for disambiguation, resolving ambiguation sentence to ensure accurate understanding and processing. Information extraction, accurately extracting relevant information from text by understanding sentence structure. Natural language processing, understanding NLU, enhancing the ability of machine to comprehend and interpret human languages. Summary, sentence, syntax, and grammars are fundamental element in NLP, enabling more precise and effective language processing. By analyzing the structure rule of language, NLP system can perform a wide range of tasks from parsing sentiment analysis to machine translation and beyond with greater accuracy and reliability. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about syntax. It's mentioned over here as definition. Syntax refer to the rule that governs the structure of sentence in a language, including word order, sentence structure, and grammatical relationships between words. Syntax trees, also known as parts tree, represent the hierarchical structure of sentence according to the rules of syntax. They show how words are grouped into phrases and how phrases are combined to form sentence. Syntactic analysis involve parsing sentence to identify their syntactic structure, including parts of speech, phrases, and grammatical dependencies. Context-free grammars are formal framework used to describe the syntax of languages. They consist of a set of production rules that define how sentence can be generated from their constituent parts. Based on these mentioned details, we can say that syntax the provided definition and the concept relation to the syntax in natural language processing. Definition of a syntax is a set of rules that detects how words are arranged to form sentence in a language. This includes the order of words, example subject, verb, object in English, how words are combined into phrases and how phrases are combined to form complete sentence. Syntax ensure that sentences are grammatically correct and meaningful. Syntax trees or phrases trees visually represent the syntactic structure of a sentence based on the rules of a sentence. Each node in a syntax trees represent a grammatical unit such as word or phrases, and the branches show how those units are hierarchical connected. Syntax trees help in understanding how different parts of a sentence related to each other. Example, for the sentence the cat sat on the mat, a syntax tree would show the cat as a noun phrase, sat on the mat as a verb phrase, BP, and so on. Linguistic, the hierarchical structure of the sentence. Syntactic analysis, also known as parsing, involving breaking down a sentence to identify its syntactic structure. This process includes identifying parts of speech, noun, verb, adjective, etc., phrases, noun phrase, verb phrase, and grammatical dependencies such as which word are the subject or the object of the verb. Syntactic analysis help in understanding the grammatical relationship between words in a sentence. Application in NLP syntactic analysis used for tasks such as machine translation, where understanding the structure of the source sentence is crucial for producing the grammatically error translation in a target language. Context free grammars, explanation context free grammars, CFG are a type of formal grammar used to prescribe the syntax of languages. CFG consists of set of production rules that specify how sentence can be constructed from their contiguous part. Each rule identifies how a symbol like a noun phrase or verb phrase can be explained into other symbols or words. Components of CFG's non-terminal symbol, abstract symbol that can be expanded into one or more symbols. Example in P for noun phrases. Terminal symbol, actual words tokens in the language. Example cat, sat. Production rules that defines the how noun terminal symbols can be expanded. Example NP greater than date, in where the NP is noun phrases, date is a determiner and in is a noun. Start symbol, the initial symbol from which sentence are generated. Example, a simple CFG for a subset of English might including rules like is greater than NPVP. A sentence consists of a noun phrase following by a verb phrase. NP did in a noun phrase consists of a determiner following by a noun. BP VNP a verb phrase consists of a verb following by a noun phrase. Application of CFGs are used in syntactic phrases to generate phrase trees and analyze the structure of a sentence in NLP application. Understanding syntax trees, syntactic analysis, and context-free grammars is essential in NLP for processing and interpreting human languages. Those concepts help in breaking down and analyzing the grammatical structure of sentence, enabling various NLP tasks such as parsing, machine translation, and information extraction. This can be said after reading out this part. Now we will go to next particular discussion. Part we will be discussing about grammar. It's mentioned over here as definition. Grammar encompasses the rules and the principle that governs the use of words and phrases in a language, including morphology, syntax, and semantics. Type of grammars, morphological grammar rule governing the formation and inflection of words, example verb, conjugation, pluralization. Syntactic grammar rules governing the structure and arrange of word in a sentence. Syntactic grammar rule governing the managing and interpreting of words and sentence. Grammatical categories such as parts of speech, example noun, verb, adjective, and syntactic roles, example subject, object, are used to classify and analyze words within sentence. Based on these mentioned details, we can say that the provided definition and concept related to the grammar in natural language processing. Grammar encompasses the rules and the principles that govern the use of word phrases in a language. It includes the following components: morphology, the structure and formation of words; syntax, the arrangement of a words to form sentence; syntax, semantic, the meaning of an interpretation of a word and a sentence. Type of grammars, morphological grammar explanation. Morphological grammar involve that rules governing the information and inflection of words. This include verb conjugation, how verb changes from base on tense, mode, aspect, etc. Example: run become ran in the past tense. Pluralization, how many changes from to indicate more than one. Example: cat become cats. Importance in NLP, morphological analysis is essential for tasks like stemming and lemmatization, where the goal is to reduce words to their base or root forms. Syntactic grammar explanation. Syntactic grammar involves the rules that governs the structure and arrange of words in a sentence. This include the sequence in the which words are arranged. Example: subject, verb, object in English. Phrases structure, how word combines to form phrase and sentence. Example: noun phrases and verb phrases. Importance in NLP, syntactic analysis is crucial for understanding sentence structure, which aids in tasks like perceiving, machine translation, and information extraction. Semantic grammar explanation involves the rules that governs the meaning and interpretation of words and sentence. This includes word meaning, the meaning of individual word and how they changes in different contexts. Sentence meaning, how the meaning of words combine to the meaning of sentence. Importance in NLP, semantic analysis is essential for tasks like sentiment analysis, question answering, and information retrieval, where understanding the meaning of a text is crucial. Grammatical categories are used to classify and analyze words within sentence. They include parts of speech, categorize the noun, verb, adjective, etc. Those describe the role of a words in a sentence. Syntactic rules like subject and object that describe the function of a word or phrase in a syntactic structure of a sentence. Example: noun in refers to people, place, things, or idea. Example: dog, city. Verb describe the action, events, or state. Example: run, exist. Adjective describe or modifies noun. Example: blue, quick. Subject, the noun or noun phrases that perform the action in a sentence. Example: the cat chased the mouse. Object, the noun or the noun phrase that receive the action in a sentence. Example: the mouse in the cat chases the mouse. In NLP covers a broad set of rules and principles that dedicated how language is used. It includes morphological grammar focusing on word formation and inflection. Syntactic grammar focus on sentence structure and word arrangement. Syntactic grammar focusing on meaning and interpretation of words and sentence. Understanding those aspects of grammar is crucial for building effective NLP system that can be accurately process and interpreted human language. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about application in NLP. It's mentioned over here as parsing. Syntactic analysis is used in parsing to understand the grammatical structure of a sentence and extract syntactic information such as phrase, dependencies, and syntactic roles. Sentiment analysis, understanding the syntactic structure of a sentence, help in analyzing sentiment by identifying subjective, negation, and syntactic cues. Machine translation, syntactic, and grammar play a crucial role in machine translation by preserving the grammatical structure and fluency of translated sentence. Text generation grammar rules are used in text generation tasks to ensure that generated text adherence to the syntactic constraint of the language. Based on these mentioned details, we can say that syntax and grammar are applied in various natural language processing NLP tasks. Parsing involving syntactic analysis to understand the grammatical structure of sentence. This process breaks down a sentence into its constitute parts such as phrases and grammatical dependencies. Role in NLP: extracting phrases, identifying noun phrases, verb phrases, etc. Dependencies determine how words in a sentence depend on each other. Example: subject verb relationship. Syntactic roles: identifying roles like subject, object, and predict within a sentence. Importance: parsing is the fundamental for understanding the structure of a sentence, which is crucial for tasks such as information extraction, question answering, and more. Sentiment analysis, explanation. Sentiment analysis involve determining the emotion tone of a text, positive, negative, neutral. Understanding the syntactic structure helps in subjectivity, identifying subjective phrases that express the opinion or feelings. Negation handling detection, negation, example, not happy, to correctly interpret the sentiment. Syntactic cues, recognizing syntactic patterns that indicate sentiment, example, very good versus not very good. Importance: accurate syntactic analysis improves the reliability of sentiment analysis by correctly interpreting complex sentence structure and contextual. Machine translation involves converting text from one language to another. Syntax and grammar are crucial for grammatical structure, ensuring that the translated sentence following the grammatical rules of a target language. Fluency, maintaining the natural flow and coherence of a translated text. Syntax mapping, align the syntax structure of a source language with that of target language to preserve meaning. Proper handling of syntax and grammar ensure the translation are not only accurate but also natural and readable in target language. Text generation, explanation, text generation task involving creating coherent and syntactically correct sentence grammars rules are used to ensure that syntactic constraint generated text adherence to the grammatical rules of the language. Fluency and coherence, the text flows naturally and makes logical sense. Context appropriateness, the generated text is appropriate for the given context and purpose. Importance: adherence to the grammar rules is essential for producing high quality human like text that it is understandable and relevant to the context. Understanding syntax and grammar is vital across various NLP tasks. Here's the recap of their roles. Parsing syntactic analysis, understand the sentence structure, extract phrases, and determine dependencies and syntactic roles. Sentiment analysis, leveraging syntactic structure to identify sentiment bearing element, handling negation, and use syntactic cues. Machine translation, preserving grammatical structure and fluency in translation, ensuring the target language text is accurate and natural. Text generation, using grammar rules to produce syntactically correct, fluent, and contextually appropriate text. In essence, syntax and grammar form the backbone of NLP system, enabling accurate processing, understanding, and generating of human languages. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about challenges. It's mentioned over here as ambiguity. Natural language often exhibits ambiguity in syntax, where a sentence can have multiple valid interpretation. Parsing complexity, parsing sentence with complex syntactic structure or ambiguous grammar can be computationally challenging. Cross linguistic validation. Different languages have different syntactic rules and grammatical structure, leading to challenge in developing language agnostic NLP system. Understanding syntax and grammar is crucial for building robust and accurate NLP system that can accurately analyze, understand, and generate human language. Advances in syntactic parsing algorithm and grammatical analysis technique continue to improve the performance of NLP system across a wide range of tasks. Based on these mentioned details, we can say that to explain the challenges associated with understanding syntax and grammar in natural language processing. Ambiguity in natural language occurs when a sentence can be interpreted in multiple ways due to its syntactic structure. This can lead to different managing based on how the sentence is parsed. Example: lexical ambiguity, a word with the multiple meanings. Example, bat can mean a flying mammals or a pieces of sports equipped. Syntactic ambiguity, a sentence structure that allow multiple interpretation. Example, I saw the man with the telescope could mean the man had the telescope or the action was done using the telescope. Importance handling ambiguity is crucial for accurate NLP application, such as information retrieval, machine translation, and sentiment analysis, as it affected the system's ability to correctly interpret user input. Parsing complexity explanation, parsing sentence, especially when those complex syntactic structure or ambiguation grammar can be computationally challenging. The complexity arises due to longer sentence with nested clause increase the difficulty of parsing. Ambiguation sentence multiple valid parts for a single sentence make it challenging to determine the correct structure. Non-standard grammar, informal or ungrammatical text, example social media post, can complicate parsing. Importance: effective and accurate parsing algorithm are necessary to handle the diverse and complex nature of human language in NLP application. Cross-linguistic validation explanation: different languages have different syntactic rules and grammatical structure, leading to challenges in creating NLP system that works across multiple languages. Example: word order. English follow a subject verb object order while Japanese follow a subject object verb order. Morphology: some language have rich morphological system. Example: Finnish with the extensive inflation while others have relatively simple morphology. Example: Chinese. Importance: developing language agnostic NLP system that can handle diverse linguistic features is challenging but essential for building globally applicable technologies. Significance of understanding syntax and grammar. Explanation: understanding syntax and grammar is crucial for building robust and accurate NLP system. This involves accurate analysis, correctly analyzing sentence structure and grammatical relationship to understand the meaning. Natural language generation, producing syntactically correct and meaningful text. Handling ambiguity, resolving ambiguity to ensure accurate interpretation and processing of languages. Adapting or to validating, addressing cross-linguistic variation to create systems that work across multiple languages. Importance advance in syntactic parsing, algorithm and grammatical analysis technique continue to enhance the performance of NLP system, enabling them to better understand and generating human languages across a wide range of tasks. In summary, understanding and addressing the challenges of syntax and grammar in NLP are fundamental for deploying effective languages processing system. Key point including ambiguity, multiple valid interpretation of sentence requires sophisticated disambiguations technique. Parsing complexity handle complex and ambiguous structure necessity advanced parsing algorithm cross-linguistic validation, different grammatical rules across language pose challenges for multilingual NLP system. Importance of syntax and grammar critical for accurate analysis, generation and handling of natural language contribute to the overall robust and effectiveness of NLP application. Advances in this area are essential for improving the capabilities of NLP system and their applicable across diverse linguistic context. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about dependency parsing. It's mentioned over here as dependency parsing is a fundamental task in natural language processing NLP that involves analyze the grammatical structure of a sentence to identify syntactic dependencies between words. Dependency parsing represents the relationship between words as direct link dependencies in a tree structure where each word is a node and the link represent syntactic relationships such as subject, object, modifier, etc. Here's an overview of dependency parsing in NLP. Based on these mentioned details, we can say that dependency parsing is a crucial task in natural language processing NLP that aims to analyze the grammatical structure of a sentence by identifying syntactic dependencies between words. Here is a deep look at what dependency parsing involves and its significance. Definition of dependency parsing: this is the process of analyzing the grammatical structure of a sentence to establish relationship between words. Those relationships or dependencies are represented as direct link in a tree structure. Each word in the sentence is a node, and the link edge denote syntactic relationship. Key components are tree structure nodes. Each word in a sentence is represented as a node. Each is directed link between nodes represent syntactic dependencies. Root: the root of a tree is typically the main verb or the main predicate of the sentence. Syntactic dependency is the noun or the noun phrase that performs the action of a verb's object, the noun or noun phrase that receives the action of the verb. Modifiers: words that the modifiers others words such as adjectives or adverbs. Example: for the sentence, the quick brown fox jumps over the lazy dogs. Fox is the subject of jumps in little bracket NSUDJ. Jumps is the root of the tree. Quick and brown are the modifiers of fox. Over is a position modifier jumps. Dog is the object of the position over. Lazy is a modifier of dog. Importance of a dependency parsing: understanding the sentence structure, grammatical relationship identifies relationship like subject, verb, object, and modifies, providing a detailed understanding of sentence structure. Semantic roles help in identifying who did that to whom in the sentence, which is essential for tasks like informing extraction. Application in NLP: machine translation ensures syntactic structure are preserved during translation, leading to more accurate translation. Sentiment analysis identifies the relationship between sentiment being words and their targets. Information extracting extract structure information for structured text by understanding dependencies. Text summarization help in identifying key element of sentence, improving the quality of summarize, handling ambiguity, disambiguity, resolving ambiguitions in sentence by providing a structure representation of possible interpretation. Types of dependency parsing be rule-based parsing grammar rules use predefined linguistic rule to parse sentence. Limitation can be less flexible and struggle with a complex or non-standard language. Statistical parsing probabilistic models use statistical methods to predict the most likely dependency structure based on the large corpus of our annotated data. Machine learning employs algorithms such as support vector machine, neural networks, or deep learning models. Transist basic parsing state transitions use a series of transitions to build the dependencies tree incrementally efficient, often faster and suitable for real-time application. Graph-based parsing global optimization find the most likely dependencies tree considering all possible tree and selecting the one of the highest probability. Accuracy can be more accurate by computational intensive. Advanced challenges deep learning modern approaches are neural networks, particularly recent neural networks, and transformer to improve the accuracy and efficiency of dependency parsing. Cross linguistic parsing develop the model that can handle multiple language with different syntactic structure remaining a significant challenges. Domain adaptation ensuring the dependency parsing work well across different domain. Example legal, medical, colloquial is an ongoing area of research. Dependency parsing essential for understanding the grammatical structure of a sentence in a NLP. It represents the syntactic dependencies in a tree structure providing valuable insight into the relationship between words. The parsing technique is fundamental for various NLP applications, including machine translation, sentiment analysis, and information extraction, and continue to evolve the advance in machine learning and deep learning technique. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about dependency relation. It's mentioned over here as dependency links. Each links in a dependency parts tree represent a syntactic relationship between two words, with one word being the head and the other being the dependent. Types of dependencies, common dependencies relationships including subject verb, the subject of a sentence is connected to the main verb. Verb object, the main verb is connected to its object. Modifier head, words such as adjective, adverbs, and preposition are connected to the words they modify. Coordination word in a coordinated structure, example conjugation, are connected to each other. Dependency level, each link is labeled with a specific dependency level, indicating the type of syntactic relationship between the word. Based on these mentioned details, we can say that each link and dependency pairs tree represent a syntactic relationship between two words, with one word begin the head and the other word begin the dependent. Function those links illustrate how words in a sentence are related to each other. Synthetically, for example, in this sentence, she read books. The link between she and reads show that she is the subject of a reads. Types of dependencies. There are several common type of dependencies relationship, including subject verb definition. The subject of a sentence is connected to the main verb. Example in the sentence, the cat sleeps. The cat is the subject and the sleep is the verb. Verb object, the main verb is connected to its object. In the sentence, she read books, read is the verb and books is the object. Modifier head, definition words such as adjective, adverb and preposition are connected to the word they modify. Example in the words very quickly, very is the adverb modification quickly. Coordination definition word is a coordinated structure. Example conjugation are connected to each other. Example in the sentence she likes apple and oranges. Apple and oranges are coordinated by and. Dependency labels definition each link in the dependency pairs tree is a label with a specific dependency label indicating the type of syntactic relationship between the words. Function those labels provide more detailed information about syntactic structure of the sentence specifying the exact nature of the relationship between the word. For example, label might including NSUBJ nominal subject, DOBJ, direct object, AMOD, adjectival modifier, etc. Those elements together help in understanding the syntactic structure of a sentence, which is essential for various natural language processing tasks such as parsing, machine translation, and information extraction. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about dependency pairs tree. Tree-structure dependencies pairs tree have a hierarchical structure where each word is connected to exactly one head word. Expect for the root of a tree. The root node of dependency tree represent the main verb or the root of the sentence. Projectivity dependency parts tree are often constrained to be projective, meaning that the link between words do not cross each other when visualized in 2D space. Dependency parsing algorithm transist basic parsing dependency parsing algorithm that operate by performing sequence of transitions to build the dependency per stream incrementally. Example include ARC standard and ARC eager algorithms. Graph based on parsing dependency parsing algorithms that build the entire parse tree at once by considering all possible dependency like simultaneously. Example including the Chuliu Enderman's algorithm and MSG parsing. Based on these mentioned details, we can say that the concept of related to dependency parsing and tree present in the image. Dependency parsing trees have a hierarchical structure where the word expect for the root is connected to exactly one head word. Function the structure represent the syntax organization of a sentence. For example, in the sentence, the quick brown fox jumps over the lazy dogs. Jumps might be the head word with the other word connected to it and dependent formatting a hierarchical structure. Root node definition the root node of a dependency tree, the main verb or the central element of the sentence. Function the root node is the another of the entries tree in the sentence. The quick brown fox jumps over the lazy dogs. Jumps would be the root node because it is the main verb around which the sentence is structured. Projectivity definition dependency per tree are often constrained to be projective, meaning that the link between words do not cross each other when visualization in 2D space. The constraint ensures that the tree can be drawn on a plane without any overlapping lines, which simplify the analysis and the visualization of a syntactic structure. For example, in a projective tree, for the sentence, she said that he saw her. The links would be drawn in a way that avoid crossing each other. Those concepts help in understanding the syntactic dependencies in a sentence, making it easier to analyze the process natural language computationally. Dependency parsing algorithm approaches transition based parsing algorithm build the dependency parse tree incrementally by performing a sequence of transition that modify the state of a parse. Function the parser start with an initial configuration and transits through a series of states until it reach a final configuration which represent the completed parse tree. The choice of transitions at each step can be guided by a classifier. Example, ARC standard algorithm. This algorithm maintain a stack and a buffer performing transition that shift word from the buffet to a stack or the create acts dependency between word on the stack. ARC eager algorithm similar to the ARC standard algorithm but allow for the creation of ARC before creating shift operations, making it potentially more efficient in some cases. Graph-based parsing defining the graph parsing algorithm construct the entire dependency parse tree at once by consider all possible dependencies, linked simultaneously and selecting the optimal tree according to a scoring function. Those algorithms are use technique from graph theory to find the highest scoring trees that satisfy the certain constraint. Example being a well formed tree. Example Chuli Edmond's algorithm. The algorithm finds the maximum spanning tree in a directed graph, which can be used to derive the dependencies parse tree, MST parsing, maximum spanning tree parsing, similar to the Chuliu Edmond's algorithm. It seeks to maximize the sum of a score of a edge dependency links in the tree, ensuring the resulting structure is a valid dependency tree. Transition based parsing building the parse tree step by step through a series of a transition. Graph based parsing construct the entire parse tree in one go by selecting the best possible set of dependencies linked. Both approaches have their advantages and are used in different scenario dependencies on a factor like the complexity of a language being parsed and the computational resource available. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about application of dependency parsing. It's mentioned over here as syntactic analysis. Dependency parsing provided insight into a grammatical structure of a sentence, including subject verb object relation, modifier attachment, and syntactic dependencies. Information extraction dependency parsing trees can be used to extract structural information from tree text, such as identifying entities and their relationship. Machine translation dependency parsing tree are used to preserve the syntactic structure of a sentence during machine translation, improving translation quality and fluency. Question answering dependency per tree can aid in understanding the syntactic structure of a question and matching them with relevant answer. Based on these mentioned details, we can say that dependency parsing provide insight into the grammatical structure of a sentence by identifying syntactic relationship between words. Functioning by analyzing those relations, it helps understanding how words in a sentence are related to each other. For instance, it can identify the subject verb object relationship, which is crucial for understanding the core meaning of a sentence. Example in the sentence, the cat chased the mouse. Dependency parsing can show that cat is the subject, chase is the verb, and mouse is the object. Information extraction dependency parsing trees can be used to extract structured information from text. Functions they help identify entities, example people, place, organization, and the relationship between them, making it easier to extract relevant information from unstructured text. Example from the sentence Joe bought a car from Alice. Dependency parsing can help extract the entities John and Alice and the relationship bought a car. Machine translation definition dependency parse tree are used to preserve the syntactic structure of a sentence during machine translation. Function by maintaining the syntactic relationship, they help ensure the translate sentence by grammatically correct and retain the meaning of original text. Example, when translation the English sentence, the cat is on a mat. Spanish dependency parsing helps ensure that the subject cat and the phrase on the mat, the correct translated and the position in the Spanish sentence, el gato está in la alfarbo. The question answering definition dependency parts we can aid in understanding the syntactic structure of a question. Function they help in parsing the question to identify the main query and the match it with relevant answer from a knowledge base or text. Example for the question who wrote pride and the prejudice dependency parsing can identify who was the subject and the root pride and prejudice as a verb and the object phrase respectively. This understanding help in finding the answer. Jane Austen. Syntactic analysis help in understanding the grammatical structure of a sentence. Information extracting facilitating the extract of entities and relationship for text. Machine translation improves the translation quality by preserving syntactic structure. Question answering assists in parsing question to find accurate answer. This application demonstrates how dependency parsing is powerful tool in various NLP tasks, enhancing the ability of system to process and understand natural languages. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about challenges. It's mentioned over here as ambiguity dependency parsing face challenges in case of ambiguity where a sentence can have multiple valid purses with different interpretations of syntactic structure. Cross linguistic variation, different languages exhibit different syntax structure and dependency patterns, requiring language specific parsing model. Parsing errors, dependency parsers may make errors in case of complex sentence structure, noisy input data, or out of vocabulary word. Dependency parsing is a crucial component of many NLP systems and plays a key role in syntactic analysis, information extraction, and the NLP task. Advance in dependency parsing algorithm and technique continue to improve the accuracy and efficiency of syntactic analysis in NLP. Based on these mentioned details, we can say that ambiguity in dependency parsing occurs when the sentence can be interpreted in multiple ways, each with a different syntactic structure. This poses a challenging because the phrases must decided on the interpretation, which may not allow align with the intended meaning. Example, consider the sentence I saw the man with a telescope. This sentence can be parsed in two ways. The speaker used a telescope to see the man, modifier with the telescope attached to the verb saw. The man has a telescope modifier with the telescope attached to the noun man. The purser must choose in between those interpretation and without additional context it might chosen incorrectly. Cross linguistic variation, different languages have different syntactic structure and dependency pattern, which means that the parsing model need to be tailored to each languages. Function the variability requires language specific adjustment and training data to accurately phrase sentence in a different languages. Example, English typically follows as a subject verb object order as in a see, eat an apple. Japanese often follows a subject verb object order as see an apple eats. German can have variable words order dependency on the sentence type and context. A parser trainer on English may not perform well on Japanese or German sentences without specific adaptation. Parser error dependency parser can be make mistake, particularly when dealing with a complex sentence structure, noisy input data, or data that are not in the parser vocabulary. Function those errors can arise from various factors such as limitations in the training data or the inherent difficulty or parsing centered sentence. Example, complex sentence structure, sentence with a multiple clause, nested structure or unusual syntax can be confuse the parser. For example, the book that the student who the rich players read the interesting has multiple embedded clause that can be difficult to parser correctly. Noisy input data text with typos, slang or informal languages, example social media post, can lead to parsing error because the parser may not recognize the words or the structure. Out of vocabulary word, if a parser encountered word it has not seen during training, it may struggle to assign correct dependencies. For instance, in the technical or specialized text with domain specific terminology, the parser might not correctly interpret the relationship between words. Summary: ambiguity challenges arise when the sentence can have multiple valid pursuit, require the pursuit to choose the most likely interpretation, which may not always be correct. Cross linguistic variation, different languages require different parsing model due to their unique syntactic structure and dependency pattern. Parsing error can occur with a complex sentence, noisy input, or out of vocabulary word affecting the accuracy of parse. Understanding those challenges is crucial for improving dependency parsing model and making them more robust across different language and text type. Let's elaborate on the important and the advance of a dependency parsing in NLP. Dependency parsing in NLP system, crucial component dependency parsing is a fundamental to many natural language processing system because it provides a detailed understanding of the syntactic structure of a sentence. It identifies how words in a sentence are related to each other, which is essential for comprehending the meaning of a sentence. Key role in a syntactic analysis. Syntactic analysis involve breaking down sentence into their grammatical component to understand the structure. Dependency parsing helps in identifying grammatical relationships such as subject, verb, object, and modifiers, providing a clear picture of a sentence structure. Example, in the sentence, the cat chased the mouse, dependency parsing reveals the cat is the subject, chase is the verb, and mouse is the object. This understand is crucial for accurate syntactic analysis. Application of dependency parsing, information extraction. Dependency parsing aid in extracting structured information from unstructured text. By understanding the syntactic relationship between words, it may identify entities and their relationship. Example from the sentence, John bought a car from Alice. Dependency parsing can help extract the entities John and Alice and the relationship bought a car. Other NLP tasks, dependency parsing is also essential in various other NLP tasks such as machine translation help preserve the syntactic structure of a source language in the target languages, improving translation quality and fluency. Question answering assistant in the understanding the structure of a question and matching them with relevant answer. Text summarization helps identify the main component of a sentence, aiding in the generation of conscious summary. Advance in a dependency parsing, improving accuracy and efficiency. Continuous advance in the dependency parsing algorithms and technique enhance the accuracy and efficiency of syntactic analysis. Those Advancement ensure that the parser can handle more complex syntax, reduce errors, and process text faster. Transition based parser algorithms like our standard and ARC eager incrementally build the parser tree through the series of transition, making the parser process more dynamic and adaptability. Graph-based parsing techniques such as Chuliu, Edmond's algorithm, and MSG parsing consider all possible dependencies simultaneously, selecting the optimal parser tree for the sentence. Machine learning and deep learning recent development in the machine learning, particularly deep learning, have significantly improved dependency parsing performance. Natural language based model can learn complex syntactic pattern from large dataset, resulting in a more accurate parser. Example, neural dependency parsing model use deep learning to automatically learn feature from data, reducing the need of for manual feature engineering and improving the parsing accuracy. Importance in NLP dependency parsing is a crucial component for syntactic analysis and various other NLP tasks, providing detailed understanding of sentence structure, application. It is play a key role in information extracting, machine translations, questions answering, and text summarization. Advancement ongoing improving the algorithm that adapted the machine learning technique continue to enhance the accuracy and efficiency of dependency parsing, enabling better syntactic analysis and overall NLP performance. Though advancement ensure that the dependency parsing remain a vital tool in NLP toolkit, contributing the development of more sophisticated and capable language processing system. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about sentiment analysis and opinion mining. Basic of sentiment analysis. It's mentioned over here as sentiment analysis, also known as opinion mining, is the process of determining the sentiment or emotional tone expressed in a piece of text. It involves analyzing and categorizing text data to identify whether it conveys positive, negative, or natural sentiment towards a particular subject, entity, or topic. Here are the basic of sentiment analysis. Based on these mentioned details, we can say that basic of sentiment analysis, sentiment analysis also known as opinion mining, is the process of determining the sentiment or emotional tone expressed in a piece of text. It aims to understand the opinion, emotions, and attributes conveyed in the text. Objective. The main goal of sentiment analysis is to classify the text as expressing positive, negative, or neutral sentiment towards a particular subject, entity, or topics. Key component of sentiment analysis is the input for the sentiment analysis is typically a piece of text such as a sentence, paragraph, review, tweet, or article. Example, I love this new phone. The camera quality is amazing. Subject or entity sentiment analysis often focusing on the specific subject, entity, or topic mentioned in the text. Example, in the sentence, I love this new phone. The subject is new phone. Sentiment classification. The core task of sentiment analysis is to classify the sentiment expressed in the text as positive, negative, neutral. Positive sentiment indicates approval, happiness, or satisfaction. Example, I love this new phone. Positive sentence. Negative sentiments indicates disapproval, anger, or dissatisfaction. Example, this phone is terrible. Negative sentiments. Neutral sentiment indicate a neutral or a factual sentiment without strong emotional tone. Example, this phone has a 12 megapixel camera. Neutral sentiment. Step in a sentiment analysis, text reprocessing, preparing the text, data for analysis by clearing the normalization it. This is including steps like removing punctuation, converting text to lowercase, and tokenizing. Break down the text into word or phrases. Example, converting I love this new phone to I love this new phone. Feature extraction, identifying the and extracting feature from the text that can help in determining sentiment, common feature including words, phrases, or engrams. Example, extracting word like love and phone from the text. Sentiment direction using machine learning algorithm or rule-based approaches to classify sentiment based on the extracted feature. This involves training a model on label data between bracket text with the known sentiment and then apply it to a new text data. Machine learning approaches using algorithms like name bias, support vector machine, or neural networks to learn about a sentiment classifier. Rule-based approaches using predefined rule and lexicons, dictionaries of sentiment Latin words to determine sentiment. Output sentiment, the result of the sentiment analysis is the classification of the text as positive, negative, or neutral. Example, the text I love this new phone is classified as positive sentence. Application of the sentiment analysis, customer feedback analyzing, customer review, feedback and social media comments to gauge customer satisfaction and identify areas for improvement. Example, analyzing produce review on an e-commerce site to determine overall customer satisfaction. Brand monitoring, social media and other online platforms to track public opinion about a brand, product or service. Example, tracking tweets about a brand to understand public sentiment and manage reputations. Market research understanding consumer opinion and trends to inform marketing strategies and product development. Example, analyzing survey response to identify consumer preference and market trends. Political analysis, public opinion on political issues, candidate and policies. Example, analyzing news article and social media posts to gauge public sentiment towards a political candidate. Sentiment analysis is the process of determining the emotion tone of a text to classify it positive, negative, or neutral. Key aspect of the text involving feature extraction, sentiment detection, and outputting sentiment. Application used in customer feedback analysis, brand monitoring, market research, and political analysis. Understanding the sentiment analysis help organization and individual gain insight into public opinion, improve customer satisfaction, and make information decision based on textual data. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about understanding sentiment. It's mentioned over here as sentiment polarity. Sentiment can be categorized into three main polarities: positive, negative, and neutral. Positive sentiment expressed favorable or positive opinions, emotions, or attitudes, while negative sentiment conveys unfavorable or negative opinions. Neutral sentiment indicates a lack of strong positive or negative feelings. Subjectivity sentiment analysis also considered the subjectivity of text, which refers to the degree of personal opinion, emotion, or bias expressed in the text. Subjective text typically contains opinions, emotion, or sentiment, while objective text presents factual information without personal judgment. Text representation, text corpus sentiment analysis relies on textual data sources such as social media posts, product review, customer feedback, news article, and user comments. Text preprocessing before sentiment analysis. Text data is preprocessed to remove the noise such as punctuation, special characters, stop word, and perform tokenization to split the text into individual word or tokens. Feature extraction feature such as word frequency engrams, sequence of adjacent word or word embeddings, dense vector representations of vector are extracted from the preprocessed text to represent the textual data for analysis. Based on these mentioned details, we can say that sentiment polarity refers to a classification of text based on an emotional tone it conveys. The three main categories of sentiments polarity are positive sentiment express favorable or positive opinions, emotion or attitudes. Example, I love this product, it's amazing. The movie was fantastic and I enjoyed every moment. Characteristics, word and phrases that indicate happiness, satisfaction, approval, or phrases. Common positive word including love, great, fantastic, happy, and excellent. Negative sentiments defining conveys unfavorable or negative opinion, emotions, or attitudes. Example, I hate this product, it is terrible. The service was awful and the staff were rude. Characteristics, words and phrases that indicate disappointment, dissatisfaction, disapproval or criticism. Common negative word including hate, bad, terrible, unhappy and awful. Neutral sentiment indicate a lack of strong positive or negative feelings. The text is often factual or informative without expressing significant emotion. Example, this product arrived on time. The book has 300 pages and will published in 2020. Characteristics, word and phrases that are neutral and do not convey strong emotion. Neutral text often includes factual statement, description, or informational content. Subjectivity in sentiment analysis refers to the degree to which a text expresses personal opinion, emotion, or biases. It constrains with objectivity, which is the presentation of facts without personal judgment or emotional influence. Subjective text contains personal opinion, emotion, or sentiments. It reflects the writer's individual perspectives and feelings. Example, I think this is the best movie I have ever seen. In my opinion, the new policies is very unfair. Characteristic subjective text often include words and phrases that indicate personal judgments, feelings, or biases. It may use first person pronouns I, my, and adjective or adverbs that convey emotion or opinion. Example based, unfair, fantastic. Objective text definition present factual information without personal judgment, emotion, or bias. It aims to be neutral and impartial. Example, the movie was released in 2023 and has a runtime of 120 minutes. The new policies, including a 10% tax on imported goods, characterizes objective text, focus on factor, data, and variable information. It's avoid subjective language and personal pronouns, aiming to provide clear, unbiased information. Importance in sentiment analysis, identifying polarity, classifying text into positive, negative, or neutral sentiment helps in understanding the overall emotion, tone, and opinion expressed in the text. This is essential for application like customer feedback, analysis, social media monitoring, and market research. Accessing subjectivity, understanding the subjectivity of the text helps differentiate between opinion, content, and factual information. This distinction is important for tasks like opinion mining, news analysis, and information extraction. Sentiment polarity: positive sentiment express favorable opinion or emotion, negative sentiment convey favorable opinion or emotion. Neutral sentiment indicate a lack of strong emotion, often presenting factual information. Subjectivity text include personal opinion, emotion, or bias. Objectivity text represent factual information without personal judgment or emotion. By analyzing both sentiment polarity and subjectivity, sentiment analysis provide a comprehensive understanding of the emotional and opinion content in the text, enabling better decision making and insights. Definition: of text corpus is a collection of textual data used for analysis. In sentiment analysis, the corpus consists of various sources of text data that provide information about people's opinion, emotion, and sentiment. Example of a textual data source: social media posts, tweet, Facebook updates, Instagram captions, etc. Product reviews, customer reviews on e-commerce site like Amazon or Yelp, customer feedback from survey response and support tickets, news article, editorial and opinion pieces from news website, user comments on blog, forums and video platform like YouTube. Importance: the text corpus serves as the raw material for sentiment analysis, providing the necessary data to identify and understand sentiment trend and patterns. Text prepausing involves preparing the raw text data to make it suitable for analysis. This step removes noise and standardizes the text to ensure consistency and accuracy. Common prepausing steps: removing noise, eliminate unwanted characters such as punctuation, social characters, and number that do not contribute to sentiments. Stopword removal: stopword common word that do not carry significant meaning such as and, the, is, and in. Those words are known as stopword. Tokenization: splitting the text into individual word or tokens. This helps in analyzing the text at the word level. Example: this sentence "I love this product" becomes "I love this product" after tokenization. Lower casing converted all to lower case to ensure uniformity and avoid treating word like good and good as different. Stemming and lemmatization reduce the word to their base or root form to handle different grammatical forms of the same words. Example: running, runner, and run are reduced to run. Importance: prepausing, cleaning, and standardize the text data, making it easier to extract meaningful features and ensure that the analysis is not affected by irrelevant or redundant information. Feature extraction involves transforming the preprocessed text into numerical representations that can be used for analysis. Those features capture important aspects of the text that are relevant for sentiment analysis. Common feature extracting technique: word frequency, count of the word in the text corpus. This can be represented at using a term frequency matrix. N-grams extraction: sequence of adjacent word n-grams from the text. Common n-grams including bidiagrams 2 words and trigrams 3 words. Example for the sentence "I love this product." Bidiagrams are "I love this product." Word embeddings use dense vector representation of the word that capture their meaning and relationship in a continuous vector space. Common word embedding model including word to wake, glove, and bird. Example: the word happy might be represented by a vector like zero point 0.1, comma, 0.2, 0.5, dot, 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 0.3. Important features extraction converts the text data into a form that machine learning algorithm can process. It captures the relevant information needed to analyze sentiments such as word uses pattern, context, and semantic relationship. Text corpus, the raw collection of textual data from various sources, providing the basis for analysis. Text preprocessing of a cleaning and preparing the text data to remove noise and standardize the content of analysis. Feature extraction, the transformation of preprocessing text into numerical representation that captured important aspect of the text sentiment analysis. Together, those steps enable sentiment analysis system to accurately and efficiently analyze the sentiment expressed in textual data. This can be said after reading out this part. Now we will go to next particular discussion. In this part, we will be discussing about sentiment analysis technique. It's mentioned over here as lexicon-based approaches. Lexicon-based sentiment analysis relies on sentiment lexicon or dictionaries containing word annotated with sentiments label, example positive, negative. The sentiment polarity of a text is determined based on the presence and polarity of sentiment bearing words in the text. Machine learning approaches, machine learning models such as classification algorithm, example support vector machine, naive bias, and logistic regression. And neural networks are trained on labeled dataset to automatically learn pattern and feature indicative of sentiment in the text. Hybrid approaches combine lexicon based method with machine learning technique to leverage the strength of both approaches for improved sentiment analysis performance. Based on these mentioned details, we can say that lexicon based sentiment analysis relies on sentiment lexicon or dictionaries that contain words annotated with sentiment labels such as positive, negative, or neutral. Process, the sentiment polarity of a text is determined based on the process and polarity of sentiment bearing words in the text. For example, it is a text contain more positive words than negative words according to the lexicon. It will be classified as having a positive sentiment. Strength of lexicon based approaches are often faster and more straightforward to implement compared to the machine learning approaches. They can also be effective for language where label trained data is limited or unavailable. Limitations, lexicon based approaches may struggle with context and sarcasm as they primarily focus on individual word without considering the surrounding context or linguistic nouns. Machine learning approaches, definition machine learning models such as classification algorithm, example support vector machine, naive bias, logistic regression, and neural networks are trained on labeled dataset to automatically learn patterns and feature indicative of sentiment in the text data. Process those model learned from label data where each text sample is associated with a sentiment label. Example positive, negative, neutral. They extract features such as word frequency, engrams, and syntactic structure to predict the sentiment of unseen text. Machine learning approaches can capture complex relationship and contextual information in text data, making them more robust in handling sarcasm, negation, and context dependent sentiment. Limitations, they require a significant amount of label training data for effective training and they can be computationally intensive and resource consuming. The hybrid approaches combine both lexicon-based method and machine learning technique to leverage the strength of both approaches for improved sentiment analysis performance. Process in a hybrid approach is lexicon-based method may be used for feature extraction or as a pre-processing step to enhance the input data before feeding it into machine learning model. Alternatively, machine learning model can be combined with lexicon-based feature to improve accuracy and robustness. Strength hybrid approaches can be capitalized on the speed and simplicity of lexicon based method while also benefited from the predictive power and contextual understanding of machine learning model. Limitation design effective hybrid model require careful integration and optimization of both components which can be complex and time consuming. Lexicon-based approaches rely on predefined sentiment dictionary. Machine learning approaches learn sentiment patterns from data, and hybrid approaches combine the strength of both for more accurate sentiment analysis. Each approach has its strength and limitation, and the choices of approaches depend on the factors such as available resources, data availability, and desired level of accuracy and scalability. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about sentiment analysis application. It's mentioned over here as product and service review. Sentiment analysis is commonly used to analyze customer review and feedback about product, service, and brand, helping business understand customer sentiment and make data-driven decisions. Social media monitoring sentiment analysis enabling organized to monitor and analyze sentiment expressed on social media platform, track public opinion, detect emerging trend and merge brand reputations. Market research sentiment analysis provide valuable insight for market research, consumer behavior analysis, and competitive intelligence by analyzing sentiment towards products, advertisement, and making campaigns. Customer support and feedback analysis. Sentiment analysis is applied in customer support system to automatically classify and prioritize customer feedback, identify issue and escalate urgent complaints. Based on these mentioned details, we can say that sentiment identification determines whether the feedback is positive, negative, or neutral. Feature specific analysis identify which specific feature or aspect of a product or service are receiving positive or negative feedback. Trend analysis track the changes in customer sentiment over time to identify trend or shifts in perceptions. Product improvement gaining insight into area of improvement and customer preference. Competitive advance unveils how your product or service are perceived compared to competitors. Customer satisfaction address common complaint and enhance customer satisfaction. Social media monitoring monitor and analyze sentiment expression on social media platform. Example, real-time analysis track real-time sentiment around events, campaigning or brand mention. Influencer impact measure the impact or influencer of key opinion leaders on public sentiments. Crisis management detect and response to negative sentiment quickly to manage potential peer crisis. Brand reputation management maintain a positive brand image by addressing negative sentiment properly. Trend detection identify emerging trend and adapt strategies accordingly. Engagement strategy tailor social media engagement strategies based on sentiment insights. Market research purpose provide a valuable insight for market research, consumer behavior analysis, and competitive intelligence. Campaigning effectiveness evaluate the sentiment towards marketing, campaigning, and advertisement. Consumer insight understand the consumer preference, behavior, and attitude towards different product or service. Competitive benchmark compare sentiment towards your brand versus competitions. Benefit of Informed decision make data driven decision about product development, marketing strategies, and market position. Consumer trend identifying shifted in consumer behavior and preferred product launch optimization product launches by understanding market sentiment and readiness. Customer support and feedback analysis automatically classify and prioritize customer feedback in support system. Feedback categorization classify feedback into categories such as complaints, suggestion, or praise. Sentiment detection detect the sentiment of feedback to prioritize urgent or negative comments. Issue identification identify recurring issue or area needing improvement. Efficient support improve the efficient of customer support operating by automation, the classification and prioritization feedback. Customer satisfaction address customer issue promptly to enhance the satisfaction and loyalty. Resource allocation allocated resource effectively by focusing on critical areas highlights by the sentiment analysis. By leveraging sentiment analysis in the area, business can gain actionable insight, improve customer experience, and make more informed strategies decision. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about challenges and limitations. It is mentioned over here as contextual understanding, understanding sentiment in contextual reach and nouns text such as sarcasm, irony, and figurative language remain a challenge to for sentiment analysis system. Domain specificity sentiment analysis perform may vary across different domain, language, and culture require domain specific lexicon and model for accurate analysis. Data imbalance, imbalanced data set with unequal distribution of positive, negative, and neutral example can bias sentiment analysis model and affect performance. Subjectivity and ambiguity, subjective and ambiguous expression in text pose challenge for sentiment analysis as sentiments may vary based on individual interpretation and perceptions. Overall, sentiment analysis is a powerful NLP technique which a wide range of application in understanding public opinion, consumer sentiment and emotional responses in textual data. As NLP techniques continue to advance sentiment analysis, methods are expected to become more accurate, scalable and adaptable to diverse domain and languages. Based on these mentioned details, we can say that understanding sentiment in contextually rich and nouns takes such as sarcasm, irony, and figurative language. Example: a phrase like "Ye right, this is exactly what I needed," can be sarcastic, meaning the opposite of the it literally says. Sentiment analysis may misinterpret the true sentiment behind such expression. Advanced natural processing techniques are required to accurately detect and interpret context. Domain specificity analysis performance may vary across different domains, language, and culture. Example: word or phrases are positive on one domain. Example: killer performance in entertainment might be negative in another. Killer mistake in healthcare. Implications require the development of domain specific lexicon and models. Customization is needed to ensure accurate sentiment analysis in various contexts. Description is imbalanced dataset with unequal distribution of positive and negative and neutral example, a dataset heavily skewed towards positive reviews may lead to a model that struggles to accurately identify negative sentence. Bias in sentiment analysis model affected their performance. technique such as resampling, synthetic data generation, or adjusting training model to handle imbalance are necessary. Subjectivity and ambiguity challenges subjective and ambiguity expression in text. Example phrases like T, it's okay can be interpreted differently based on context and individual perceptions. Implication of difficulty in achieving consistent sentiment analysis result. Need for model that can handle various in individual interpretation and context. By addressing those challenges, sentiment analysis can be improving to provide more accurately and reliable insight across different application and context. The text highlight the significance of sentiment analysis and its feature potential in neural language processing. Overview of a sentiment analysis is a powerful NLP technique used to understand public opinion, consumer sentiment, and emotional responses from textual data. Application widely used in various fields such as marketing, customer service, market research, social media monitoring, and more. Current and future potential, current benefits, public opinion help in gauging public sentiment on issue, events, or political matters. Consumer sentiment assists business in understanding consumer opinion about product or services. Emotional responses identifies emotional tones in text, aiding in more nuanced customer interaction and support. Accuracy as NLP technique, advanced sentiment analysis is expected to become more precise in interpreting sentiments. Scalability improve algorithm and computational power will make sentiment analysis more scalable, handling larger volume of data efficiency. Adaptability, enhancing adaptability to diverse domain and languages will broaden its applicability and effectiveness across different contexts. The significance analysis is an essential tool in the modern data driven world, providing valuable insight into human emotion and option. Common improvement in NLP will enhance the capabilities of sentiment analysis, making it more integral part of various industry and application. By leveraging those advertisement, organization can better understand and respond to the sentiment expression in textual data, leading to more informed decision making and improved customer expression. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be learn about aspect based sentiment analysis. It's mentioned over here as aspect based sentiment analysis. ABSA is an advanced technique in natural language processing that aims to analyze and understand sentiment towards specific aspect or components within a pieces of text. Unlike traditional sentiment analysis, which provide an overall sentiment score for the entire text, ABSA delves deeper by identifying and analyzing sentiment expressed towards individual aspect or attribute of a product, service or topics. Here is an overview of aspect based sentiment analysis. It is mentioned over here as aspect based sentiment analysis is an refined approaches within the field of natural language processing that targets sentiment at more granular levels. Here is a detailed explanation of ABSA. ABSA is a technique that identifies and generalizes sentiment expression towards specific aspect or components within a piece of text. Granular analysis, traditionally sentiment analysis, provide an overall sentiment score for the entire text, categorizing it is as positive, negative, or neutral. ABSA breaks down the text into different aspects or attributes, analyze sentiment towards each aspect individually. Aspect identification. ABSA first identifies the aspect or attributes mentioned in the text. Aspects are specific components of features of a product, service, or topics. Sentiment detection. After identifying the aspects, ABSA determines the sentiment expression towards each aspect. This can include identifying whether the sentiment is positive, negative, or neutral for each specific aspects. Consider a restaurant review text. The food was excellent, but the service was terrible. Traditional sentiment analysis might classify the overall sentiment as mixed or neutral, balancing the positive and negative comments. ABSA aspect identification food and service as expected. Sentiment detection. Sentiment towards food is positive, sentiment towards service is negative. Application of ABSA product review help companies understand customer opinion about specific feature of their product. Example, battery life, camera quality in smartphone. Service feedback allow business to pin out strength and weakness in their service offering. Example, friendliness of staff, speed of service. Market research provide detailed insight into consumer preference, an area for improvement by analyzing specific product attributes. Social media monitoring analyze public sentiment towards various aspects of a topic or brand, helping in reputation management and strategy development. Benefits of ABSA offer a deeper understanding of consumer sentiment by focusing on individual aspect rather than the text as a whole, enabling business to making specific improvement based on aspect level feedback, enhance overall consumer satisfaction, enhance decision making, provide the actionable insight that can inform product development, making strategies, and common service enhancement. Aspect based sentiment analysis is an advanced NLP technique that offers more nuanced and detailed understanding of sentiment within the text. By focusing on individual aspect, ABSA provides the valuable insight that can drive targeted improvement and informed decision making in various applications from product review to social media monitoring. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about key components. It's mentioned over here as aspect, and aspect refer to a specific feature, attribute, or aspects of a product, service, or entities that is mentioned in the text. Example of aspect could include battery life for a smartphone, customer service for a company, or plot for a movie review. Sentiment refers to the polarity or emotional tone expressed towards a particular aspect. It can be positive, negative, or neutral. Workflow aspect extraction. The first step in ABSA is to identify and extract relevant aspect mentioned in the text. This can be done using techniques such as name entity recognition, parts of speech, tagging, or domain specific dictionaries. Sentiment classification. Once the aspects are identified, sentiment classification is performed to determine the sentiment polarity associated with each aspect. This involves classifying the sentiment expressed towards each aspect as positive, negative, or neutral. Aspect level analysis. After sentiment and classification, aspect level analysis is conducted to aggregate sentiment score and identify the overall sentiment towards each aspect. This may involve calculating sentiment score, generating aspect specific, summarize, or visualizing sentiment distribution. Based on these mentioned details, we can say that an aspect refers to a specific feature, attribute, or component of a product, service, or entities that is mentioned in the text. For a smartphone, aspect would including battery life, camera quality, screen resolution, etc. For a company, aspect might be customer service, pricing, product quality, etc. For a movie review, aspect could be plot, acting, special effects, soundtrack, etc. Importance of identifying aspect allow for a more detailed analysis of the text inside a general sentiment about entire product or service. You can understand how each specific feature is perceived. Sentiment refers to the polarity or emotional tone expressed towards a polarity aspect. It indicates whether the sentiment is positive, negative, or neutral. Example: positive sentiment indicates approval or satisfaction. Example: the battery life is fantastic, or the plot was very engaging. Negative sentiments indicate disapproval or dissatisfaction. Example: the customer service is terrible, or the social effect were disappointing. Neutral sentiment indicate a neutral or indifferent tone. Example: the screen resolution is okay, or the actionable was average. Understanding the sentiment towards each aspect provides granular insight. It helps business or analyst pinpoint exactly what consumer or user like or dislike about specific features of a product or service. When conducting aspect based sentiment analysis, both aspect and their components, sentiments are identifying as analyzed. This combination allow for detailed and actionable insight. Example: consider a product review for a smartphone. Takes the battery life is excellent, but the camera quality is poor. Aspect not identification: aspect 1 battery life, aspect 2 camera quality. Sentiment detection: sentiment towards the battery life is positive, sentiment towards the camera quality is negative. By analyzing both the aspect and sentiment, companies can see that while the battery life of the smartphone is appreciated by camera quality needed improvement, this detail level of feedback is more actionable compared to a general sentiment analysis of the entire review. In the aspect based sentiment analysis, aspect are the specific feature or attribute mentioned in the text. Sentiment is the emotional tone or polarity expressed towards each aspect. These approaches provide a deeper and more precise understanding of customer opinion, allow for targeted improvement and more informed decision making. Workflow here is an explanation of three main steps in aspect based sentiment analysis. Distribution of the first step in ABSA is to identify and extract relevant aspect mentioned in the text. Technique: name entity recognition: identify and classify name entities into text into predefined categories such as the name of person, organization, location, and other entities. Parts of speech tagging involves tagging word in a sentence with their respective parts of speech. Example: nouns, verb, adjective. Aspect are often nouns or noun phrase. Domain specific dictionary: use predefined dictionaries that list domain specific learns and phrases relevant to the aspect of interest. Example: the battery life of the smartphone is excellent. Aspect extraction identifies battery life as an aspect. Sentiment classification: once the aspects are identified, sentiment classification is performed to determine the sentiment polarity associated with each aspect. Process: the classification sentiment expressed towards each aspect is classified as positive, negative, or neutral. This can be done using various machine learning or rule based methods. Example: the battery life of the smartphone is excellent, but the camera quality is poor. Aspect extraction identifying battery life and camera quality as aspect. Sentiment classification, sentiment towards the battery life is classified as positive. Sentiment towards the camera quality is classified as negative. Aspect based level analysis definition after the sentiment classification, aspect level analysis is conducted to aggregate sentiment score to identify the overall sentiment towards each aspect. The process of sentiment score calculating sentiment score for each aspect. This could be a simple count of positive, negative, and neutral mention or a more complex scenario system. Summarization generalize summarize that highlights the overall sentiment towards each aspect. Visualization sentiment distribution to provide a clear view of how different aspects are perceived. Example, taste the battery life of the smartphone is excellent, but the camera quality is poor. Aspect extraction, battery life, camera quality, sentiment classification, sentiment for battery life positive, sentiment for camera quality negative. Aspect level analysis, sentiment score, positive sentiment score for battery life, negative sentiment score for camera quality. Summarization, user generally praise the battery life but criticize the camera quality. Visualization, a bar chart showing the positive sentiment score for battery life and the negative sentiment score for camera quality. Aspect-based sentiment analysis involve aspect extraction, identifying relevant aspect in the text using technique like NER, POS tagging, or domain-specific dictionaries. Sentiment classification, determining the sentiment polarity, positive, negative, neutral, associated with each aspect. Aspect level analysis, aggregating sentiment score and analyzing the overall sentiment towards each aspect, often through summarize or visualize. The detailed approaches allow businesses and analysts to gain precise insight into specific component of product, service, or topics, leading to more informed decision and targeted improvement. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about technique and approaches. It's mentioned over here as machine learning model, supervised machine learning model such as support vector machine, logistic regression or neural networks can be trained on label dataset for aspect based sentiment analysis. Lexicon based approaches, lexicon based method leverage sentiment lexicons or dictionaries containing aspect specific sentiment score to assign sentiment labels to each aspect mentioned in the text. Hybrid approaches combine machine learning technique with lexicon based methods or rule based heuristic to improve the accuracy and robustness of aspect based sentiment analysis. Based on these mentioned details, we can say that those approaches utilize supervised machine learning algorithm, classify data by finding the optimal hyperplane that separate different classes. Logistic regression uses a logistic function to model the probability of a certain class or event. Neural networks model that mimic the human brain structure capable of learning complex patterns in data. Uses those models are trained on labeled dataset where each example is tagged with aspect and their corresponding sentiments. Lexicon based approaches, those methods use predefined sentiment lexicons or dictionaries. Collection of words or phrases with assigned sentiments score specific to certain aspect. Aspect specific lexicon dictionaries tailored to capture sentiment related to particular aspect of the product or service. Uses text is analyzed by matching word or phrases to the lexicon, assigning sentiment based on the lexicon score. Those approaches combine elements from both machine learning and lexicon based method. Method combination of technique use machine learning model to handle complex pattern and lexicon for more precise sentiment scoring. Rule-based heuristic incorporate predefined rule to further refine sentiment analysis, leveraging both data-driven and rule-based insights. Users provide a more robust and accurate sentiment analysis by leveraging the strength of the multiple methods. Those approaches help in accurately determine the sentiment expressed in different aspects of the text, improving the insight that businesses can gain from customer feedbacks. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about application. It is mentioned over here as product review. ABSA is widely used in analyzing product reviews and feedbacks to identify sentiment towards specific product features or attributes. For example, in a smartphone review, ABSA can identify sentiment towards aspects such as camera quality, battery life, and performance. Social media monitoring (ABSA) can be applied in social media monitoring to analyze sentiment towards different aspects of a brand, company, or event mentioned in a social media post, tweets, or comments. Customer feedback analysis (ABSA) help businesses analyze customer feedback and support tickets to identify areas of improvement, prioritize issue, and understand customer sentiment towards different aspect of their product or service. Aspect identification, identifying the extracting relevant aspect from text accurately can be challenging, especially for complex and domain specific text. Fine grained sentiment analysis analyzing sentiment towards specific aspect require fine grained sentiment analysis technique capable of capturing nouns, sentiments, expression, data annotation and labeling. Creating annotated data set for aspect based sentiment analysis can be labor intensive and acquiring domain expert to ensure accurate labeling of aspect and sentiments. Based on these mentioned details, we can say that here is a detailed explanation of how aspect-based sentiment analysis is applied in different scenarios. ABSA is used to analyze product review and feedback to identify sentiment towards specific product features or attributes. Example, the camera quality of the smartphone is outstanding but the battery life is terrible. Aspect identifying camera quality, battery life. Sentiment analysis positive sentiment for camera quality, negative sentiment for battery life. Application companies can use those insights to understand which features are appreciated and which need improve. For instance, they may decide to enhance battery performance in future model while maintaining camera quality. Help manufacturer and retailers improve product design and functionality based on specific feedback. Provide details insight into customer preference and pain points. ABSA is applied to analyze sentiment towards different aspects of a bond, company, or event mentioned in the social media post, tweets, or comments. Example, the customer service at brand X is exceptional but their delivery times are too long. Aspect identification, customer service, delivery times. Sentiment analysis, positive sentiment for the customer service, negative sentiment for the delivery times. Application ban can minor social media to gauge public opinion and sentiment towards different aspects of their services or product. They can address negative sentiment quickly and leverage positive feedback for making benefits, enable real-time monitoring or brand reputations, helps in identifying the addressing potential issue quickly, provide insight into public opinion and emerging trend. Customer feedback analysis ABSA help business analysis customer feedback and support tickets to Identify area of improvement, prioritize issues, and understand customer sentiment towards different aspect of the product or service. Example, the interface of a software is user friendly but often crash when I try to save my work. Sentiment positive for interface, negative sentiment for crashes. Challenges is the aspect identifying the process of identifying and extract relevant aspect or feature mentioned in the text. Complex text is and domain specific text aspect may not be explicitly mentioned or may be reflected indirectly. Synonym and vibrations or phrases may be used to describe the same aspect. Context dependency, the relevant can aspect the dependent and context, making it difficult to accurately identifying without understanding surrounding text. I love the display of the phone, but it performs is super. Aspect identification, correctly identifying display and performance as aspect of the phone. Solution technique, name entity recognition, identifying the classifier name entities in text such as product features, person switch tagging, analyze the grammatical structure of help identify nouns and noun phrases that are likely to be aspects. Domain specific dictionary utilize predefined list of aspects relevant to specific domain to improve identification accuracy. Fine tuned grain sentiment analysis involve determining the sentiment expressed towards specific aspect, capturing noun sentiment expression. Challenges nouns expression sentiment can be suitable for nouns involving sarcasm, irony, or implement expression. Advanced NLP model utilize deep learning model like BERT or LSTM can be understand context, capture nouns and sentiments. Aspect specific sentiment lexicon develop that account for the sentiment variation specific to each aspect. The data annotation label creating the annotated data sets involving manually labeling text with identifying aspect and corresponding sentiment, which serves as training data for ABSA models. Challenge is labor intensive, manual annotation is time consuming and requires significant efforts. Domain expertise, accurate labeling, accurate knowledge of specific domain to understand the context of relevance of aspects. Consistency in ensuring consistency and accurate labeling across large dataset can be difficult. The user interface intuitive but the app crashes frequently. Labeling the user interface with a positive sentiment and app crashes with a negative sentiment. By addressing those challenges, ABSA can provide a more precise and detailed insight into customer opinion and sentiment, helping businesses make informed decisions and improve their product and services. This can be said after reading out this part. Now we will go to next particular discussion of previous chapter. It's mentioned over here as aspect-based sentiment analysis is a valuable technique in NLP, enabling deeper insight into sentiment expressed in textual data and providing actionable feedback for business to improve products, services, and customer experience. As NLP research progress, further advancement in ABSA are expected to enhance its accuracy, scalability, and applicability across diverse domains and languages. Based on these mentioned details, we can say that aspect-based sentiment analysis is a technique used in natural language processing to analyze the sentiment expressed in text at a more granular level instead of just determining whether a piece of text is positive, negative, or neutral overall. ABSA aims to identify the sentiment associated with specific aspect or feature mentioned in the text. For example, in the product review, ABSA can help identify not only whether the overall sentiment towards the product is positive or negative, but also the sentiment towards individuals, aspects such as the product design, performance, customer service, etc. This level of analysis provides deeper insight into customer opinion and preference. Businesses find ABSA valuable because it allows them to understand customer feedback. ABSA help businesses understand what aspect of their product or service customer like or dislike. This information is crucial for making targeted improvement and enhancement. Improve product and services by analyzing sentiment at granular level. Business can prioritize area for improvement and focus their effort on addressing specific pain point or enhanced feature that are well received. Enhance customer experience. ABSA enables businesses to tailor their offering based on customer feedback, leading to a better overall experience and increased customer satisfaction. As NLP researcher advance, we can expect further enhancement in ABSA in terms of accuracy. Improved algorithm and model will lead to more accurate sentiments analysis, reducing error and misinterpretation. Scalability. Advanced technique will enable ABSA to handle large volume of data efficient, making it scalable for analyze vast amount of textual data. Applicability across domain and languages. Researcher effort will focus on making ABSA application across diverse domain, healthcare, finance, hospitality, and language catering to broader range of industry and region. Overall, ABSA is a valuable tool for business making to leverage textual data for actionable insight and continuous improvement. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about machine translation and language generation. Machine translation, it's mentioned over here as machine translation MT in a natural language processing NLP is the task of automatically translating text from one language to another while preserving its meaning. MT system enable communication and information exchange across language barriers, facilitating multilingual communication in various domains. Here's an overview of machine translation in NLP. Based on these mentioned details, we can say that machine translation in natural language processing refers to a automated process of translating text from the one language to another while preserving its meaning. MT system utilize various techniques and models to understand the structure and semantics of the input text and general and equivalent translation in the target language. Types of machine translation. Rule-based machine translation, those systems rely on linguistic language and dictionaries to translate text. They work well for languages with clear grammatical rules but may struggle with complex or ambiguous sentence. Statistical MT statistical model are trained on large corpora to learn the probabilities of word sequence. These approaches can handle a wider range of languages paired but may not be capture nouns in meaning. Neural MT neural networks, particularly sequence to sequence model, have revolutionized MT. They can capture contextual information and produce more fluent and accurate translations, especially when trained on large datasets. Challenges in machine translation. Ambiguity. Language often have ambiguous words on phrases that can lead to incorrect translation. Context. Understand the context of sentence is crucial for accurate translation, especially for resolving pronouns and idiomatic expression. Rare languages. Building empty system for languages with limited resource or few training data can be challenging. Domain specific translation. Empty system may struggle with domain specific terminology or jargon. Application of machine translation, cross-border communication, MT facilitated communication between speakers of different languages in business, diplomacy, and personal interactions. Global content localization. Companies use MT to localize content such as website, software interface, and making material for international audience. Information access MD enables access to information in multiple languages, benefiting education, research, and knowledge sharing. Multilingual customer support. Business use MD to provide multilingual customer support through chatbots, email, and help desk system. Advanced in machine translation, neural MD advanced. Continued research in neural MT has led to improve in translation quality, especially for low resource languages. Multimodal translation integrated visual information, images, and videos into MT system for more accurate translation. Customization. Business can customize MT system for specific domain or terminology, improving translation accuracy. Machine plays a vital role in breaking down the language barriers and facilitating global communication and collaboration across diverse linguistic background. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about types of machine translation. It's mentioned over here as statistical machine translation is empty. Traditional approaches that relies on statistical model to learn translation patterns from parallel corpora source target language pairs. Neural machine translation (NMT) modern approach that use neural networks such as recurrent neural networks or transformer to directly model the mapping between source and target languages without relying on handcraft features. Rule-based machine translation uses linguistic rules and dictionaries to generate translation based on syntactic and semantic analysis. Neural machine translation (NMT) architecture NMT model typically consists of an encoder-decoder architecture. The encoder processes the input sentence in the source language and generates a fixed length representation, context vector, which is then decoded into the target language by the decorator. Sequence to sequence NMT model are trained end to end to maximize the likelihood of generating the correct target sentence given the source sentence. Attention mechanism allows the model to focus on relevant part of the input sentence during decoding, improving translation quality for long sentence. Based on these mentioned details, we can say that statistical machine translation is the traditional approaches to machine learning that relies on statistical model to learn translation pattern from parallel corpora, which are collection of text in two or more languages that are translations of each other. SMT model typically use technique like phrase-based translation or statistical alignment to identify pattern and generate translation. Advantages SMT system are relatively simple and computationally efficient. They can handle a wide range of language pair and can be trained on large dataset to improve translations quality. However, SMD system may struggle with capturing complex linguistic structure, handling rare or unseen words, and produce fluent translation, especially for language with significant syntactic difference. Neural machine translation (NMT) is a modern approach to the machine translation that leverage Neural networks such as recurrent neural networks or transformer model to directly model the mapping between source and target languages. Technique NMT system use encoder decoder architecture where the encoder process the input sentence and the decoder generate the corresponding translation. Advantages NMT has revolutionized machine translation by capturing context on long range dependencies better than SMT. It can produce more fluent and accurate translation, especially for complex sentence and low resource language. Challenges: training NMT model require large amount of data and computational resources. Fine tune for specific domain or language can also be challenging. Rule-based machine translation (RBMT) relies on linguistic rules and dictionary to generate translation based on syntactic and semantic analysis. Technique RBMT system use grammatical rules, lexicons, and morphological analysis to analyze the structure of the input sentence and generate a grammatically correct translation. Advantages: RBMT can produce high quality translations for language with well defined grammatical rules and limited linguistic variations. Challenges: RBMT system require extensive linguistic knowledge and manual rule creation, making them less adaptability to new languages or domains. They may struggle with handling idiomatic expression and capturing context. Neural machine translation model typically follow an encoding decoding architecture where the encoder processes the input sentence in the source language and generate a fixed length representation, also known as a context vector or through vector. The encoder uses recurrent neural networks, convolutional neural networks, or transformer based architecture to encode the input sentence into a semantic representation. Decorators also equipped with RNNs, LSTM, long short-term memory, or transformer takes the context vector generated by the encoder and generated the corresponding translation in the target languages. Sequence to sequence training NMT model are trained end to end using a sequence to sequence learning framework. This means the model learn to map sequence of word from the one language input sentence to sequence in another language output sequence. Objective: during training, the model maximize the likelihood of generating the correct target sentence given the source sentence. This is typically achieved using technique like maximum likelihood estimation or cross entropy loss. Attention mechanism in NMT allow the model to focus on relevant parts of the input sentence during the decoding process. This helps improve translation quality, especially for long sentences where certain words or phrases are more important for generating accurate translation. This attention mechanism calculated attention score for each word in the input sentence based on its relevance to the current decoding step. Those scores are used to weight the contribution of different parts of the input sentence when generating each word in the output sentence. Common types of attention mechanism including additive attention, multiplicative attention, and self-attention under in this transformation model. Overall, the encoder-decoder architecture, sequence-to-sequence training, and attention mechanism are fundamental components of modern natural machine translation system. They enable NMT models to capture more complex linguistic patterns, handle varying sentence length, and produce fluent and contextually accurate translations across different language peers. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about training in empty model. It's mentioned over here as parallel corpora. In empty model are trained on large parallel corpora containing sentence paired in the source and target languages. Word embeddings word in the input and output language are typically represented as dense word embeddings, example word to wake, globe, to capture semantic similarities. Training object NMT model are trained to minimize a loss function that measure the discrepancy between the predicted and actual translation such as cross entropy loss. Evaluation matrix BLEU score, the bilingual evaluation understudy score, measure the overlap between the mechanism generated translation and reference translation based on n-grams precision. TER score, the translation edit rate, measure the number of edits required to transform the machine generated translation into the reference translation. Human evaluation, human judge access the quality of translation based on fluency, adequacy, and overall quality. Based on these mentioned details, we can say that parallel corpora refer to a refer collection of sentence pair where each sentence in one language has corresponding translation in another languages. Those corpora are essential for training NMT model as they provide the necessary input output pairs for training translation patterns. Uses in NMT model are trained on parallel corpora to learn the mapping between source language, sentence, and their corresponding translation in the target languages. Quality and size. The quality and the size of the parallel corpora significantly impact the performance of NMT models. High quality and diverse parallel data lead to better translation quality and converge of linguistic variations. Word embeddings are dense vector representations of word in a continuous vector space. Each vector is mapped to a high dimensional vector where similar words are close together in the vector space, capturing semantic similarities. Uses is NMT in NMT words in the input and output languages are typically represented as word embeddings. Those embeddings capture semantic relationship between words and help the model learn meaningful representations of the input and output vocabulary. Training word embedding can be trained from scratch during NMT training pretend using method like word to vec globe or fast text on a large text corpora. Predent embedding are often used to initialize the embedding layer in NMD model, leveraging learned semantic relationships. Loss function NMD model are trained to minimize a loss function that measure the discrepancy between the predicted translation and actual translation in the training data. One common loss function used in NMT is cross entropy loss. Training process during training the model parameter including the weight of the encoder, decoder and attention mechanism are updated iteratively using optimization algorithm like stochastic gradient descent or ADAM. The goal is to minimize the loss function and improve the model's ability to generate accurate translation. Evaluation in MD model are evaluate the based on metrics such as BLEU, TER or human evaluation to access translation quality, fluency and adequacy. Let's explain the concept of BLEU score, TER score and human evaluation in context of evaluation mechanism. The BLEU score is the metric used to evaluate the quality of machine generated translation by comparing them to one or more reference translation. Calculation BLEU measured the overlap between the machine generated translation and the reference languages based on n-grams precision. It computes the precision of n-grams sequence of n words in the machine generated translation that also appear in the reference translation. Advantages of BLEU is a widely used metric in machine translation evaluation as it provides quantitative measure of translation quality and it relatively easy to compute. Limitation, however, BLEU has limitations such as being insensitive to syntactic accuracy, fluency, and sentence structure. It may also favor translations that contain similar engrams to reference translation, even if the overall translation quality is superb. T-year score is another metric used to evaluate machine generated translation by measuring the number of edits, insertion, deletion, substitution required to translate the machine generated translation into the reference translation. Calculation TER calculate the edit distance between the machine generated translation and reference translation. Lower TER score indicate better alignment with the reference translation. Advantages of TER provide a more fine-grained evaluation of translation quality by considering the specific edits need to match the reference translation. Limitations like BLEU TER may not fully capture semantic accuracy and may penalize translation for minor differences that do not significantly affect overall meaning. Human evaluation involves human judge accessing the quality of translations based on various criteria including fluency, naturalness of the language and adequacy of conveying of the meaning and the overall quality. Overall impression process human judge typically evaluate translation on a scale. Example 1 to 5. For each criteria provide qualitative feedback on strength and weakness. Advantages human evaluation provide a holistic assessment of translation quality considering factor that automated the metrics like BLEU and TER may overlook. Limitations human evaluation can be time consuming, subjective, and may vary depending on expertise and biases of the human judge. In summary, BLEU and TER score offer quantitative measure of translation quality based on overlap and edit distance, respectively, while human evaluation provide a more comprehensive and nuanced assessment considering factors like fluency, adequacy, and overall quality. Combined automated metrics with human evaluation can provide a balance and through evaluation of machine translation system. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about challenges in machine translation. It's mentioned over here as ambiguity. Translation ambiguity arise from polysemy, multiple meaning of words, and syntactic ambiguity, making it challenging for MT systems to select the correct translation. Rare and morphologically rich language MT performance tends to be lower for language with limited parallel corpora or complex morphological structure. Domain adaptation MT system trained on generic corpora may struggle to translate specialized or domain specific text accurately. Contextual understanding MT system may fail to capture context dependent meaning and idiomatic expression leading to error in translation. Based on these mentioned details, we can say that words often have multiple meanings, leading to ambiguity in translation. Empty system may struggle to determine the correct meaning of a word based on context, especially in case where multiple meanings are possible. Syntactic ambiguity sentence structure can be ambiguous, making it challenging for empty system or parts generated accurate translation. Ambiguities in syntactic structure can lead to incorrect translation. Rare and morphological rich language, limited parallel corpora empty system rely on parallel corpora for training, and language with limited parallel data may have lower translation quality due to insufficient training. Example: complex morphology language with complex morphological structure such as agglomerative or inflectional language pose challenge for empty system. Handling morphological variation and inflation accurately is crucial for producing grammatical correct translation. Domain adaptation, generic training data, empty system trained on generic corpora may not perform well when training specialized or domain specific text. Domain specific terminology, jargon, and context may not be adequately captured in generic training data. Domain specific adaptation techniques such as fine-tune empty model on domain-specific data or using domain-specific lexicons can improve translation accuracy for specialized text. Contextual understanding, contextual dependency translate text accurately require understanding the context and nouns of language use. Empty system may struggle with capturing context-dependent meaning, idiomatic expressions, and cultural nouns. Improving contextual understanding, advanced NMT model with attention mechanism and contextual embedding can improve contextual understanding by focusing on relevant part of the input sentence and capturing contextual information. Addressing those challenges in machine translation often involve a combination of advanced model technique, domain-specific training data, and continuous improvement in natural language understanding. Research in NLP aims to develop more robust and context-aware MT system to overcome those challenges and improve translation quality across different languages and domains. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about application of machine translation. It's mentioned over here as cross-lingual communication. Enabling communication and information exchange across language barriers in multilingual environment. Globalization facilitating international business, trade, and diplomacy by enabling translation of document, website, and communication channel. Content localization, adapting content such as website, software, interface, and making material to local languages and cultures. Language learning, supporting language learning by providing access to translated material and resources. Machine translation continue to be an active area of research in NLP with ongoing efforts to improve translation quality, address translation challenges, and develop models that can handle a wide range of language and domains. Based on these mentioned details, we can say that into each aspect of mention regarding the importance and application of machine translation, cross-lingual communication refers to enabling communication and information exchange across language barriers in multilingual environments. MT plays a crucial role in breaking down languages barriers and facilitating seamless communication between individual business and organizations speaking different languages. Example including real-time translation in multilingual meetings, conference, and online communication platform, enabling people to communicate effectively regardless of their native languages. Globalization involved the integrated of economics, culture, and societies on a global scale, often facilitated by technology and communication. Importance MT contribute to globalization by enabling international business, trade, diplomacy, and cultural exchange through the translation of documents, website, communication channel, and multimedia content. Application is used in translation, business document, legal contract, marketing material, website, and software interface for global audience, focusing collaboration and expanding market reach. Content localization involve adapting content such as website, software interface, making material and multimedia content to local languages, culture, and preference. Importance of MT8 in content localization by translating and adapting content to resonate with local audience, improve user experience, engaging and accessibility. Application of NT is used in website localization, software localization, multimedia localization, subtitle debugging, and marketing localization are tailored content for diverse linguistic and cultural context. Language learning refers to the process of acquiring proficiency in a new languages. Importance MT support language learned by providing access to translated material resources and educational content in learner native languages or target languages. Application of MT is used in translation, education and material, language learning apps, dictionaries and online resources facilitating language acquisition and cross-cultural understanding. Ongoing research and advance in NLP and machine translation focus on improving translation quality, addressing translation challenges such as ambiguity and context understanding, and developing model that can handle a wide range of language domain and use cases. MT continues to play a vital role in building linguistic barrier and fostering global communication, collaboration, and cultural exchange. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about language generation. It's mentioned over here as language generation in natural language processing refers to the task of automatically generating human text or speech based on a given input or context. Language generation technique enable machine to produce coherent and contextual relevant sentence, paragraphs, or even longer passages of text. Here's an overview of language generation in NLP. Based on these mentioned details, we can see that language generation in natural language processing refers to the task of automatically generating human like text or speech based on a given input or context. This task involves various techniques and models that enable machine to produce coherent, contextually relevant, and grammatically correct sentence paragraphs or longer passages of text. Here is an overview of language generating in NLP. Rule-based system, traditional rule-based system use linguistic rules and template to generate text based on predefined patterns. Those systems are limited by the complexity of rule and may struggle with generating natural surrounding text. Statistical language model such as Ingram's model or hidden Markov model learn the probabilistic of word sequence from training data and use this knowledge to generate text. However, they may produce repetitive or non-seasonal output due to limited context understanding. Natural language model Natural language model, particularly recurrent neural networks, long short-term memory networks, and transformer-based model, have revolutionized language generation. Those models can capture long-range dependencies, contextual information, and syntactic relationship, leading to more coherent and human-like text generation. Application of language generation, chatbots, and virtual assistant language generated is used in creating conversational agent, chatbot, and virtual assistant that can interact with user in natural language, understanding queries, and provide relevant responses. Content creation language generated is employed in content creating tasks such as generating product description, news article, social media post, and marketing copy. Summarization technique use language generation to generate conscious summary of longer text document of article. Dialogue system language generation is integral to dialogue system and conversational agent that engage in multi-turn conversational with user. Creative writing languages model can also be used for creative writing tasks such as generating poem, story, or dialogues. Challenges in language generation: ensuring that the generated text is coherent, contextual, relevant, and consistency throughout is a challenge. Avoiding bias and offensive content, language generation model need to be trained and fine-tuned to avoid generation bias or offensive content. Handling ambiguity, dealing with ambiguity in language such as polysemy and syntactic ambiguity in a challenge for language generation system. Context understand generating text that accurately reflect the input context and maintain logical flow is crucial but challenging. Overall language generation in NLP has diverse application and is continuously evolving with advancement in neural model, training technique and neural language understanding. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about types of language generation. It's mentioned over here as text generation, generating writing text in the form of sentence, paragraph, article, or stories. Speech synthesis, generating spoken language output in the form of synthesized speech or voice. Technique for language generation, rule-based generation using handcraft rule and template to generate text based on predefined grammatical and stylistic rules. Temple-based generation, filling in predefined temples with dynamically generated content to produce varied text output. Statistical language modeling using statistical model to estimate the likelihood of generating each word based on the input context or preceding words. Natural language models, deep learning models such as recurrent neural networks, transformer, and generative adversarial network trained to generate text based on learned pattern and context. Based on these mentioned details, we can say that text generation and speech synthesis are two related but distinct tasks in natural language processing. Text generation refers to the task of automatically generating writing text in the form of sentence, paragraph, article, or stories. Text generation can be achieved using various techniques including rule-based system, statistical language models, and neural language models. Application of text generation is used in chatbots, virtual assistant, content creation, summarization, dialogue system, and creating writing tasks. Challenges in text generation including maintaining coherence and consistency, avoiding bias and offensive coherence, handling ambiguity and understanding context to produce contextual relevant text. Speech synthesis, also known as text to speech, refer to the task of generating spoken languages output in the form of synthesized speech or voice. Technique: speech synthesis technique including concatenative synthesis using pre-recorded segment of speech, format synthesis, modeling speech production, and more recently neural networks based synthesis. Application of speech synthesis is used in applications such as virtual assistants, navigation system, accessibility tools for visually impaired individuals, and vice versa for multimedia content. Challenges in speech synthesis including generating natural surrounding speech with appropriate prosody, intonation, rhythm, stress, handling different accent and languages, and reduce the robotic or synthetic quality of synthesized speech. In summary, text generation focus on generating and writing text while speech synthesis focusing on generating spoken language output. Both tasks are essential in NLP and have applications across various domains, including communication system, accessibility tools, content creation, and entertainment. Advances in neural language model and speech synthesis technique have led to significant improvement in the quality and naturalness of generating text and synthesized speech, making those technologies increasingly useful and accessibility. Technique for language generation, rule-based generation involve using handcraft rules and templates to generate text based on predefined grammatical and stylistic rules. Rules are typically created by linguistic or domain expert and specific how different part of speech synthetic structure and semantic element should be combined to form coherent text. Advantages of rule-based generation allow for precise control over generating text structure, grammar, and style. It is suitable for generating text in domain with well-defined rules and requirements. Limitation rule-based system may struggle with handling ambiguities, generating natural sounding text, and adapting to diverse contexts or languages. Variation. Template-based generation Template-based generation involves filling in predefined template with dynamically generated context to produce variety text output. Technique temples consistence of placeholder for dynamic coherence such as variable slot or placeholder for words, phrases, or entities. The system then generated or selected appropriate content to fill the placeholder. Advantages template based generation allow for flexibility and variation in generating text while maintaining a consistent structure. It can be useful for generating personalized context from later or structured response. Limitations template based approaches may be limited by the complexity of template and need for diverse content source and challenging in generating natural sound text within the template context. Statistical language model use statistical model to estimate the likelihood of generating each word based on input context or preceding words. Technique such as ingram model, hidden Markov model, and conditional probability model are used to learn word probabilities and generating text based on those probabilities. Statistical language model can capture local context dependencies and generating text based on learned statistical pattern from training data. They are effective for generating fluent and coherent text in many applications. Limitation of statistical model may struggle with capturing long range dependencies, understanding complex semantic and adaptive to diverse language style or domain. Natural language model are deep learning models such as recurrent neural networks, transformer, and generative adversarial networks trained to generate text based on learned pattern and context. Neural language model leverage neural network to learn distributed representation of words capture long range dependencies and generated text fluently and coherently. Natural language models excel in capturing complex semantics, understanding context, and generating human-like text across diverse domain and style. They have led to significant improvement in text generation quality. Limitation of training neural language model require large amount of text and computational resource. They may also generate biased and non-sequential text if not properly trained or fine-tuned. In summary, different text generating approaches offer varying level of control, flexibility, and quality in generating text. Rule-based and temple-based approaches providing structure and control, but may lack of adaptability and naturalness. Statistical language model captures statistical pattern but may struggle with context understanding. Natural language model leverages deep learning technique to achieve high quality context aware text generation but require extensive training and resources. Each approach has its strength and limitation, making them suitable for different text generation tasks and application. This can be said after reading out this part. Now we will go to next particular discussion. Part we will be discussing about application of language generation. It's mentioned over here as text summarization, generating concise summarize of longer text while preserving key information and meaning. Chatbots and conversational agent generating responses to user query or prompts in natural language, enabling human-like interaction in conversational system. Machine translation generating translation of text from one language to another to facilitate cross linguistic communication. Text to speech synthesis converting written text into synthesized text or vice output for applications such as virtual assistant, navigation system, and audiobooks. Content generation automatically generating content for websites, social media posts, product description, and marketing material. Based on these mentioned details, we can say that text summarization involves generating conscious summaries of longer text while preserving key information and meaning. Technique text summarization technique including extractive methods, selecting important sentence or phrases from the original text, and abstractive methods generating new sentence and convey the essence of the original text. Application of text summarization is used in news aggregation, document summarization, research paper abstract, and content creation to provide user with condensed and digestible information. Chatbot conversational agent are systems that generate response to user queries or prompts in natural language, enabling human-like interaction in conversational system. Chatbot use natural language understanding (NLU) to interpret user and input natural language generation (NLG) to generate appropriate response technique including rule-based system, statistical model, and neural networks. Application of chatbot are used in customer support, virtual assistant, messaging platform, and interactive system to provide information, answer question, and engaging in conversation with user. Machine translation involves generating translation of text from one language to another to facilitate cross-lingual communication. MT technique including rule-based systems, statistical models such as perhaps-based and neural machine translation, and transformer-based model that learn to translate between languages. Application of MT is used in language localization, international businesses, diplomacy, education, and multilingual context dimensions to bridge language barrier and enable communication across diverse linguistic backgrounds. Text to speech synthesis involves the converting text into synthesized speech or voice output. TTA system use speech synthesis techniques such as quantitative synthesis, format synthesis, and neural network based synthesis to generate neural sounds speech from text. Application of TTS is used in virtual assistant navigation system, accessibility tool for visualize impaired individuals, voice cover for multimedia content and audiobook to provide spoken language output. Content generation involves automatically generating content for website, social media post, product description and making material. Content generation technique including template based generating, rule based system, statistical language modeling and neural language modeling tailored to specific the content type and domains. Content generation is used in content making, digital advertising, SEO optimization, and content automation to produce relevant, engaging, and scalable content for various platforms and audience. Those text generated tasks play crucial role in NLP application, enabling automated content creation, communication system, language translation, information summarization, human-like interaction in digital environment. Advance in NLP technique, particularly with neural language model and deep learning, have led to significant improvement in text generation quality, naturalness, and adaptability across different domain and use cases. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will learn about challenges in language generation. It's mentioned over here as coherence and consistency. Ensure that generated text is coherent, contextually relevant, and logically consistent. Naturalness, producing text that sounds natural and human-like in terms of style, tone, grammatically correctness. Diversity, generating diverse and variant text output to avoid repetitive or monotonous responses. Bias and fairness, addressing biases in language generation model to ensure fairness and inclusivity in generated content. Evaluation, developing metrics and method for evaluating the quality and appropriateness of generating text output. Approaches to evaluate automatic metrics using quantitative metrics such as perplexity, BLEU score, ROUGE score, and semantic similarity to evaluate the quality of generated text. Human evaluation, soliciting human judgment and feedback through the subjective evaluation, survey, or crowd source assessment to assess the naturalness, coherent, and relevant of generated text. Based on these mentioned details, we can say that coherent in text generation refers to the logical flow and connection between sentence or ideas, ensuring that the generated text is cohesive and understandable. Consistency involves maintaining a uniform style, tone, and information across the generated text, avoiding contradiction or abrupt shift in content. Importance of coherence and consistency are crucial for ensuring that generated text is contextually relevant, logically and consistency and easy to comprehend. Naturalness is in text generation refers to producing text that sounds natural and human-like in terms of style, tone, grammatical correctness, and idiomatic expression. Technique. Naturalness is achieved by training language model on large diverse dataset to capture natural language pattern, semantic and contextual dependencies. Importance of natural sounds, text enhance user experience, readability and engagement, making it more appealing and credible to reader or listener. Diversity in text generation involves generating text and varied text output to avoid repetitive or monotonous responses, provided user with more engaging and interesting content. Techniques such as sampling strategy, diversity promoting objective during training, and incorporating randomness can enhance text diversity. Importance of diversity prevent text generation continue from producing overly similar or predictable output, improving user satisfaction and preventing boredom. Bias in language generation refer to the presence of unfair or discriminatory language, stereotypes, or cultural bias in generating content. Fairness in text generation involve addressing biases in languages model and ensure that generated content is inclusive, respectful, and free from discriminatory languages. Mitigation techniques such as bias detection, bias aware training, debiasing method, and inclusive language guidance help mitigation bias and promote fairness in text generation model. Evaluation metrics develop metrics and method for evaluating the quality, coherence, naturalness, diversity, and fairness of generating text output. Human evaluation conducting human evaluation through user studies, survey, or expert judgment to assess the appropriateness, relevance, and overall quality of generating text. Automated evaluation using automatic metrics such as BLEU score, ROUGE score, perplexity, or novelty metrics to quantitatively evaluate text generation quality. Overall, addressing coherence, consistency, naturalness, diversity, bias, fairness, and developing robust evaluation method are critical aspects of text generation research and development. Those considerations help improve the quality, relevance, and user satisfaction of generated text across various applications and domain in natural language processing. Let's explain automatic metrics and human evaluation in context of evaluation the quality of generated text. Automatic metrics automatic metrics refer to quantitative measure used to evaluate the quality of generating text automatically without human intervention. Perplexity measure how well a language model predict a sample of text. Lower perplexity indicate better model performance in prediction the next word in a sentence. BLEU score BLEU score measure the overlap between machine generated translation and reference translation based on n-grams precision. Higher BLEU score indicate better alignment with reference translation. ROUGE score evaluate the quality of text summarization comparing generated summarize with reference summarize based on n-grams overlap and other similarity measure. Semantic similarity matrix access how semantically similar and generated text is to the reference text using method like word embedding, semantic vector, or similarity matrix. Purpose of automatically matrix provide objective and quantitative measure of text, generating quality, coherence, fluency, relevance, and similarity to reference text. They are useful for comparing different model, tuning hyperparameters, and track performance over time. Automatic metrics have limitations such as being insensitive to certain aspect of text quality like naturalness, context understanding, and semantic accuracy. They may not capture nouns in language use, idiomatic expression, or cultural relevance. Human evaluation involves soliciting human judgment and feedback through subject evaluation, survey, or crowded source assessment to assess the quality of naturalness, coherence, relevance, and overall impression of generated text. Human evaluation rate generated text on the scale for attributes like naturalness, coherence, relevance, and overall quality. Survey gather feedback from user or domain expert regarding their preference, comprehensive, and satisfaction with generated text. Crowdsource assessment, crowdsource platform like Amazon Mechanical Truck or professional evaluator are used to collect diverse opinion and judgment on text quality. Human evaluation provides qualitative insight, subject judgment, and nouns feedback on the strength, weakness, and user preference of generated text. It complements automatic metrics by capturing aspect of text quality that metrics may overlook. Human evaluation can be time consuming, subjective, and dependent on the expertise and biases of human evaluation. It may also require careful design, validation, and control to ensure reliable and meaningful result. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about future directions. It's mentioned over here as conditional generation, incorporating adding content or conditioning information. Example, user preference, dialogue history to generate more contextually relevant and personalized response. Multimodal generation, integrating multiple modalities such as text, images, and audio to generate rich and expressive multimodal content. Controllable generation, developing technique to control specific attribute or characters to generate text such as style, sentiment, or formalities. Ethical and responsible AI, addressing ethical considerations and societal impact of language generation, including bias mitigation, privacy preservation, and responsible development of language generation technologies. Language generation is a rapidly evolving area of research in NLP with ongoing efforts to develop more sophisticated models, improve generation quality, and address ethical and social implications. Advances in language generation have the potential to revolutionize human capture, computer interaction, content creation, and communication in various domains. Based on these mentioned details, we can say that conditional generation uses additional context or conditional information to produce more relevant and personalized text. Example, chatbot and virtual assistant by considering the user previous message, dialogue history. This system can provide more accurate and contextual appropriate responses. Content personalized news articles or advertisement can be tailored to individuals, user preference or browsing history, making the content more engaging and relevant. Enhancing user experience, personalized responses feel more natural and satisfying to user. Increasing engagement, content that aligns with user preference is more likely to capture and retain user interest. This approach combines multiple types of data such as text, images, and audio to create richer and more expressive content. Generating descriptive text for images which can help visually inspired user understand visual content. Video description combine audio analysis and visual data to generate comprehensive summaries or transcriptions of videos. Importance of improved accessibility help in making content accessibility to people with disability. Example, image description for the visually impaired. Enhancement communication provide more detailed and informative content by leveraging multiple data sources. Controllable generation technique that allow the adjustment of specific attribution or characteristics of the text generated text such as tone, sentiment, or formality. Example, customer service adapting the tone of responses to be more formal or informal based on the customer interaction. Creative writing allow writers to generate text in a specific style or mood, such as cheerful, suspenseful, or professional. Importance of flexibility provides the ability to tailor content to specify needs or audience improvement, communication effectiveness. Consistency ensure that the generated content align with the desired tone or style, which is crucial for brand voice and messaging. Addressing the ethical implementation and societal impacts of language generation technologies, key area of bias mitigation ensure that the model do not perpetuate or amplify bias present in the training data. This involves techniques like fairness award training and regular audits of model output, privacy preserving, protecting user data, and ensuring that personal information is not inadvertently disclosed in generated content. Responsible deployment, implementing safeguard to prevent the misuse of languages generation technologies such as generating harmful, mislead, or unethical content. Importance of trust and safety, building user trust, ensuring that AI systems are fair, transparent, and accountable. Regularity compliance, adhering to the legal and ethical standard, which is increasingly important, and regulations around AI and data privacy to become strict. Social responsibility contributed positively to society by ensuring that AI technologies are used in ways that benefited all users and do not cause harm. Overall impact of advantages in language generation, human computer interaction more natural and intuitive with AI system making technology more accessible and useful. Content creation, automation of various content generation tasks from news articles and reports to creative writing and making material significant increasing efficiently. Communication enhancement, communication capabilities, especially in multilingual and multicultural context, enabling better understanding, collaboration with different languages and cultures. Those absences languages generation are transformed various industry and application, driving innovation and improvement user experience across the broad. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about text summarization and question answering. Text summarization. It's mentioned over here as text summarization and question answering are two important tasks in natural language processing NLP that involve processing and understanding textual information. Here's an overview of each task. Based on these mentioned details, we can say that text summarization is a process of automatically generated concise and coherent summary of a longer text document while retaining the most important information and key points. Types of text summarization, extractive summarization. This method involves selecting and extracting key sentence, phrases, or section from the original text and combining them to from a summary. It relies on identifying important parts of the text without altering them. Example, given a long news article, an extractive summarization system might extract the most relevant sentence to form a summary. Abstractive summarization, this method involves understanding the main ideas of the original text and then generating new sentence that convey the some information. It is similar to how humans write summarize, requiring a deeper understanding of the content. Example, given a detailed report, an abstractive summarization system might rewrite the key point in a shorter form, potentially reshaping and combining information from different parts of the text. New aggregation summarization news article to provide quick overview of current events. Research creating concise summarization of academic paper or literature reviews. Legal documents summarize legal text for easier understanding and quick reference. Challenges of preserving coherence ensure that the summaries remain coherent and logically structured. Retaining key information accurately identifying and retaining the most important information while discarding irrelevant details. Abstracting generating natural and grammatical correct sentence in abstractive summarization. Question answering is the task of automatically answering question posed by humans in natural language. It involves understanding the question, retrieving relevant information, and generating a correct and concise answer. The system is trained to answer questions within a specific domain or subject area using a predefined set of information or a knowledge base. Example, a medical Q&A system answering questions related to disease and treatment. Open domain QA, the system is capable of answering a question on any topic by retrieving information from a broad and potential unstructured knowledge source such as the internet. Example, a general purpose of QA system like Google search engine answering question on a wide range of topics. Technique retrieval based QA, the system retrieval relevant document or passing from a large corpus and extracts the answer from those documents. Example, using search algorithm to find document related to the question and extracting the answer from the most relevant passages. Generative Q&A, the system generates an answer from scratch based on its understanding of the question and the available knowledges. Example, using transformer based model like GPT-4 to generate a natural language answer to the question. Application of a customer support providing automatic answer to common customer queries in chatbots and virtual assistant. Education assisting students by answering their question related to various subjects and providing explanation. Healthcare offering quick answer to medical questions, accessing both patients and healthcare professionals. Challenges understanding natural language accurately interpreted the question, especially when it involves complex or ambiguous languages. Information retrieval efficiently retrieval and processing relevant information from large and diverse dataset. Answering generator accurately relevant and contextually appropriate answers, especially in open domain settings. Importance of text summarization and question answering. Both tasks significantly improve their efficiency of information processing and retrieval, saving time for user by providing concise, summarize, and direct answering. Accessibility, making large volume of information more accessible and understandable to use regardless of their background knowledge. Enhance user experience, improving interaction with digital system by providing quick and accurate information tailored to user queries. Those tasks are fundamental to many applications in NLP and continue to evolve with advancement in machine learning and artificial intelligence, leading to more sophisticated and effective solution. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about text summarization. It's mentioned over here as text summarization is the process of generating a concise and coherent summary of a longer text while preserving its key information and main ideas. It aims to distill the most important content from a document or a set of document into a shorter form There are two main types of text summarization. Extractive summarization select and extracts important sentence or passages from the original text from the summary, often based on identifying informative sentence using statistical or heuristic method such as sentence importance score. Retain the original wording of the selected sentence. Abstractive summarization generates new sentences that capture the main ideas of the original text in a more compressed and coherent form. Involve understand the meaning of the text and reshaping in a concise manner. May involve techniques such as natural language modeling, sequence to sequence modeling, and attention mechanism. Based on these mentioned details, we can say that text summarization is the process of generating a concise and coherent summary of a longer text while preserving its key information and main ideas. It aims to distill the most important content from a document or a set of document into a shorter form. There are two main types of text summarization. Extractive summarization involves selecting and extracting key sentence perhaps or selecting more from the original text and combining them to form a summary. It relies on identifying important parts of the text without altering them. Sentence scoring are scored based on their importance using various techniques such as term frequency, inverse document frequency, position in the text, presence of certain keywords, or statistical and linguistic features. Selection: the top scoring sentence are selected and combined to create the summary. Advantages of easier to implement compared to abstractive method. Preservation of original meaning since it uses sentence directly from the source text, it maintains the original meaning and context. Disadvantages of extracting sentence might not flow well together and there might be a redundancy, lack of abstraction. It does not paraphrase or synthesize information which can limit the query of summary. Example, given news article and extractive summarization system might extract sentence that mention the key event, main actor and outcomes, combining them into a shorter version of the article. Abstractive summarization involves understanding the main ideas of a original text and then generating a new sentence that convey the some information. It is similar to how humans write summarize, requiring a deeper understanding of content. Text understanding: the system uses techniques such as deep learning and natural language understanding to comprehend and content of the text. Generation: it generates new sentences that summarize and main ideas of often reshaping or considering information from the source text. Advantages of abstract summarization tend to become more coherent and readable since they are generated to flow naturally. Reductance of reduction: it can effectively combine the condensed information reduction redundancy. Disadvantages of complexity: more challenging to implement and require advanced technique like neural network and transformer. Potentially for information loss, there is a risk of losing important details of the model does not fully understand the text. Example, given a detailed report, an abstractive summarization system might generate a summary that captures the main option point in the coincide and coherent manner, using newly generated sentence rather than extracting directly from the text. Importance and application of text summarization: new aggregation quickly providing readers with the main point of news article. Researcher helping researcher to get an overview of academic paper or literature review. Legal and financial documents summarizing lengthy legal text or financial report. for quick comparison. Customer service summarization, customer interaction or support tickets to identify key issue and resolution. Text summarization, whether extracting or abstractive, plays a crucial role in managing and understanding large volume of information efficiently, making it valuable tool in various fields and application. Here's a more detailed explanation of extractive and abstractive summarization. Extractive summarization, select and extract important sentence or passages from the original text to from the summary. It identifies and selects key sentence directly from the source text. Methods often uses statistical or heuristic method to determine sentence importance score. Original wording, retain the original wording and structure of a selected sentence. How it works: statistical method technique like term frequency, inverse document frequency, word frequency, and sentence position are used to score the importance of each sentence. Heuristic method use predefined rules or patterns to identify key sentences such as those containing certain keywords or occurring in specific section of the text. Ranking sentences are ranked based on their score and the top ranked sentences are selected to form the summary. Advantages of simplicity: easier to implement and requires less computational power. Accuracy in content, since it uses extract sentence from the text. The risk of distorting the original meaning is minimal. The disadvantage of coherence: the selected sentence may not flow well together, leading to a less coherent summary. Redundancy: they may be repeated information since it does not synthesize new content. Example given: a news article, an extractive summarization system might extract the first sentence from each paragraph or the sentence with the highest frequency of important keywords. Abstractive summarization generates new sentences that capture the main ideas of the original text in a more comprehensive and coherent form. The characteristics of new sentence generation creates new the summarize the text rather than directly extracting from it. Understanding and reshaping involve the understanding the meaning of the text and reshaping it in concise manner. Advanced technique may involve neural language model, sequence to sequence model, and attention mechanism. Its work like natural language model use deep learning models such as transformer to understand and generate text. Sequence to sequence model, those models take a sequence of a word as input and generate a sequence of sequence word as output, which can be a summary. Attention mechanism allows the model to focus on relevant parts of the input text while generating the summary, improving the quality and coherence of the output. Advantages of the generated summary is often more coherent and natural sounding. Reductant and redundancy can effectively combine and condense information, reducing reductant coherence. Disadvantage of complexity: more challenging to implement and require significant computational resource. Information loss: there is a risk of losing important details if the model does not fully understand the text. Example given: a detailed report and abstractive summarization system might generate a summary that conveys the key point in new concise sentence, such as the report highlights a 20% increase in sales driven by the new making strategy. Extractive summarization: select and extract important sentence technique, statistical and heuristic methods. Output: retrain the original wording. Abstractive summarization approaches generates a new sentence to summarize and main ideas. Technique: natural language model, sequence to sequence model, attention mechanism. Output: more coherent and compressed summarization with new wording. Both type of summarization have their own advantages and use cases, and the choice between them depending on specific requirement and constraint of the task at hand. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will learn about question answering. It's mentioned over here as question answering QA is the task of automatically generate accurate and relevant answer to question or post in natural language. QA system typically take a question as input and search for the relevant information in a given text corpus to produce the answer. There are different type of QA system. Factoid question answering answer question that require a specific piece of factual information. Example including who is the president of the United States or what is the capital of France. Non-factoid question answering answer question that require more complex reasoning or understanding of context. Example including why did World War II start or how does the human digestive system work. Based on these mentioned details, we can say that Q&A is the task of automatically generate accurate and relevant answer to question posed in natural languages. Q&A system typically take a question as input and search for the relevant information in a given text corpus to produce the answer. Factoid QA system answering questions that require a specific piece of factual information. Characteristics: the answers are typically short than the specifics such as name, dates, or place. Direct retrieval: the system often retrieves the answer directly from the knowledge base or text based corpus. Example: who is the President of the United States? Answer: Joe Biden. What What is the capital of France? Answer: Paris. When did the Titanic sink? Answer: April 15, 1912. Technique: information retrieval. The system uses technique to retrieval document or passages containing the factual information. Name entity recognition: identify the extract entities like name, dates, and location from the text. Pattern matching uses predefined patterns or templates to identify and extract answer. Application of search engine provide a quick factual answer to user queries. Virtual assistant answering basic question in personal assistant application like Siri or Alexa. Defining non-factoid QA system answering questions that require more complex reasoning or understanding of context. Characteristics: complex answering the question may involve explaining the descriptions or multi-sentence responses. Context understanding: the system must understand and context and provide a more detailed and nuanced answer. Example: why did World War II start? Answer: World War II started due to a combine of factors including territory, versatility, the rise of fascism, and the invasion of Poland by Nazi Germany. How does the human digestive system work? Answer: this is the so on kind of situation. So the technique is for natural language understanding. Use advanced technique to understand the question and context. Machine reading comprehension: read and comprehends longer text to extract and synthesize relevant information. Generative model C uses model like transformer to generate coherent and contextually appropriate answer. Application of these: education provided detailed explanation and answer to the student question. Customer support offering comprehensive responses to complex customer inquiries. Medical advice assistant in answering health related questions with detailed explanation. Importance and challenges in QA: QA system provide a quick and accurate answer. saving time and effort for user, makes information more accessible and understandable, especially for complex queries, enhance interaction, improve human computer interaction by enabling natural language queries and responses. Challenges in understanding natural language accurately interpreted the intent and context of the question, especially when the language is complex or ambiguous. Retrieving relevant information efficiently, finding and right information from large and diverse dataset. Generating accurately answer, ensuring the answer are correct, relevant and contextually appropriate, especially in non-factorial QA. Factorial QA is focused on specific factorial information, technique, information retrieval, name entity recognition, pattern matching. Example, who is the president of the United States? What is the capital of France? The non-factorial QA is the focus on complex reasoning understand, like why did World War II start? So after reading out this part, now we will go to next particular discussion. In this particular part, we will be discussing about technique and approaches. It's mentioned over here as information retrieval in QA, relevant document or passages are retrieved from a large corpus using techniques such as keyword matching, semantic similarity, or vector space model. Reading comprehension QA model employ technique to understand the context of the question and extract the answer from the retrieved document. This can be involved pre-trained language model, attention mechanism, and fine-tune on QA dataset. Semantic parsing for more complex questions. Semantic parsing technique may be used to convert natural language question into formal queries or logical forms that can be executed against structured knowledge base or databases. Based on these mentioned details, we can say that in QA information retrieval involves finding relevant documents or passages for a large corpus that contain the information needed to answer the question. Technique keyword matching, identifying document or passages that contain the same keyword as the question. Example, for the question, what is the capital of France? The system looks for document containing capital and France. Semantic similarity uses technique to find text that is semantically similar to the question even if does not contain the exact keyword. Example, for the question, who is the president of the United States? It might also consider current US president or Joe Biden's role. Vector space model representation the document or query as a vector in a multi-dimensional space using technique like TF-IDF or word embedding. The relevance is determined by the coincide similarity between those vectors. Example, documents are ranked based on how closely their vector representation align with the quick vector. Importance of quickly narrows down the search space to relevant document, making the QA process faster. Accuracy ensure that only potential useful information is considered for further processing. Reading comprehension Reading comprehension in QA involve understanding context of the question and extracting the answer from retrieved document. Technique pre-training model uses model like BERT, GPT or robot that have been pre-trained on large text corpora and can be understand natural language context. Example, fine-tuning BERT on a QA dataset enable it to predict the start and end position of answering within a passage. Attention mechanism focusing on the most relevant part of the text when answering the question using technique like self-attention in transformer. Example, in transformer model, attention weight highlight which word or phrases in the passages are most relevant to the question. Fine tune on QA dataset, adapt pre-trained models specially for QA tasks using dataset like SQUAD, Stanford Question Answering Dataset. Example training model on QUAD helps it learn to extract the precise answer from the passages. Importance context understanding, enhancing the model ability to comprehend and interpret the context of both the answer and the text. Accuracy extraction improve the accuracy of pinpoints the extract answer within a document. Semantic parsing involves converting natural languages question into a formal queries or logical format that can be executed against the structured knowledge based on the or dataset. Technique like natural language or logical forms, translation natural language questions into a logical form, structure query languages. Example, the question what is the popular of Japan is converted into an SQL query. Select population from countries where name equals to Japan. Knowledge-based querying executed the generated logical form against a structured knowledge base to retrieve precise information. Example, a semantic words might generate SPA query to retrieve data from a RDF resource description framework knowledge base. Combines information retrieval with semantic parsing to handle both unstructured and structured data. Example, first retrieve relevant document using IR, then parses the text from structured queries. Importance of complex question handling, enabling the system to handle more complex and comprehensible questions that require logical reasoning. Structured data access allow QA system to leverage structured data in knowledge base, providing more accurate and contextually relevant answer. After reading out this part, now we will go to next particular discussion. In this particular part, we will be discussing about application. It's mentioned over here as search engine text summarization help generate snap for search engine result while QA system improve the relevance and accuracy of search result. Document summarization summarize long document or articles to provide user quick overviews or key points. Customer support QA system can be used to automatically answer customer queries or provide assistance through chatbots. Educational tool summarization and QA system can be used in educational setting to help student understanding complex topic and find relevant information. Based on these mentioned details, we can say that application of how text summarization and question answering system are applied in various domains. Role of generate snap for searching engine result. Function when a user search for something, search engine provide a brief summary or snap from the relevant web pages in a result form. Benefit helps us quickly understand the context of the web pages and decided which links to click on. Example, a search for benefit of exercise might show snap summaries, key points like exercise improve mental health, reduce risk of chronic disease and enhance the physical fitness. QA system roles improve the relevance and accuracy of search result. Function directly answering specific queries by retrieving relevant information from a large corpus. Benefit of provides user with a precise answer to the question without need to shift to multiple documents. Example, asking we invent the light bulb would return the answer Thomas Edison along with the relevant support information. Document summarization, long document or article to provide user with a quick overviews or key points. Function like condense information, extract the most important information from a lengthy text to create coincide summarization. Enhance understanding, help user to grasp the main ideas without reading the entire document. Application of business reports, summarization financial report or market analysis to provide executive with key insights. New article summarization, new article to give reader to a quick overview or current events. Example, a summary of a research paper might include the purpose of a study, key finding and implementation, helping the readers to quick understand the main points. Customer support QA system can automatically answer the customer queries or provide assistance through chatbots. Function automated assistant uses QA system to handle routine inquiries and providing instant responses to common questions. Improve efficiency, reduce the workload on human customer support agent by automated repetitive tasks. Application of chatbot virtual assistant on website that can answer FAQs, guide user through process or troubleshoot issues. Support tickets automatically providing answer or suggesting solution based on previous support cases. Example, a customer asking how can I reset my password can receive a direct answer or be guided through the step by a chatbot. Educational tools, definition, summarization, and QA system help students understand complex topic and find relevant information. Text summarization role summarize textbook, research paper, and other educational material. Providing students with concise summarize help them focus on key component and important details. Example, summarizing a chapter on photosynthesis to highlight the main process and function involved. QA system answer the specific question related to the course content or study material. Benefit of assisting student in finding precise answer to their queries, aiding in their learning process. Example, a student asking what are the causes of the French Revolution. Receiver a detailed explanation conveying a man economic, social and political factors. After reading out this part, now we will go to next particular discussion. This particular part we will be discussing about challenges. It is mentioned over here as understanding context, both text summarization and QA system face challenges in understanding the context of the text and generating accurate and relevant summarize or answer. Handling ambiguity, dealing with the linguistic ambiguity, especially in abstract summarization and non-factoid QA, where multiple interpretation may exist. Evaluation, developing robust evaluation metrics for accessing the quality and relevance and summarize an answer which may involve human judgments or automatic evaluation method. Text summarization and question answering are essential tasks in NLP with numerous applications across various domains. Advanced in machine learning and NLP technique continue to improve the performance and capabilities of system for those tasks, enabling more efficient information process and retrieval. Based on these mentioned details, we can say that an explanation of a challenges factor by text summarization and question answering. Understanding the context of text summarization and QA system, both types of system must be accurately understand the context of a text process, generate relevant and coherent outputs. This involves interpreting the nouns of languages, recognizing relationship between different parts of speech, text, and maintaining coherence in the generated summary or answering. Detailed contextual understanding requires deep language understanding to grasp implicit meaning, reference, and the overall narrative. Example summarization: a news article about a political event required understanding the background, the main actors involved, and the significance of the event. Context preserving: for QA, the system needs to ensure that the answer is consistent with the context of the question and the source document. Example answering the question, what did the president say about climate changes? Involve locating and accurately interpreted the relevant section of a speech or article. Handling ambiguity challenges: linguistic ambiguity, both summarization and QA system must manage the inherent ambiguity in natural language. This is the particularly challenging in abstractive summarization and non-factoid QA, where multiple valid interpretation may exist. Details abstraction summarization involves generating new sentences that may introduce or resolving ambiguities different than the other original text. Example summarization is a scientific article may require considering complex information while ensuring the key point remaining clear the ambiguous. Non-factorial QA require understanding and reasoning about open-ended questions that don't have straightforward answer. Example for the question, why did the World War II start? The system must synthesize the information from multiple sources if possible, providing different perspectives or reason. Challenges of developing robust metrics: accessing the quality and relevant or generated summarize and answer is complex and often require a combining of human judgment and automatic evaluation method. Detailed human judgment involve using human evaluator to access the coherence, accuracy, relevance, and informativeness of the outputs. Example, a human evaluator might score a summary based on how well it capture the main idea of the original text and its readability. Automatic evaluation method include metrics such as ROUGE for summarization and BLEU for QA, which compare the generated output to reference output. Example, ROUGE score measure overlap between the generated summary and a set of reference summarize, while blue scoring access the quality of machine translated text against the reference translation. Challenges with matrix: automatic matrix may not always capture the true quality of the output, especially for more nouns aspect like coherence and factual correctness. Example, a summary might score highly on ROUGE but fail to accurately convey the main point or maintain coherence. The understanding of context, both summarization and QA system need to accurately interpret and mean the context of the text, produce relevant and coherent outputs. Handling ambiguity, managing linguistic ambiguity is crucial, especially in abstractive summarization and non-factorial QA, where multiple valid interpretation may exist. Evaluation: develop robust evaluation matrix is essential for accessing the quality and relevance of generated summarize and answering, requiring a mix of human judgments and automatic methods. Text summarization define the process of coincides the coherent summary or a longer text while preserving its key information and main ideas. After reading out this part, we can understand this thing. Now we will go to next particular discussion. In this particular part, we will be discussing about advanced topic in NLP. It's mentioned over here as deep learning architecture have revolutionized natural language processing, enabling sufficient advancement in various tasks such as language modeling, text classification, machine translation, and more. Here are some key deep learning architecture commonly used in NLP. Based on these mentioned details, we can say that recurrent neural network RNN are designed to process sequential of data by maintaining a hidden state that capture information from previous element in the sequence. Uses in NLP, they are used for tasks like language modeling, sentiment analysis, and sequence leveling, where the order of word or tokens matter. Long short-term memory network are variant of RNN designed to address the vanishing gathering problem, enabling them to capture long-term dependencies in sequence. Uses in NLP, LSTM are commonly used in tasks require understanding of context over longer sequence such as machine translation and text generation. Gated recurrent unit GRU purpose of use similar to LSTM. GRU are designed to capture long-term dependencies in sequence while being computationally more efficient. Use in NLP, GRU are used in tasks where memory efficiency is crucial, such as language modeling and sentiment analysis. Convolutional neural network are primarily used for image processing but can be also applied to tasks data by treating text as a one-dimensional sequence. Uses in NLP are used for tasks like text classification, sentiment analysis, and name entity recognition by learning hierarchical representation of text. Transformer modeling revolutionized NLP with their attention mechanism enabling parallel processing of tokens in sequence and capturing long range dependency effectively. Uses in NLP transformer based architecture like Word, GPT, and T5 are used for wide range of tasks including language understanding, text generation, and question answering. Encoder decoder architecture, those architecture are often based on RNN transformer are used for sequence to sequence task where an input sequence is transformed into an output sequence. Uses in NLP, they are used in machine translation, text summarization, and dialogue generation tasks. Those architecture, along with variants and combination, have significant advanced the capabilities of NLP model, allowing them to handle complex language tasks with high accuracy and efficiency. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about recurrent neural networks. It's mentioned over here as prescription RNNs are designed to handle sequential data by maintaining hidden state that capture information from previous time state. They are well situated for tasks requiring sequential processing such as language modeling, text generation, and sentiment analysis. Variants, long short-term memories, LSTM, and gated recurrent unit GRU are popular variant of RNN that address the vanishing gradient problem and capture long-term dependencies more effectively. Convolutional neural network CNNs are widely used for image processing tasks but have also been successfully applied to NLP tasks such as text classification and sequence labeling. In NLP, CNN operate over 1D sequence. Example, word embeddings and capture local pattern and feature through convolutional operation following by pooling layers. Application of text classification, sentiment analysis, and name entity recognition. Based on these mentioned details, we can say that RNN are designed to process a sequence of data by maintaining hidden state that capture information from previous step. This allows them to capture temporal dependencies in data. They are commonly used in tasks involve sequential processing such as language modeling predicting the next word in a sentence, text generation creating new text based on a given input, and sentiment analysis determine the sentiment of emotion expressed in a text. LSTM is a variant of RNN designed to address vanishing gradient problem which occur when training deep networks with the traditional RNN's LSTM use a gating mechanism to selective remember to or forget information over time, making them more effective at capturing long-term dependencies. Uses of LSTM are commonly used in tasks where understanding context over longer sequence is crucial such as machine translation and text generation. GRU is another variant of RNN that is simpler than LSTM but also effective in capturing long-term dependencies. It combines aspects of LSTM such as gathering mechanism but with a reduced number of parameters. GRU are often used in scenarios where memory efficiency is important, such as in language modeling and sentiment analysis tasks. Those variants of RNN, especially LSTM and GRU, have significantly improved the ability of neural networks to handle sequence data and have more fundamental in many NLP applications. CNN are primarily known for their effectiveness in image text tasks where they use convolution layer to extract spiral pattern and feature from images. However, they have also found success in NLP tasks by operating over 1D sequence such as word embedding or character sequence. In NLP, CNNs process text data by applying convolutional operation to capture local patterns and features within the text. This is followed by a pooling layer to reduce dimensionality and extract the most important information. CNN are widely used in NLP such as text classification, assigning a level or category to a piece of text. Sentiment analysis determine the sentiment expressed in a text and name entity recognition identify and classifying name entities like names, organization and location in text. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part we will be discussing about transformer. It's mentioned over here as prescription transformer are self-attention based model that can capture global dependencies across input sequence efficiently. They consist of multiple layers of self-attention mechanism and feed-forward neural networks. Transformers have become the state-of-the-art architecture for many NLP tasks, especially in tasks require long-range dependencies and context understanding. Application of machine translation, text generation, and language modeling, question answering. Bidirectional encoder representations from transformer. Word. Word is a pretend transformer based model that has achieved remarkable performance across a wide range of NLP tasks. It is trained on large corpora of text data using unsupervised learning object, allowing it to capture deep contextual representation of word and sentence. Application name entity recognition, text classification, question answering, sentiment analysis. Based on these mentioned details, we can say that transformer, a deep learning model based on self-attention mechanism, allow them to capture global dependencies across input sequence efficiently. This consists of multiple layers of self-attention mechanism and feed-forward neural networks. Self-attention allows each word token in the input sequence to attend to all the other words token, capturing dependencies and relationship regardless of their distance in the sequence. This ability to capture long-range dependencies in a significant advantage of transformer. State of the art. Transformer have indeed become the state of the art. architecture for many NLP tasks due to their effectiveness in understanding context and handling long range dependencies. Application of transformer are widely used in machine translation tasks where they can effectively translate text between different languages by capturing contextual information and dependencies. Text generation they can also use in text generation tasks such as generating human-like text based on a given prompt or context. Model like GPT, generative pre-trained transformer excel in this area. Language modeling are used for language modeling tasks where they learn the probability distribution of the word in a language, sequential for like speech recognition and auto completion. Question answering task transformer can process question answering and context to generate accurate answer. As seen in model like bird, transformer have significant advanced capabilities of NLP model, especially in tasks required and understanding of context and long range dependencies. Bidirectional encoder representations from transformers is the pre-trained transformer-based model that have achieved remarkable performance in various NLP tasks. It stand out for its bidirectional nature, allowed it to consider context from both directions, left to right and right to left during training. Training BERT is a trained on a large corpus of text data using unsupervised learning object such as mask language modeling, prediction mask word in a sentence and next sentence prediction, determining if two sentences follow each other in a original text. Representation by pre-training on a vast amount of data, BERT captures deep contextual representation of word and sentence, enabling it to understand nouns and context in text data. Application of name entity recognition word is effective in any a task where it can accurately identify and classify name entities like names, organizations, and location in text. Text classification word excel in text classification task where it can assign a label or category to a piece of text where high accuracy making it useful for tasks like a spam detection, sentiment analysis, and topic categorization. Question answering word is a use in QA task where it can process question and context to generate accurate answer. It achieves significant success in benchmark like the Stanford question answering dataset SQUAD. Sentiment analysis word is also applied in sentiment analysis task, determining the sentiment or emotion expressed in piece of text such as product review or social media post. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about generative pre-trained transformer GPT. It's mentioned over here as description. GPT is another pre-trained transformer based model that focus on text generation task. It is trained using autogressive language modeling object where the model predicts the next word in a sequence given the previous word. GPT has been used for various text generation tasks including dialogue generation, story generation, and code generation. Application text generation, dialogue system, code generation. Encoder decoder architecture. Description encoder decoder architecture such as sequence to sequence models consist of two main components, an encoder that processes the input sequence and a decoder that generates the output sequence. Those architectures have been widely used for machine translation, text summarization, and other sequence to sequence tasks. Application like machine translation, text summarization, and speech recognition. Based on these mentioned details, we can say that GPT is a pre-trained transformer-based model that is specialized in text generation tasks. It is training using autoregressive model object, where the model predicts the next word in a sequence given previous word. This train approach allows GPT to generate coherent and contextual relevant text. Autoaggressive model in autoaggressive language, the model generates text one word at a time. Condition each prediction on the previous generated word. This enables GPT to capture dependencies and structure of natural language text. Versatility GPT model, particularly version like GPT-2 and GPT-3, are known for their versatility and ability to generate high quality text across a wide range of domains and topics. Application of text generation GPT is primarily used for text generation tasks where it can generate human like text based on given prompt or context. These include tasks like story generation, article completion, and creative writing. Dialogue system GPT has been applied in dialogue system and chatbots where it can engage in conversational and provide contextual relevant responses based on ongoing dialogue. Code generation GPT model have also been used for code generation tasks where they can generate code snap based on input specification or description. Overall, GPT strength lies in the ability to generate coherent and contextual relevant text, making it valuable tool for various text generation applications. Encoder and decoder architecture, particularly sequence to sequence model, are fundamental component in natural language processing. Tasks that involve converting one sequence of data into another. Encoder component of an encoder decoder architecture processing the input sequence. It typically converts the input data such as sentence in natural language into a fixed length vector representation called a context vector or Latin representation. These vectors contain semantic information about the input sequence. Decoder, the decoder component task that context vector generated by the encoder and use it for generated the output sequence. In tasks like machine translation, the decoder generates a sequence of words in the target language based on context vector. Each word in output sentence is generated based on previously generated word and the context vector. Application of machine translation, one of the most prominent application of encoder decoder architecture is in machine translation. Here is the input sequence is typically a sentence in one language, source language, and the output sequence is translated sentence in another language. Target sequence, the encoder process the source sentence while the decoder generates the translation sentence. Text summarization encoder decoder models are used in text summarization tasks. The input sequence is longer pieces of text such as article and the output sequence is a coincident summary of the text. The encoder captures the essential information from the input text and decoder generate a summary based on this information. Speech recognition is encoder decoder architecture can be used in convert audio input speech signal into text output. The encoder processes the audio data, extracting relevant features, and the decoder generates the corresponding text representation. Those applications demonstrate the versatility of encoder decoder architecture, making them valuable tool in various NLP tasks where sequence to sequence transformers are required. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about transformer learning and fine tune. It's mentioned over here as description. Many pretend deep learning model trained on large text corpora are available allow for transformer learning and fine tune on specific NLP tasks. with limited level data. This approach has become increasingly popular and effective for various NLP tasks. Application name entity recognition, sentiment analysis, and text classification. Those are just a few examples of deep learning architecture that have had a significant impact on NLP. Continued research and advancement in deep learning continue to drive progress in NLP, enabling the development of more accurate, efficient, and versatility model for understanding and processing natural language. Based on these mentioned details, we can say that pre-trained deep learning model have the field of natural language processing by offering a way to leverage the large amount of labeled text data for various tasks. Pre-trained model are deep learning models that are initially trained on vast amount of text data such as Wikipedia article, news article, book and other source during this pre-trained phase. The model learns general language pattern, semantic relationship and syntactic architecture. Transfer learning after pre-trained, those models can be fine-tuned or adapt to specific NLP tasks with limited label data. This purpose is known as transfer learning, where the knowledge gained from pre-trained is transferred to the task, helping the model learn task-specific pattern and nouns. Advantages of pre-trained allow model to learn from diverse and extensive text corpora, capturing a broad range of language features. Reduce data dependencies, fine-tune on specific tasks, require less level data compared to training a model from scratch, making it more feasible for tasks with limited annotated data. Improved performance transfer learning often lead to improved performance on target tasks as the model already has a good understanding of languages, semantic and structures. Application of name entity recognition pre-trained model can be fine-tuned for any task where the goal is identify and classify entities such as names of people, organization, location, etc. within text. Sentiment analysis model are pre-trained on large text corpora can be fine-tuned for sentiment analysis tasks, classifying text into positive, negative, or neutral sentiment based on the context. Text classification pre-trained model are effective for text classification tasks such as categorization, documents, email, or social media posts into predefined class or categories. Impact on NLP, those availability of pre-trained model and the adaptation of transfer learning have significant advanced the field of NLP by allow researcher and developer to build more accurate and efficient model with less data and computation resource, enabling the develop of domain specific NLP solution by fine-tuned model on specialized dataset, driving continuous progress in NLP through ongoing research and improvement in deep learning technique, leading to more sophisticated and versatile model for understanding and processing natural language. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about ethical and responsible AI in NLP. It's mentioned over here as ethical and responsible AI in natural language processing NLP refers to the principle, guidelines, and practice aimed at ensure that NLP systems are developed, deployed, and used in a manner that respect ethical considerations, societal value, and human rights. Here are some key aspects of ethical and responsible AI in NLP. Fairness and bias. Fair representation ensure that NLP model and system provide a fair and unbiased treatment to all individuals regardless of their demographic characteristics such as race, gender, or ethnicity. Bias detection and mitigation, identifying and mitigation bias in training data, algorithms, and decision making process to prevent discriminatory outcomes in NLP application. Diverse representation promoting diversity and inclusivity in NLP research dataset and term to mitigate bias and ensure equitable representation. Based on these mentioned details, we can say that ethical and responsible AI in natural language processing involve adhering to principles, guidelines, and practice that prioritize ethical considerations, societal value, and human rights throughout the development, deployment, and use of NLP system. Here are some key aspects of ethical and responsible AI in NLP. Fairness and biases mitigation ensure that NLP systems do not exhibit biases or discrimination against individuals or groups based on attributes such as race, gender, ethnicity, or societal economic status. This provides mitigation bias in data algorithms and decision making process to promote fairness and equity. Transparency and explainability, providing transparency into how NLP system work, including the data used for training, the algorithm employed, the decision making process. Explainability enable user and stakeholder to understand the reasoning behind NLP system output and decision, fostering trust and accountability. Privacy and data protection representing user privacy and safeguard sensitivity information during data collection, stored, processing and sharing NLP system should completely with privacy regulation and implement robust data protection measure to prevent unauthorized access or misuse of personal data. Human-centered design NLP system with a focus on user needs, performance, and well-being. This involves considering the potential impact of NLP technologies on individual, communities, and society at large, and designing systems that prioritize user empowerment, safety, and autonomy. Accountability and governance, establishing clear accountability framework and governance mechanism for NLP deployment, development and uses. This includes defining roles and responsibilities, conducting ethical impact assessment, and implementing mechanism for addressing ethical issue, complement or biases that may arise. Bias detection and mitigation, implementing technique for detection and mitigating bias in NLP systems such as bias aware training, fairness aware algorithms, and bias testing evaluation. Continuous monitoring and auditing of NLP system can help identifying and address biases over time. Ethical use case and application, ensuring that NLP technologies are used for ethical purpose and beneficial application that contribute positively to society. This involves considering the potential ethical implementation of NLP use case such as misinformation detection, content moderation, and sentiment analysis in sensitive domains. Fairness and bias, representation, bias detection and mitigation, and diverse representation of essential components of ethical and responsible AI in natural language processing. Here is an explanation of each aspect. Fair representation in NLP refers to ensure that NLP model and system provide fair and unbiased treatment to all individuals regardless of their demographic characteristics such as race, gender, and ethnicity. This involves avoiding biases. NLP systems should be trained on diverse and representative dataset to avoid biases that may lead to discriminatory outcomes. Fair treatment, NLP algorithm, and decision making process should treat all individuals fairly and equitably without favoring or discriminating against specific groups. Bias detection and mitigation in NLP are crucial for identifying and addressing biases in training data, algorithms, and decision making processes. Key aspects including data biases, identifying biases in training data such as underrepresentation or skewed distribution. and taking steps to address those biases during data collection and pre-processing. Algorithmic biases evaluating NLP algorithm for bias that may lead to unfair or discriminatory outcomes and implementing technique to mitigate those biases such as debiasing algorithm or using fairness over training models. Decision making biases ensuring that NLP system make decision based on objective criteria and do not biases or stereotype in their outputs. Diverse representation of in NLP involve promoting diversity and inclusivity in NLP research, dataset and terms to mitigate bias and ensure equitability representation. This include diverse using dataset that encompass a wide range of language, culture, representative and experience to learn NLP model and ensure they generalize well across diverse populations. Team diversity encoding diversity within NLP research term, including individuals from diverse background, disciplines and perspective to foster innovation, mitigation biases and promote inclusive design practice. Inclusive research conducting research that consider the needs of performance and experience of diverse community and stakeholders, leading to more inclusive and ethically sound NLP solution. By prioritizing fair representation, bias detection and mitigation, and diverse representation in NLP, organization and researcher can build more ethical, inclusive, and equitable AI system that benefits society as a whole. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about transparency and explainability. It's mentioned over here as model transparency, providing transparency into the working of NLP model and system, including their output mappings, decision making process, and underlying assumptions. Explainability developing technique to explain the decision and prediction made by NLP model in a human interpretable manner, enabling user to understand and trust the system outputs. Interpretability ensuring that NLP model are interpretable and understandable by domain expert, policymakers, and end user to facilitate accountability and oversight. Privacy and data protection, data privacy, protecting the privacy of individuals' personal data use in NLP system by implementing privacy preserving technique, data anonymization and informed consent mechanism. Data security safeguarding NLP dataset and model against unauthorized access, misuses and security breaches to prevent data leak and privacy violations. Regulatory compliance ensuring compliance with data protection regulations such as GDPR, CCPA, and HIPAA when collecting, processing, and storing personal data for NLP application. Based on these mentioned details, we can say that model transparency and explainability, interpretability, and critical aspect of ethical and responsible AI in natural language processing NLP. Model transparency refers to providing clear and comprehensive visibility into the inner working of NLP model and system. This includes input output mapping, describing how input data such as text or speech is processing by the model to generate output, such as text classification or language translation. Decision making processes explaining the logical and algorithmic use by the model to make decision or predictions, including the features considering and the weight assigning to different factors. Underlining assumption, identifying and disclosing the assumption and limitation of the model, such as the scope, applicationability, potential biases, and area of uncertainty. Explainability in NLP involved developing technique to explain the decision and prediction made by NLP model in human interpretability manner. Key aspects include interpretability outcome, ensuring that the output of NLP models such as sentiment analysis or name entity recognition are explained in a way that user can understand and trust, including explanation for confidence source or certainty levels. Feature importance, highlighting the importance of different feature or input in influencing the model decision, enabling user to understand which factors contributes most to the output. Visualization and explanation, using visualization, textual explanation or interactive tool to communicate the models, ensuring decision making process to user, making it easier for them to interpret and validate the output. Interpretability ensure that NLP model are interpretable and understandable by domain expert, policymaker, and end user. This include domain-specific interpretation, tailoring explanation, and interpretation of NLP model to specific domain or applications such as legal, healthcare, or finance to meet the need of domain expert and stakeholder. Regulatory complaints ensure that NLP model meet regulatory requirements for interpretability and accountability, particularly in sector with strict data privacy, ethics, and transparency standards. User-friendly interface, design user-friendly interface and tools that enable non-expert to interact with NLP models, understand the output and provide feedback or corrections as needed. Privacy and data protection and regulation complaints are crucial aspect of ethical and responsible AI in natural language processing, especially when dealing with sensitive personal data. Here's an explanation of concept data privacy in NLP involve protection the privacy of individuals person data uses in NLP system. Key aspect including privacy preserving technique, implementing techniques such as differential privacy, federated learning, and secure multi-party consumptions to ensure that sensitivity information is not exposed or compromised during data processing or model training. Data anonymization, personal data by removing identification information such as name, address, and contact details to protect individuals' privacy. Informed consent mechanism, obtaining information consent from individuals before collecting, using, or sharing their personal data for NLP application. Ensuring transparency and respect for their privacy preference. Data security in NLP focusing on safeguard NLP dataset and model against authorized access, misuse, and security breaches. This include access control, implementing strict access control measuring to limit access to NLP data and model. Only the authorized personnel or system preventing unauthorized from accessing sensitive information. Encryption data both in transition and rest using strong encryption algorithms to protect data from being intercepted as accessing authorized parties. Security audits, conducting regulating security audits, assessment and potential testing to identify mitigation potential security risk and in the NLP system. Regulatory complaints involve ensuring that NLP application completely with data protection regulation and standards such as GDPR, CCPA, and HIPAA. Key consideration include data collection and pre-processing personal data for NLP application and accordance with the legal requirements, including obtaining consent, providing data subject rights, and adhering to data minimizing and purpose of limitation principle. Data storage and retention. Storing personal data surely ensure data integrating and implementing appropriate data retention policy to improve completely with regulatory requirements and protect individuals' privacy rights. Data transfer ensuring secure and compliant transfer of potential personal data across borders, adhering to international data transfer mechanism and agreement to prevent data breaches and privacy violation. By addressing data privacy, data security, and regulatory complaints in NLP, development and deployment organizations can build trust, mitigate risk, and protect individuals' privacy rights in the use of NLP technologies. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about ethical use case and applications. It's mentioned over here as social impact assessment. Conducting ethical impact assessment to evaluate the potential social, cultural, and ethical implications of NLP application on individuals and communities. Bias free languages. Promoting the use of inclusive and non discriminatory language in NLP system and application to avoid reinforcement stereotypes or perpetual harmful biases. Human rights protection, upholding fundamental human rights principles such as freedom of expression, privacy, and non discrimination in the design and deployment of NLP technologies. Responsible deployment and governance, ethical guidelines, developing and adhering to ethical guidelines, code of conduct, and best practices for the responsible development, deployment, and use of NLP system. Ethics Review Board, establishing ethics review boards or communities to oversee the ethical implementation of NLP projects and providing guidance on ethical decision making. Stakeholder engagement, engaging with diverse stakeholders including affected communities, civil society organizations, and policymakers to solicit input and feedback on the ethical dimension of NLP project. Based on these mentioned details, we can say that social impact assessment, bias-free languages, and human rights protection are critical consideration in ensuring ethical and responsible AI in natural language processing. Social impact assessment involve conducting ethical impact assessment to evaluate the potential social, cultural, and ethical implementation of NLP application on individuals and communities. Key aspect of including stakeholder engagement with diverse stakeholders including communities, advocacy group, experts, and affected individuals to understand their perspectives, concern, and expectations regarding NLP technologies. Impact analysis assessing the potential positive and negative impact of NLP application on various aspects of society such as employment, education, healthcare, governance, and human rights. Mitigation strategy, developing strategies and interventions to mitigate potential harms, address ethical challenges, and promoting positive social outcomes in the design, development, and deployment of NLP technologies. Bias-free languages refers to promoting the use of inclusive and non-discriminatory language in NLP system and application to avoid reinforcing stereotypes or perpetual harmful biases. Key consideration including debiasing technique, implementing debiasing technique in NLP algorithm and dataset to mitigate biases related to gender, race, ethnicity, religion, and the other protected characteristics. Sensitivity language handling sensitivity topics and language with care and sensitivity, ensuring that NLP system do not generate or propagate offensive, discriminatory, or harmful content. In exclusive representation of promoting diverse and inclusive representing in training data, model, and output to reflect the diversity of human experience and perspectives without marginalizing or stereotyping any groups. Human rights protection involve upholding fundamental human rights principles such as freedom of expression, privacy, and non discrimination in the design and deployment of NLP technologies. Key considerations include privacy by design, incorporating privacy enhanced technologies in principle such as data minimization, encryption, and user content mechanism into NLP system to protect individual privacy rights. Freedom of expression represent the safeguard individuals' right to freedom of expression and access to information while also addressing harmful content, misinformation, and disinformation in NLP application. Non-discrimination, ensuring that NLP system do not discriminate against individuals or groups based on protected characteristics and taking protective measure to prevent discriminatory outcome and biases in decision making process. By integrating social media assessment, bias free language practice, and human rights protecting into NLP development and deployment. Organization can promote ethical AI, foster inclusivity, and mitigation potential risk and harms associated with NLP technologies. NLP development and governance, ethical guidelines, ethics review board, and stakeholder engagement are essential components of promoting ethical and responsible AI in natural language processing. Here is an example of each concept. Ethical guidelines. Ethical guidelines involve developing and adhering to principle, codes of conduct, and best practices for the responsible development, deployment, and use of NLP system. Key aspects including ethical principle, establishing fundamental ethics principles such as fairness, transparency, accountability, privacy, and non-discrimination to guide decision making and behavior in NLP project. Best practices is promoting best practices for data collection, annotation, pre-processing, model training, evaluation, and deployment to ensure ethical considerations are integrated throughout the NLP lifecycle. Complaints, ensuring compliance with relevant ethical frameworks, legal requirements, industry standards, and organizational policies to uphold ethical standards in NLP activities. Ethics review ethics review board or committees are established to oversee the ethical implementation of NLP project and provide guidance on ethical decision making. Key function including ethics assessment, conducting ethical assessment of NLP project to identify potential risk, harms, biases, and ethical dilemmas, and recommendation, mitigation strategies, and adjustment as needed. Ethical oversees monitoring the implementation of ethical guidelines and policies, evaluate the ethical impact of NLP system on individuals and society, and ensuring compliance with ethical standard. Ethical consultation, providing ethical guidance, training, and support to NLP practitioners, researchers, and stakeholders to navigate complex ethical issues and promotes responsible AI practice. Stakeholder engage involve activity engaging with diverse stakeholders including affected communities, civil society, organization, and policymaker to solicit input and feedback on the ethical dimension of NLP project. Key aspect including community consulting with affected communities, marginalized group and end user to understand their perspectives, concern, value and preference regarding NLP technologies. Public dialogue, facilitating open and transparent discussion workspace forms on ethical AI topic, inviting diverse viewpoint, forecasting, collaboration, and building trust with stakeholders. Policy advocacy, engaging with policymakers, regulators, and advocacy groups to advocate the ethics standard, regulator frameworks, and guidelines that promote responsible AI and protect individuals' right in NLP application. By incorporating ethical guidelines, establish ethics review, brand and engaging with stakeholder organization can promote a culture of ethical responsibility, enhance trust and transparency, and address ethical challenges to in development and deployment of NLP technologies. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about continuous monitoring and evaluation. It's mentioned over here as ethics audits, conducting regular ethics audits and evaluation of NLP system to assess their compliance with ethical principle, identify potential risk and biases, and address ethical concern proactively. Feedback mechanism, implementing mechanism for user and stakeholder to report ethical concern, biases or unintended consequence of NLP system and taking core corrective action accordingly. Ethical and responsible AI in NLP is an ongoing and interdisciplinary efforts that requires collaboration between researcher, practitioner, policymaker, and society at large to ensure that NLP technologies benefit humanity while respecting ethical values, human rights, and societal well-beings. Based on this mentioned details, we can say that the provided text outline key components of continuous monitoring and evaluation of our NLP system. Continuous monitoring and evaluation ethics audit involve systematically reviewing and evaluating the ethical aspect of NLP system. Purpose the goal is to ensure that those systems comply with established ethical principle. Focus area compliance check the whether system adheres to ethical guidelines and standard. Risk identification identifying potential risk including biases and other ethical concerns. Proactive measure addressing and identifying ethical issues proactively to mitigate potential harm. Feedback mechanisms are processes or tools that allow user and stakeholder to report their concern regarding the NLP system. Purpose the mechanism help gather information about any ethical issues, biases, or unintended consequences that user encounter. The information collection through feedback is used to take co-reactive action to improve the system and address any reported problems. Continuous monitoring this ensure ongoing oversight of the NLP system ethical performance, ethics audit regular assessment, help maintains ethical integrity and address potential issue early. Feedback mechanism thus provide a way for user to contribute to the ethical improvement of system, ensuring it remains trustworthy and fair. The provided text emphasizes the importance of collaboration in ensuring ethical and responsible AI in natural language processing. Here is an explanation of this ethical and responsible AI in NLP. Ensuring that AI and NLP technologies are ethical and responsible is not a one time task but a continuous process that requires persistent attention and improvement. Interdisciplinary approaches achieving ethical and responsible AI in NLP involves the integration of various fields of expertise, including researchers, scientists, and academics who develop the fundamental theories and technologies, practitioners, engineering, and developers who implement and deploy those technologies. Policymakers, government officials, and regulators who create the enforce law and guidelines, society at large, general public, and civil society organizations who are affected by and can provide feedback on those technologies. Goals of immunity ensure that NLP technologies contribute positively to human life and societal progress. Respect ethical values adhering to moral principles such as fairness, transparency, and accountability. Human rights protecting the rights and freedom of individuals such as privacy and freedom from discrimination. Societal well-being promoting the overall health and prosperity of society, avoiding harm and addressing societal challenges. Collaboration, effective, ethical, and responsible AI in NLP requires the concerted efforts of multiple stakeholders from different domains. Continuous improvement, the process is dynamic and must involve with advancement in technologies and changes in societal values. Holistic approaches addressing the ethical challenges in NLP involve considering a wide range of perspectives and impacts, ensuring comprehensive and inclusive solution. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about NLP applications and future trends. NLP applications in industry. It's mentioned over here as natural language processing has numerous applications across industry ranging from customer service and support chatbot to sentiment analysis and beyond. Here are some key NLP applications in various industries. Based on these mentioned details, we can say that chatbot and virtual assistant automated systems that handle customer inquiries, provide information, and perform tasks such as booking appointment or troubleshooting issues. Sentiment analysis analyzing customer feedback, review to gauge satisfaction and identifying areas for improvement. Medical transcription converting spoken medical notes into text, aiding in maintaining accurate patient's record. Clinical decision support analyzing patient's data and medical literature to assist healthcare professional in making informed decisions. Fraud detection analyzing transaction patterns and communication to identify fraudulent activities, customer insight, leveraging sentiment analysis and other NLP technique to understand customer behavior and preference. Retail and e-commerce personalized recommendation using NLP to analyze customer review and preference to provide personalized product recommendation. Customer feedback analysis extracting insight from customer review and feedback to improve products and service. Content moderation, automatically detection and filtering incorporate or harms content in user generated content. Content creation assisting in generating articles, summarize and other types of content using NLP technique. Resume screening, automation and screening of resume and matching candidate to job description, employee sentiment analysis monitoring, employees feedback and sentiment to improve workplace culture and address concern. Contract analysis analyzing legal documents to identify key clause, obligations, and potential risk. Legal research using NLP to search and summarize relevant legal precedent and documents. Automated grading using NLP to grade essays and providing feedback to students. Language learning developing tools and applications that assist in language learning through interactive dialogue and assessment. Market research analyzing social media and other online content to gain insight into market trends and consumer preference. Campaigning analysis evaluating the effectiveness of marketing campaigning through sentiment analysis and other NLP techniques. Keywords of NLP versatility application across various industry improving efficiency, enhancing customer experience and providing valuable insight. Improving decision making by analyzing large volume of text data, NLP help organization making data driven decision. Enhancing automation NLP enable and automated of many tasks that traditionally require human intervention, leading to increased productivity and reduced cost. The integration of NLP in a different industry continues to grow, driving by achievements in technologies and increasing demand for automation and data-driven insight. The application highlighted above demonstrate the broad potential and impact of NLP across various sectors. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about customer service and support chatbot. It's mentioned over here as automated response NLP powered chatbot can understand customer queries and provide automated responses, helping businesses handle customer inquiries, troubleshoot issues, and provide support 24 into 7. Natural language understanding chatbot equipped with NLP capabilities can understand the talent and context of customer message, enabling more accurate and personalized interaction. Efficiency and scalability NLP powered chatbot can handle a large volume of customer inquiries, simultaneously improving efficiency and scalability for business. Sentiment analysis, social media monitoring NLP techniques are used to analyze and classify social media posts, customer review, and feedback to gauge sentiment towards products, brand, or services. Brand reputation management, sentiment analysis help businesses monitor and manage their brand reputation by identifying positive and negative sentiments expressed by customer and addressing issue promptly. Market research in NLP based sentiment analysis provide insight into customer preference, trends, and options, helping businesses make data driven decisions and improve their product or services. Based on these mentioned details, we can say that the provided text outlines and advantages of functionality of NLP powered chatbot in customer service with a huge explanation. Automated responses are pre-programmed replies generated by chatbot in response to customer queries. Functionality understanding queries NLP powered chatbot analyze and comprehend customer questions. Providing support, they offer instant replies to inquiries, troubleshooting common issues, and guide customer through various processes. Those chatbot operates around the clock, ensuring customer receiving support at any time, improving customer satisfaction and loyalty. Natural language understanding NLU is a subset of NLP focusing on enabling machine to understand and interpret human languages. Functionality in recognition chatbot with NLU can identify the purpose of behind customer messages such as whether they are asked for information, seeking help, or making compliment. Context awareness they can maintain context across the conversational making interaction more coherent and relevant. Personalized interaction by understanding intent and context chatbot can provide responses tailored to individual customer need, enhancing the user experience. Efficiency and scalability NLP powered chatbot can manage multiple customer interaction at the same time, reducing wait times and speeding up responses time, task automation, repetitive tasks, freeing up human agents to focus on more complex issues. High values business can scale their customer support operating with a proportional increase in cost. Chatbot can handle growing number of inquiries as the business expands. Consistent service quality, the provider consistent responses and services quality regardless of the number of interactions. Key takeaways: enhancing customer support NLP provide chatbot improve customer service by providing quick, accurate, and personalized response. 24 into 7 availability, they offer round the clock support, ensuring customers always have access to help. Operational efficiency, businesses benefit from increasing efficiency and scalability, handling more inaccurate without additional cost or resources. Sentiment analysis, the provider text discusses how natural language processing techniques are utilized in social media monitoring, brand reputation management, and market research. Social media monitoring involves tracking and analyzing user generated content on social media platform. The functionality of NLP technique can process vast amount of social media data to extract meaningful information, classify content. Those techniques categorize post, review, and feedback based on topic and sentiment expressed. NLP can determine the overall sentiment positive, negative, or neutral towards product, brand, or services provided real-time insight into public perception. Brand-based reputation management, brand reputation involve monitoring and responses to how a brand is perceived by a public. Functionality: sentiment analysis by analyzing sentiment expressed in a social media post, review, and feedback. Business can understand how customers feel about their brand. Identifying sentiments NLP help to identify and categorizing sentiments as positive, negative, or neutral. Addressing issues early: identification or negative sentiments allow businesses to address customer concern promptly. Mitigation potential damage to their reputation. Highlighting positive sentiment can be leveraged in marketing and customer engagement strategy to enhance brand images. Market research involves gathering and analyzing data to understand market dynamics, customer behavior, and trends. Consumer insight and based sentiment analysis provide deep insight into consumer performance and opinions. Trade analysis: by analyzing the sentiment trades over time, business can identify emerging trend and shifted in consumer behavior. Data-driven decision: the insight gained from sentiment analysis help businesses make informed decision about product development, marketing strategy, and customer service improvement. Competitive analysis: monitoring sentiment towards competitors provides valuable information on market positioning and areas for differentiation. Key real-time insight: NLP enabling businesses to track analyzing customer sentiment in real life, allow for immediate action and responses. Proactive management: business can proactively manage their brand reputation by addressing negative sentiment and amplifying positive ones. Strategic decision making insight from sentiment analysis support data driven decision, enhancing product offering and customer satisfaction. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about content categorization and recommendation. It's mentioned over here as content classification. NLP algorithm classify and categorize textual content such as news article, blog post, or product description based on topics, theme, or relevance. Personalized recommendation: NLP powered recommendations such as system analyze user performance, behaviors, and historical interaction to deliver personalized content recommendations such as product recommendation on e-commerce platform or content recommendation on streaming service. Text summarization and information extraction. Document summarization NLP technique are used to generate coincide summarize of long document article or report enabling user to quickly extract key information and insights. Information extraction NLP system extracts structured information from unstructured data such as name entities, events, or relationship to support tasks such as determining knowledge graph construction and information retrieval. Based on these mentioned details, we can say that the provided text outlines how natural language processing is used for content classification and personalized recommendation. Here's in a details explanation of content classification involves organizing and categorizing textual content into predefined categories based on its subject matter. Those algorithms process the and analyzing textual data, identifying key topics, them and relevant information. Classification textual content such as news article, blog post, or product description is classified into categories based on its content. Application of news website classifying article by topic like politics, sports, technologies, etc. E-commerce categorizing products description to enhance searchability and user experience. Content management organizing large volume of text for easier retrieval and analysis. Personalized recommendation system provide user with suggestion tailored to their preference and behavior. Functionality NLP provide system analyze user data including past interactions such history and behavior patterns. Recommendation generation based on the analysis, the system generates personalized recommendation, e-commerce platform recommendation, products that match user preference and provides purchases. Streaming service suggestion movie, TV show or music based on user viewing or listening history. Content platform delivering personalized article, blog post or other content that align with user interest. Improving the user experience, both content classification and personalized recommendation enhance the user experience by providing relevant and tailored information. Efficiency and accuracy NLP algorithm improve the efficiency and accuracy of categorizing content and predictions user preference. Enhance engagement, personalized recommendation increase user engagement by offering content that matches individual taste and interest. NLP plays a crucial role in both content classification and personalized recommendation. By leveraging advanced NLP algorithms, businesses can efficiently organize textual content and deliver personalized experience that cater to individual user preference, thereby improving customer satisfaction and engagement. Text summarization and information extraction. The provided text discussion how natural language processing technique are used for document summarization and information extraction. Here is a details explanation. Document summarization involves creating concise summarize of longer document, article, or report. NLP technique, advanced NLP algorithm analyze the content of long document to identify the most important information. Generating summarize those technique generate summarize the capture the enhance of original document while being significantly shorter. Application news article summarizing news article to provide readers with quick overviews of the main points. Research paper creating abstract or summarize the academic paper to help researcher quickly grasp the key findings. Business report summarizing lengthy reports to allow executive and stakeholder to extract key insight without reading an entire documents. Information extraction involves identifying and extracting structured information and unstructured text data. Those systems use various NLP techniques to process and analyze text, identifying and extracting relevant information. Name entities, identifying entities such as people, organization, location, date, and other proper nouns. Events recognition, event mentioned in the text such as meeting, transaction, or incidents. Relationship extraction, relationship between entities such as who works for whom or what product are associated with which companies. Application of data mining, extracting valuable information from large data set, discovering pattern and trend. Knowledge graph construction, building structured knowledge graph that represent information in the graph format, liking entities and relationship. Information retrieval, improving search engine and databases by extracting the index relevant information from text document. The key takeaway of efficiency and accessibility, document summarization help user quickly access the understand key information without reading lengthy text. Structured data from unstructured text, information extracting transform unstructured text into structured data, making it easier to analyze and use in various applications, enhancing information process. Both summarization, information extraction streamline the process of handling large volume of text, providing user with relevant insight and data. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about voice assistant and virtual agent. It's mentioned over here as conversational interface NLP powered voice assistant and virtual agent understand and responses to spoken queries and comments, providing user with hands-free access to information service and tasks. Task automation, voice enabling NLP system automated routine tasks such as setting reminders, schedule appointment, or controlling smart homes devices, enhancing user productivity and convenience. Compliance and regulatory monitoring, text analysis and classification, NLP system analyze and classify regulator document, contract, and legal text to identify compliance risk, monitoring regulator change and ensure adherence to legal requirements. Anomaly detection NLP technique anomaly derive irregularities in textual data such as fraudulent transaction, suspicious activities or complaints violation, helping businesses mitigation risk and maintaining regulatory complaints. Based on these mentioned details, we can say that conversational interface including voice assistant and virtual agent that interact with through natural languages. NLP powered system can comprehend spoken language, interpret user queries and commands. Those systems provide appropriate responses, action based on interpreted input. Devices like Amazon Alexa, Google Assistant, and Apple Siri use NLP to understand the responses of user. Virtual agent online chatbot assisting user in navigating website, answering question, and providing customer support. Benefits of this product, user can access information service and perform tasks without need to use their hands, enhancing conversing and accessibility. Neutral interaction conversational interface enabling user to interact with technology in a more intuitive and human-like manner. Task automation refers to the use of technology to perform routine tasks without human intervention. NLP voice allow assistant to automate various routine tasks through spoken commands. Benefits of enhancing productivity, automation routine tasks saves time and efforts, allow user to focus on more important activities. Increasing convenience, enable automation, simplify everyday tasks, making it easier for user to manage their day-to-day activities. Accessibility, those systems provide significant benefits to individuals with disability or those who require hands-free solution. Text analysis and classification. Text analysis involves semantic examination, categorization of text content to extract meaningful information and insights. Anomaly detection is involved identifying patterns, derivatives, or irregularities in the data that may indicate potential issues or risk. Functionality: NLP technique analyze text data to find anomalies such as unexpected terms, phrases, or patterns that vary from the norms. Identifying fraudulent transaction by analyzing transaction data, NLP system can detect patterns such as fraudulent activities and financial irregularities. Spotting suspicious activities, NLP can flag unusual behavior or activities in communication log, email, or transaction record that may indicate compliance violation, security threats. Application: finance service monitoring transaction to sign or fraudulent or financial crimes. Cybersecurity analyze network log and communication data to detect signs of cyber attacks and unauthorized access. Enhance the complaints NLP system help business maintain regulatory complaints by analyzing and classifying legal text and identifying complaints risk. Proactive risk management anomaly detection technique allow for early identification of potential user, enabling businesses to take proactive measure to mitigate the risk. This can be said after reading out this part. Now we will go to next particular discussion. We will be discussing about healthcare and medical NLP. It's mentioned over here as clinical documentation. NLP system extract and analyze information from medical records, clinical notes, and patient narratives to support clinical decision making, diseases, surveillance, and healthcare research. Healthcare monitoring. NLP powered system analyze patients generated data such as electronic health records, wearable sensor data, and social media posts to monitor health trends, identify diseases, outbreaks, and provide personalized healthcare interventions. Those are just a few examples of how NLP is applied across industry to automated tasks, improve customer experience, gain insight from data, and enhance decision-making process. NLP continues to drive innovation and transformation in various sectors, unlocking a new opportunities for businesses and improving people's lives. Based on this mentioned detail, we can say that the natural language processing is utilized in clinical documentation and healthcare monitoring. Clinical documentation involves recording and managing patient-related information, including medical records, clinical notes, and patient narratives. NLP system can extract clinical information from unstructured text found in medical records and clinical notes. Data analysis: those systems analyze the extract data to identify patterns, trends, and relevant insight that can support clinical decision making. By providing healthcare professionals with structured information and actionable insight, NLP help in making informed decisions regarding patients' care. Diseases surveillance: analyzing clinical documentation allow for the early detection and tracking of those outbreaks and trends. Healthcare research can leverage NLP to analyze large volume of clinical data, identifying correlation and insight that contribute to medical research and advancement. Benefits of efficiency: automation that extract and analysis of clinical documentation, save time, reduce the burden of manual data entry for healthcare providers. Accuracy: NLP system can provide the accuracy of extracted information, ensuring that critical details are not overlooked. Healthcare monitoring involves the continuous observation and analysis of health related data to assessing and improve individuals and public health. Functionality of analyzing patients generated data. NLP system analyze various sources of patients generated data including electronic health records, age, wearable sensor data and even social media posts. Identifying healthcare trends by processing and analyzing this data, NLP can identify health trends such as increasing in certain symptoms or disease outbreaks, providing personalized interventions based on the analyzed data. Healthcare providers can offer personalized healthcare interventions tailored to the specific needs and condition of patients. Application of the monitoring data from various sources allow for early detection of diseases, outbreaks, enabling timely public health responses. Chronic diseases management analyzing data from wearable sensor and EHRs help in managing chronic diseases by tracking patients' health metrics and providing necessary interventions. Patients engaging NLP can analyze patients' feedback from social media or health forums, offering insight into patients' experience and concern. Proactive healthcare continuous monitoring and analyzing of health data, enabling proactive healthcare intervention, improving patients' outcomes. Personalized NLP allow for the delivery of personalized healthcare, ensuring that the intervention are tailored to individual patients' needs. Public health improves by identifying and responding to health trends. NLP contribute to the overall improvement of public health. Key takeaways of enhanced clinical decision making NLP support healthcare providers by extracting and analyzing relevant information from clinical documentation, aiding in accurate and informed decision making. Efficient health monitoring, continuous analyzing of patient generated data, help in monitoring health trends and providing personalized healthcare interventions. Improve healthcare outcomes, both clinical documentation and health monitoring using NLP contribute to better patients' care and public health management by leveraging data driven insight. NLP plays a crucial role in both clinical documentation and health monitoring by automating the extraction and analysis of medical records and patients' data. NLP system enhance clinical decision-making, diseases surveillance, and healthcare researches. Additionally, continuous health monitoring using NLP enable proactive and personalized healthcare interventions, contribution to improve patients' outcome and public health. This statement highlights the broad applicability and impact of natural language processing NLP across industry. Let's break it down. Automation task NLP used to automate various tasks that involve processing and understanding of human language. For example, chatbot and virtual assistant use NLP technique to understand user queries, provided relevant responses, automation, customer support, and information retrieval process. Improving customer experience, NLP plays a crucial role in enhancing customer experience by analyzing customer feedback, sentiment, and preference from text data, like review, social media post, or survey. Businesses can gain insight into customer needs and sentiments, enabling them to tailor product and services more effectively. Gaining insights from data, NLP help extract valuable insight from unstructured text data. For instance, in healthcare, NLP can analyze medical records to identify trends, patterns, and correlation, aiding in medical research, diagnosis, and treatment planning. Enhancing decision-making process by leveraging NLP technique for information extraction, summarization, and sentiment analysis. Organization can make data-driven decision more efficiently. For instance, finance institution use NLP to analyze news article, market reports, and social media data to make informed investment decision. Driving innovation and transformation, NLP fuels innovation by enabling the development of advancement applications such as language translation, content generation, and personalized recommendation system. It transforms industry by streamlining workflows, improving communication, and unlocking new opportunities for businesses to innovate and grow. Overall, NLP continues to evolve and revolutionize various sectors, offering solutions that improve efficiency, accuracy, and user experience while paving the way for new advancement and opportunities in technologies and businesses. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about future trends in NLP. It's mentioned over here as the field of natural language processing is evolving rapidly driven by advance in machine learning, deep learning, and computational linguistic. Here are some future trends in NLP that are expected to shape the field. Contextual understanding of bidirectional models, future NLP models are likely to further improve contextual understanding by incorporating bidirectional context, capturing dependencies from both left and right context simultaneously. Dynamic context model may be dynamically adjust their understanding of context based on the surrounding context and discourse, enabling more accurate and nuanced language understanding. Based on these mentioned details, we can say that those future trends in natural language processing highlight the ongoing involving and innovation in the field. Advance in machine learning, continued advancement in machine learning algorithm, particularly in areas like reinforcement learning and unsupervised learning, will enable NLP model to learn and adapt more effectively from large scale dataset without extensive human supervision. This will lead to more robust and context aware NLP system. Deep learning architectures such as transformer-based model like BERT, bidirectional encoder representation from transformer, and GPT, generative pre-trained transformer, will continue to be refined and scale up. Those models have shown remarkable performance in tasks like language understanding, generation, and translation, and further improvement in model architecture and training technique will enhance their capabilities. Multimodal NLP integrated of NLP with the multi like vision and audio multimodal NLP will become more prevalent. This include tasks like image captioning, video summarization, and speech-to-text translation, where NLP techniques are combined with computer vision or speech recognition to process and understand information from multiple sources simultaneously. Explainable AI in NLP. As NLP model become more complex and powerful, there will be a growing needs for explainable AI technique. Researchers are working on methods to interpret and explain the decision made by NLP model, enhancing transparency, trust, and accountability in AI-driven application. Domain-specific NLP customized NLP solution tailored to specific domain or industries such as healthcare, finance, legal, etc. We'll see increased development. Those domain specific NLP model will be fine tuned on domain specific dataset and incorporate specialized knowledge and terminology to deliver more accurate and relevant results. Ethical and responsible AI. With the growing influence of AI in society, there will be a greater emphasis on ethical and responsible AI practices in NLP research and development. Those include addressing issues like biases, fairness, privacy, and security in NLP system to ensure they serve the common good while mitigation potential risk and harms. Overall, those future trends reflect the dynamic nature of the NLP field, driven by a combination of technologies, advancement, interdisciplinary collaboration, and societal considerations, paving the way for exciting innovation and application in the year to come. Contextual understanding bidirectional model for contextual understanding current NLP model like word bidirectional encoder representation from transformer have revolutionized contextual understanding by considering both left and right context simultaneously. This means they can analyze a word or phrase in a sentence by taking into account not just the preceding words left context but also the following words right context. The bidirectional approaches help capture complex dependencies and nouns in language, leading to more accurate and contextually rich representation of text. Future NLP models are expected to build upon this bidirectional framework to further enhance contextually understanding, enabling them to grasp interact linguistic relationships and suitable nouns in human language more effectively. Dynamic context adaptation, another key aspect of future NLP model in is the ability to dynamically adjust their understanding of context based on the surrounding discourse and context. This dynamic context adaptation involves continuously updating and refining the model's understanding of the text as it processes more information. For example, in a conversational or a document with changing topics, a dynamic context aware model can adapt in interpretation of word and phrases based on the involving context. These capabilities lead to more nouns and accurate language understanding, especially in scenario where the context is dynamic and complex. In a sense of future NLP model are expected to leverage bidirectional context and dynamic context adaptation to improve their ability to understand and process natural language in more sophisticated and contextually aware manner. This advancement will contribute to more robust and accurate NLP application across wide range of tasks, from language understanding and generation to translate the sentiment analysis. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about multimodal NLP. It's mentioned over here as integration of modalities. NLP system will increasingly integrate multiple modalities such as text, image, audio, and video to enable more comprehensive and contextually rich language understanding. Cross-modal representation learning, future NLP model may learn shared representations across modalities, facilitating tasks such as image captioning, video summarization, and multimodal questioning answering. Few short and zero shot learning. Transfer learning NLP model will continue to leverage transfer learning technique to generalize across task and domain, enabling few short and zero shot learning for new tasks with limited level data. Meta learning approaches may be employed to enable rapid adaptation and learning of new tasks and language for minimal examples. Based on these mentioned details, we can say that traditionally, natural language processing has primarily focused on text data. However, as the digital landscape became more diverse and proliferation of multimedia context such as image, audio, and video, there is growing need for NLP system to integrate multiple modalities. By integrating those modalities, NLP system can achieve a more comprehensive and contextually rich understanding of language. For example, analyzing text along with accompanying images or videos can provide additional context and insight that enhance the overall understanding of the context. The integration enabling NLP system to tackle a broader range of tasks and application from sentiment analysis on social media posts with image to generate text description from video context. Cross-modal representation learning future NLP model are expected to go beyond unimodal single modality process and venture into a cross-modal representation learning. Cross-modal representation learning involved learning sheer representation or embedding that captured the relationship and semantic across different modalities such as text, image, audio, and video. Those shared representation enable NLP model to understand and generate context across modalities seamlessly. For instance, a model trained with cross-modal representation learning could generate accurate and descriptive captioning for image or video, summarize video content into text, or even answer questions that involve multiple modalities. Example, answering a question about a scene in a video with both visual and contextual information. By integrating modality and leveraging cross-modal representation, learning feature NLP system can unlock a new capabilities and address complex tasks that require a holistic understanding of language in various forms, including text, image, audio, and video. Those integration pace the way for achievements in areas like multimedia context analysis, multimodal communication, and interactive AI system that can interpret and generate content across diverse modalities. Few short and zero short learning. Transfer learning is a technique where knowledge gained from a training on a task or domain is leveraged to improve performance on another related task or domain. In the context of natural language processing, NLP transfer learning has become a crucial approach for generalized across tasks and domains. NLP models such as BERT, bidirectional encoder representation from transformer, and GPT, generative pre-trained transformer, are often pre-trained on large-scale dataset with diverse text data. This pre-train allow the model to learn general linguistic patterns, semantic and syntactic structure from the data. After pre-train, those models can be fine-tuned on specific task or domain with the limited level data, enabling few shot and zero shot learning. Few shot learning refers to learning from a small amount of level. Example, with zero shot learning refers to generalize to new task or domain without any task specific training data. Transfer learning in NLP facilitates the rapid adaptation of model to new tasks and domains, improve their performance and efficiency. Meta learning in NLP, also known as learning to learn, is an approach with a model learn how to learn from a limited amount of data or example. In the context of NLP, meta-learning technique can be employed to enable rapid adaptation and learn of new tasks and language. From minimal example, meta-learning algorithm aim to learn high-level representation or strategies that enable efficient learning and adaptation to new tasks with limited data. For example, in a few short learning scenario, a meta-learning algorithm may learn a quickly generalize from a few level example to perform well on new tasks without extensive retaining. Meta learning in NLP can improve our scalability, flexibility, adaptability of model, allow them to tackle and language with limited level data. Both transfer learning and meta learning are powerful techniques in NLP that enable model to generalize, adapt, and learn efficiently from limited data or example. Those approaches contribute to the development of more robust, versatile, and data efficient NLP system that can tackle a wide range of tasks and domain effectively. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about ethical and responsible AI, fairness and bias mitigation, there will be increase on developing NLP system and their fair, unbiased and inclusive with technique to detect mitigation biases in language data algorithms. Transparency and explainability efforts will be made to enhance the transparency and explainability of NLP model, enabling user to understand decision-making process and potential biases inherent in the system. Cross-linguistic multilingual NLP. Language agnostic model, future NLP model will aim to be language agnostic, capable of understanding and processing text in multiple languages without the need for language specific adaptation. Zero shot translation model will advance towards zero shot translation, allow for seamless translation between language pairs not seen during training. Based on these mentioned details, we can say that in ethical and responsible AI, we can say in the context of natural language processing, fairness refers to ensure that NLP model and system treat all individuals or groups fairly and without discrimination regardless of their demographic attributes such as race, gender, or ethnicity. There is an increasing of awareness of the potential biases can exist in language data and algorithms, leading to bias or unfair outcomes in NLP application. To address this, there is a growing focus on developing NLP model and systems that are fair, unbiased, and inclusive. Techniques such as bias detection and mitigation are employed to identify and rectify biases in language data and algorithm. For example, researcher may analyze training data for bias, language pattern, or developing algorithms that mitigate biases during the model training process. Fairness in NLP is essential for building trustworthy and equitable AI systems that uphold ethical understand and prompt inclusivity. Bias mitigation technique aim to reduce or eliminate bias in NLP model and syntax. The involves variation strategies such as debiasing algorithm, data augmentation, and diverse dataset collection. Debiasing algorithms modify the model's learning process to reduce the impact of biased data or correct bias prediction. Data augmentation technique introduce diverse into the training data to mitigate biases and improve the model's generalization ability. Additionally, collection diverse and representative dataset help reduce biases by ensure that the model learn from a wide range of examples. Bias mitigation in NLP is crucial for preventing discriminatory outcome and ensure fair and equitable treatment for all users. Transparency and explainability in NLP in refers to make the decision making process of NLP model and system understandable and accessible to user. Transparent NLP model provide insight into how they arrives and decision, which help user understand the underlying mechanism and potential biases inherent in the system. Effort to enhance transparency in NLP includes providing explanation for model prediction, documentation, model architecture, and training processes, and disclosing potential limitation or biases. Transparent NLP model promote accountability, trust, and responsible AI development, enabling user access the reliability and fairness of the system. Explainability in NLP involve providing explanation or justification for the outcome or prediction generated by NLP model. Explainable NLP model help user understand why a particular decision was made, which is especially important for critical applications such as healthcare, finance, and legal domains. Techniques such as attention mechanism, Salicipens maps, and model agnostic explanation are used to providing interpretable insights into the model's decision making process. Explainable NLP model empower user to evaluate and interpret model outputs, identify potential biases or errors, and make informed decision bias on the generated insight. Overall, the fairness and bias mitigation effort in NLP focus on developing an fair and unbiased model, while transparency and explainability initiative aim to make NLP system more understandable and accountable to user, fostering trust, fairness, and ethical AI practices. Cross-lingual and multilingual NLP language agnostic NLP model are designed to understand the process of text in multiple languages without requiring language specific adaptation or separate model for each language. Those models aim to achieve a level of universality where they can effectively handle diverse language with minimal additional training or adjustment. Language agnostic model typically leverage techniques such as multilingual embeddings, share representation, and across lingual transfer learning by learning general linguistic patterns and structure across language. Those models can generalize their knowledge and capabilities to various linguistic contexts. Language agnostic model enable applications such as multilingual sentiment analysis, language identification, and cross-lingual information retrieval, providing flexibility and efficiency in handling multilingual data and tasks. Zero source translation refers to the ability of translation models to perform seamless translation between language pairs that were not seen during training. Traditional translation models are trained on specific language, example English, French, English, Spanish, and require explicit training data for each language pair. However, zero-shot translation models generalize across language and can translate between language pairs that were not explicitly included in their training data. Those models achieve zero-shot translation through techniques such as multilingual training, shares, representation, and cross-lingual transfer learning. Zero-shot translation is particularly beneficial for handling translation tasks involving rare language, dialect, or language pair with limited training data. It enables more versatility and adaptability translation system that can cater to diverse linguistic needs and scenario without the need for extensive training data or model training for every language pair. Both language agnostic model and zero shot translation represent achievements in NLP that contribute to the development of more versatility, scalable, and inclusive language processing system. Those innovation facilities symbolize language understanding and translation across diverse language promotion, global communication, accessibility, and linguistic diversity in the digital age. This can be said after reading out this part. Now we will go to next particular discussion. This particular part we will be discussing about domain specific NLP. It's mentioned over here as specialized model NLP models tailored to specific domains such as healthcare, finance, legal, and scientific literature will continue to emerge, addressing domain specific challenges and requirements. Customization and adaptation tools and framework for customizing and adapting NLP model to specific domain and application will become more accessibility and user friendly. Interactive and contextual generation, interactive dialogue system, NLP system will evolve towards more interactive and context aware dialogue system capable of engaging in multi-turn conversation, understanding user intent, and generating appropriate responses. Dynamic text generation, future text generation model may generate content dynamically based on user interaction, preference, and contextual cues, enabling personalized and adaptive content creation. Based on these mentioned details, we can say that Specialized model in NLP are tailored to address specific domain challenge and requirements in areas such as healthcare, finance, legal, and scientific literature. Those models are designed to understand and process text data that is unique to particular domain, incorporating domain-specific knowledge, terminology, and context. Specialized NLP models are trained on domain-specific dataset and fine-tuned to optimize performance for tasks relevant to the domain. For example, in healthcare, specialized NLP model can analyze electronic health records, medical literature, and clinical note to extract patient's information, identifying medical condition, and address in diagnosis the treatment planning in the legal domain. Those models can handle tasks such as legal domain analysis, contract review, and legal case summarization. Specialized NLP model offer tailored solutions that address the interactions and nouns of domain specific language, improving accuracy, efficiency, and relevance in domain specific application. Customization and adaptation of NLP model tool and the framework for customizing and adapting NLP model to specific domain and application are become more accessible and user friendly. Those tools allow developer and domain expert to fine tune and pre-existing NLP model or train new model from a scratch using domain specific dataset. Customization and adaptation of NLP model involve tasks such as domain-specific vocabulary integration, training data augmentation, feature engineering, and model parameter tuning. Additionally, transfer learning technique enable the transfer of knowledge from pre-trained model to domain-specific tasks, reduce the need for extensive training data and computational resource. Customizable NLP framework and platform provide flexibility and scalability for building domain-specific NLP application, empowering organizations to address unique business challenges and requirements effectively. Overall, the specialization model and customization tool in NLP cater to diverse need of different domain and industry, offering solutions that are tailored, accurate, and efficient in handling domain-specific language and tasks. Those advancements drive innovation and application diverse in NLP, enabling organization to leverage NLP technique to its full potential across various domain and application. Interactive and contextual generation system represent a shift towards more engaging and context-aware NLP system that can engage in multi-turn conversational, understand user intent, and generate appropriate responses. Those systems are designed to mimic human-like interaction where the system and the user exchange message and queries in a conversational manner. Key characteristics of interactive dialogue system include multi-turn conversational interactive dialogue system can handle conversational that span multiple turns where the system maintain context and continuity across exchange. This allow for more natural and engaging interaction compared to single turn interactions. Understanding intended, those systems employ natural language understanding technique to interpret user queries, intents, and preference. By understanding and context and intent behind user input, the system can generate relevant and accurate responses. Generative appropriate responses, interactive dialogue system, user natural language generation technique to generate responses that are contextually appropriate, informative, and conversational. This includes generating text that is coherent, fluent, and tailored to the ongoing conversation. Context awareness, the system maintain context throughout the conversation, consideration, previous interaction, user preference, and contextual cues to generate personalized and relevant responses. Content awareness enhance the quality and effectiveness of the dialogue. Overall interaction dialogue system enable a more natural, intuitive and engaging interaction between user and NLP system, facilitating tasks such as customer support, virtual assistant and conversational AI application. Dynamic text generation in NLP. Dynamic text generation refers to the ability of text generation model to generate content dynamically based on user interaction, preference, and contextual cues. These enable personalized and adaptive content creation where the generated text is tailored to individual user or specific context. Key aspects of dynamic text generation include user interaction. The model incorporates user inputs, interacts, and feedback to the dynamically adjust the generated text. Those include adapting the style, tone, and content of the text based on user performance and behavior. Contextual cues. Dynamic text generation model consideration contextual cues such as the current conversation topic, user context, and environmental factors to generate contextually relevant and timely context. Personalize. Those model can personalize the generated text to suit individual user preference, interacts with demographic. This may involve incorporating personalized recommendations, suggestion, or insight into the text. Adaptation. Dynamic text generation model adapted to changing circumstances, new information, or involved user need ensure that the generated content remains up to date, accurate, and aligned with user expectation. Dynamic text generation enhances the content creation by providing tailored and adaptive text output that resonate with user, improve engaging, and meet specific communication goal. Those models find application, personalized marketing, content recommendation system, chatbot, and content generalized platform. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about continual learning and lifelong adaptation. It's mentioned over here as continual learning NLP system will be designed to learn continuously from new data and experience, avoiding catastrophic forgetting and maintaining performance over time. Lifelong adaptation model will adapt and evolve over time to reflect changes in language uses, societal norms, and cultural context, ensuring relevance and effectiveness in dynamic environments. Those feature traits in NLP reflect the ongoing advancement and innovation in the field, driven by the quest to develop more capable, robust, and ethical language technologies that can understand, generate, and interact with human language in increasingly sophisticated ways. Based on these mentioned details, we can say that continual learning NLP system will be designed to continuously learn from new data and experience. This help in avoiding catastrophic forgetting, which is of when a model forget previously learned information upon learning new information. Continual learning ensure that the performance of NLP system is maintained over time, even as they are exposed to new and diverse data. Lifelong adaptation NLP model will continuously adapt and evolving over time to reflect changes in language uses, societal norms, and culture context. Importance of this ensure that the NLP model remain relevant and effective in dynamic environment as language and culture context are constantly evolving. Models that can adapt will be better suited to understand and generate human language accurately. Those trend highlights the ongoing advancement and innovation in NLP, emphasize the development of more capable, robust, and ethical language technologies. The aim is to create NLP systems that can understand, generate, and interact with human language in an increasingly sophisticated way, making them more effective in real-world application. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about capstone project. It's mentioned over here as final project where students apply their knowledge to solve a real world NLP problem such as sentiment analysis, text classification or machine translation. Designing a final project where students apply their knowledge to solve a real world NLP problem is an excellent way to reinforce their understanding and skill. Here's a suggested outline for such a project. Project title: Real World NLP Problem Solving. Objective: the objective of the final project is to apply the concept of technique and tools learned throughout the course to solve a real world NLP problem. Student will choose one of the following NLP tasks: sentiment analysis, text classification, or machine translation, and develop a solution using appropriate methods and technologies. Based on these mentioned details, we can say that the goal is for students to apply their understanding and skill in NLP to address a real world problem. Example of such problem including sentiment analysis, text classification or machine translation. Step to design the final project, student should select a specific NLP problem to tackle. This could be based on their interest or real world relevance. Data collection: student will be need to gather, process relevant data for their chosen problem. This may be involve collecting text data from various sources, maybe SQL, maybe Excel, maybe SAP, any kind of source they can use and cleaning it for analysis. Model selection and training: student will choose appropriate NLP model and train them using the collected data. This could involve experience with different algorithms and architectures. Evaluation and analysis: after training the model, student will evaluate their performance using appropriate metrics. They will analyze the result to understand the model strength and weakness. Reporting and presentation: finally, student will document their process, finding and conclusion in detailed reports. They may also represent their work to their peers or instructor. This project-based approach is an effective way to reinforce student understanding and skill in NLP by providing hands-on experience with real-world application. Project title is Real-World NLP Problem Solving Objective. The objective of the final project is for students to practically apply the knowledge and skill they have gained throughout their NLP course to solve their real world problem. Here is a breakdown of those what the entails. The purpose of this project is application of learning. The main goal is for students to demonstrate their understanding and ability to use the concept of technique and tools they have learned. Real world problem solving: student will address up practical NLP problems, showing how theoretical knowledge can be used in real world scenario. Task selection, sentiment analysis. This involves determining the sentiment or emotion expressed in a piece of text such as positive, negative, or neutral. For example, analyzing customer review to understand their opinion about a product. Text classification: this involves categorizing text into predefined classes or level. For example, sorting news article into categories like sports, politics, or entertainment. Machine translation: this involves automatically translating text from one language to another. For example, translating a document from English to Spanish. Development process: appropriate methods and technologies. Student will choose the right methodologies and technologies for their selected task. This could involve using machine learning model, neural networks, natural language processing libraries, and other relevant tools. Outcomes of this practical solution: by the end of the project, student will have developed a functional solution to the selected NLP problem. This not only reinforces their learning but also provides them with practical experience that can be showcased in their academic or professional portfolios. In essence of the final project, allows students to synthesize and apply their learning in a meaningful way, preparing them for a real world application of NLP technologies. This can be said after reading out this part. Now we will go to next particular discussion. This part we will be discussing about project components. It's mentioned over here as problem definition, defining the specific NLP task to address example sentiment analysis of movie reviews, text classification of news articles, machine translation of English to Spanish. Clearly articulate the object and scope of the project, include any specific requirements or constraints. Data collection and pre-processing, gathering relevant dataset for the chosen NLP task from publicly available source or domain-specific repository. Purpose the raw text data by cleaning, tokenizing, and normalize the text and handling issues such as missing values, encoding, and noise removal. Exploratory data analysis EDA perform exploratory data analysis to gain insight into the characteristics and distribution of the text data. Visualize key statistics such as word frequency distribution, class distribution for classification task, and sentiment distribution for sentiment analysis. Based on these mentioned details, we can say that sentiment analysis of movie reviews determine the sentiment of positive, negative, or neutral expressed in a movie review. Text classification of news article categorize news article into predefined categories such as sports, politics, terminology, etc. Machine translation of English to Spanish develop a system automatically translates text from English to Spanish. Objective and scope of clearly state that you aim to achieve, for instance, improving accuracy of sentiment analysis, achieving high precision in the text classification, or creative and effective machine translation model. Scope define the boundaries of the project, including what will and what will not be covered. These could involve specifying the dataset, the type of model to be used, or perform metrics to be measured. Requirements and constraints, identifying any specific needs or limitations. This might include computational resources, the need for real-time processing data, privacy concern, or the require for the model to work on a specific language or domain. Data collection and pre-processing, obtain dataset from public source such as Kaggle, UCI machine learning repository, or domain-specific repository like IMDb for movie review or news website for articles. Ensure that the data is relevant to your chosen NLP task. For example, use a dataset of bilingual text pair for machine translation or collection of label reviews for sentiment analysis. Purpose the raw text data, remove any irrelevant information or noise such as HTML tags, punctuation, and specific characteristics. Tokenization split the text into individual word or tokens, which are the basic units of the process. Normalization convert the text to a standard format, such as lowercasing all words, expanding on fraction, and stemming or lemmatization word to their root form. Handling issues addressing missing values by either removing incomplete entries or imputing them. Ensure the text is correctly encoded, example UTF-8, and remove any additional noise or anomalies. Exploratory data analysis, gain insight, understand characteristics, analyze the basic properties of the text data such as the length of document, the frequency distribution of word, and the occurrence of specific terms of phrases. Distribution analysis, examine how the data is distributed across different categories or classes. For instance, in sentiment analysis, check the distribution of positive, negative, and neutral reviews. Visualization, use visual tools like histograms, word cloud, and box plot to better understand the data patterns and detect any anomalies or outliers. By following those steps, students will be able to define their NLP project clearly gathered and prepare the necessary data and perform initial analysis to set the foundation for developing their NLP model. The structure approaches ensure a comprehensive and organized way to tackle complex NLP tasks. Visualizing text statistics help in understanding the data better and identifying patterns, trends, and potential issues. Word frequency distribution to identify the most common word in the dataset, to identify understand the vocabulary size and distribution of a occurrence. Methods of a word cloud, a visual representation where the size of each word indicates its frequency or importance. Bar plot, a bird chart showing the top n most frequency word and their counts. Implementation example like from word cloud import word cloud library, then we have to use import matplotlib.pyplot as PLT. We have to create text equals to in double inverted comma dot join review for review in dataset in between third bracket text underscore column. Word cloud equals to word cloud in between bracket width is equal to 800, height equals to 400, max underscore word equals to 100 dot generate in between bracket text. Width, height, max word, it's a parameter of word cloud library containing and dot generate is a function which applies in text. Then we use plt.figure in between bracket figure size equals to 10 comma 5. plt.figure is a function and we define as a figure size equals to 10 comma 5. plt.imShow in between bracket word cloud interpolation is equal to bilinear plt.axis of plt.show. We use this parameter to show our plot in our Jupyter notebook and we use axis as off to avoid the axis name. Then we create a bar plot using some Python code from collection import counter import matplotlib.pyplot as plt. We use word equals to text dot split function word underscore count equals to counter in between bracket word common underscore word equals to word underscore count dot most underscore common in between bracket 20. 20 is the range we use to which is the most frequent word in our dataset. Word dot count equals to zip in between bracket common underscore word plt dot figure figure size 10 comma 5 plt dot bar word comma counts plt dot extracts rotation equals to 90 plt dot show function. Class distribution for classification task purpose to check the balance of classes in dataset to identify any potential issues with class imbalance which can affect model performance. Method bar plot a chart showing that the count of sample in each classes. Implementation of this import cmon as sns plt.figure figure size we have to mention 8,6 as an example. sns dot count plot in written bracket x equals to class underscore column comma data equals to dataset. plt dot title in written bracket class distribution plt dot show eminent distribution for sentiment analysis purpose to understand the distribution of sentiments in between bracket example positive negative neutral in the dataset to identify if there is a skew towards a particular sentiments. Method of pie chart we use a pie chart to showing the proportion of sentiment classes. Bar plot similar to class distribution, a bar chart showing the count of samples in each sentiment categories. Sentiment equals to dataset sentiment underscore count dot value dot counts sentiment dot plots pie. We use a punctuation comma figure size equals to 8 comma 8 title of sentiment distribution. Plt dot y level function plt dot show. We use a bar plot plt dot figure in between bracket figure size sns dot count plot x equals to sentiment underscore column data is equal to data set plt dot title sentiment distribution plt dot show. This can be said after reading out this part. Now we will go to next particular discussion. Particular part we will be discussing about model selection and training. It's mentioned over here as select appropriate NLP model and algorithms based on the chosen task and data characteristics. Example, neural networks for sentiment analysis support vector mechanism for text classification, sequence to sequence model for machine translation. Split the dataset into training, validation and test set and train the selected model using the training data. Model evaluation evaluate the performance of the trained models using appropriate evaluation metrics for the specific task. Example, accuracy, precision, recall, F1 score, BLEU score. Compare the performance of different model and fine-tune hyperparameters to optimize performance. Result interpretation and analysis. Interpret the result of model evaluation and analyze the strength, weakness, and limitation of the developed solution. Discuss any insight gained from the analysis and potential implication for several real world applications. Based on these mentioned details, we can say that each step in this process of model selection, training, evaluation, and analysis for an NLP project. Model selection and training selected appropriate NLP model and algorithm use model like neural networks, example LSTM, GRU, BERT, or traditional machine learning algorithm, bias, logistic regression. Text classification use model like support vector machine, random forest, or deep learning models, example CNN, BERT. Machine translation use sequence to sequence models with attention mechanism such as transformer models. Split the dataset, training set used to train the models, typically 70 to 80 of the data. Validation set used to tune hyperparameters and prevent overfitting, typically 10 to 15% of the data. Test set used to evaluate the final model prediction, typically 10 to 15 of the data. Train the selected model. For training the model, we need to import from sklearn model selection, import train test split function to utilize splitting data. Train underscore data test underscore data equals to train underscore test underscore split function dataset comma test size equals to 0.2. We consider 20% as our test dataset. Random state equals to 42. Train underscore data comma val underscore data equals to train underscore test underscore split function. Train underscore data test underscore size equals to 0.1 means it's a statistical parameter. We need to take 10% of our whole data set. Random for is 42. Example for training an LSTM model for sentiment analysis, we need to import from Keras model import sequential. From keras.layer import LSTM dense embeddings. Model equals to sequential function model.add between bracket embedding input underscore dim is equal to vocab size. Output dimension equals to embedding dimension, input length equals to max length. Model.added in between bracket LSTM in between bracket unit size 128 dropout layer 0.2 recurrent dropout 0.2. Model.add in between bracket dense 1 activation we use here as sigmoid. Model.compile optimizer Adam Loss equals to binary cause entropy matrix accuracy matrix. Model.feed in between bracket train underscore data train labels validation data equals to val data comma val labels. We here use for 5 epochs with a batch size of 32. Then we evaluate our model, evaluate the performance of this model, choose the appropriate matrix based on the task. So here, sentiment analysis, text classification, accuracy, precision, recall, F1 score, machine translation, we use BLEU score, implementation of this accuracy matrix from SQL matrix import accuracy score, precision score, recall score, F1 score. Validation prediction equals to model.predict val data. Val accuracy equals to accuracy underscore score in between bracket val labels val prediction. Val precision equals to precision underscore score val underscore labels val underscore predicts comma average equal to weighted. Same goes for the val recalls underscore score val labels comma val predictions average equals to weighted. Well, F1 score, F1 underscore score, val labels, val prediction, average weighted. F1 is a harmonic mean of recall and precision. Then we need to print those accuracy metrics in a proper manner. So print if validation accuracy val accuracy, print if validation precision val precision, print if validation recall val recall, print if validation f1 score val underscore f1. Compare performance and fine-tune hyperparameter. Compare the performance of different model using the evaluation matrix. Fine-tune hyperparameters such as learning rate, batch size, number of epochs, etc. to optimize the performance. Implementation use tools like grid search CV, randomized search CV, and hyperparameter tuning. From sklearn model selection import grid search CV. We select some parameters C 0.1, 1, 10, 100. Gammas we select 1, comma 0.1, 0.01, 0.001. Kernel is linear or RBF. Those are the hyperparameters. Grid equals to grid search CV, SVM function. Parameters grid refit equals to true, verbose equals to 2. So git dot fit training data training levels best underscore parameters grid dot best underscore parameters model underscore grid dot best estimator. Result interpretation and analysis. Analyze the evaluation matrix to understand how well the model perform on different aspects, identifying strain such as high accuracy and weakness such as low recall or precision. Explain any pattern or trend observed from the result. Discuss the implementation for real world applications such as potential use cases, benefits, and limitation. Provide suggestion for future improvement or additional feature that could enhance the solution. Example of interpretation strain the model achieve high accuracy and precision indicates it accurately classified the majority of instance. Weakness of the model recall is lower, suggesting it misses with relevant instance. This could be due to an imbalanced dataset. Insight improved data balance or using more relevant advanced model like BERT might enhance the performance. Additionally, further tuning of hyperparameters could help address current limitation. By following those steps, student can systematically approach their NLP project, ensuring through model selection, training, evaluation, and insightful analysis, leading to a robust and practical solution. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about deployment and application. It's mentioned over here as if feasible deploy the train model as a functional application or web service to demonstrate its practical utility. Showcase how the model developed solution can be used to address real world NLP problems and add value to specific use case or application. Deliverables, project reports, a comprehensive reports documentation, the project object methodology, data analysis, model development, evaluation result and conclusion. Code repository, a GitHub repository containing the codebase, script notebooks, and any other relevant resources used in the project. Presentation and oral presentation or demo showcasing the project findings, insight, and outcome to the instructor and classmate. Based on these mentioned details, we can say that deploying the train model as a functional application or web service is an important step to demonstrate its practical utility. This process involves several steps from setting up a service, creating an interface for user interface with the model. Here's the detailed explanation of how to do this. So we deploy the model, we need to choose a cloud service platform like AWS, Google Cloud, or Microsoft Azure provide infrastructure to host your model. Containerization, we use Docker to create a container for your application which can be easily deployed on various platforms. Web framework use framework like Flask, Django, or Fast API to create a web service. Set up the environment, ensure you have all dependencies installed in your deployment environment, create a virtual environment and install necessary libraries. Example, TensorFlow, PyTorch, Scikit-learn. Create a web service, develop a web service that handles HTTP requests and responses. The service should accept input data, process it, use the train model, and return predictions. Example with Flask. From Flask, import Flask request JSONify. Import joblib. App equals to Flask underscore underscore name underscore underscore. Model equals to joblib.load in between backend model.pkl. At the rate app route predict comma methods equals to post def predict function data equals to request.json prediction equals to model.predict in between bracket data text return jsonify prediction and prediction 0 if underscore underscore name underscore underscore equals to in between bracket underscore underscore main underscore underscore app run host equals to 0.0.0.0 comma port equals to 5000. For test the web service, use tool like Postman to send requests to your web service and verify that it's return correct prediction. Ensure the service handle edge cases and error gracefully. Deploy web service using Dockers. For that, from Python 3.8 Slim, work directory slash app, copy dot slash app, run pip install dash r requirement dot text, cmd python comma app.py, build and run the dockers container, dockers build dash t nlp model, dockers run on dash p 5000 nlp model. Monitor and maintain the performance of your web service using logging and monitoring tool. Regularly update the model and service as needed based on new data and user feedbacks. Showcasing the solution, demonstration create a user interface UI or interactive dashboard that allow user to input data and see model prediction in real time. Example of Streamlit import Streamlit as ST import requested st.title NLP model demo user underscore input equals to st.text underscore area enter the text. If st button predict response equals to response quest.post http localhost 5000 slash predict json equals to text user input prediction responses json prediction st write prediction. Real world use cases explain how your solution can be used in practical scenario. Sentiment analysis automatically analyze customer review to gauge overall sentiment and improve customer service. Text classification classify news article into categories for better content organization and retrieval. Machine translation document or communication between language and facilitating global business operation. Benefit and values highlight the benefit of using your solution such as increasing efficiency, automation of repetitive tasks and improved decision making. Discuss how your solution can add value to specific applications such as enhancing user experience, providing actionable insight, and supporting multilingual communication. Example use case sentiment analysis for movie reviews, use case description like objective we have automatically analyze and sentiment of movie reviews to determine whether they are positive, negative, or neutral. Application of this can help movie studios understanding audience reaction, improve marketing strategy, and enhancing user recommendation on movie platform. Implementation of input users submit a movie review text processing the web service process the input using the sentiment analysis model and return the sentiment prediction output. The output prediction is displayed to the user indicating whether the review is positive, negative, or neutral. UI example streamline application import streamline as st import requested st.title movie review sentiment analysis review equals to st.text underscore area enter your movie review. If st button analyze sentiments response request dot post http slash localhost 5000 predict json equals to text review sentiment response json prediction st write sentiment analysis sentiment. By following those steps, you can effectively deploy your NLP model as a web service, demonstrate it practically, utilize and showcasing its value in real-world application. This approach not only make your solution accessible but also provide a clear demonstration of its impact and potential use cases. Deliverable to success compile and present an NLP project, it's important to document your work thoroughly and effectively. Communication your findings. Here's you can achieve the through a project report, code repository, and presentation. Project report. A comprehensive project report should include the following action. Project objective clearly state the goal and purpose of the project. Scope define the boundaries and extent of the project. Methodology problem defining explain the specific NLP tasks. Example sentiment analysis, text classification, machine translation. Approaches describe the technique and algorithm used to address the problem. Data collection and pre-processing is a step to data source list the data set and their sources. Pre-processing step detail the step taken to clean, tokenize, normalize, and pre-processing the data. Exploratory data analysis EDA include visualization and key statistics such as word frequency, distribution, and class distribution. Model development, model selection describe the model and algorithm chosen for the task. Training process explain how the model were trained and the hyperparameter used. Model evaluation evaluate models matrix, present the matrix used in a evaluation the model. Results show the performance of the model on validation and test set. Result interpretation and analysis, strength and weakness discuss the performance of the models, highlighting their strength and weakness. Insight provide any insight gained from the result and potential implication for real world application. Deployment of process describe how the model was deployed as web service or application. Uses of explain how the deployed model can be used in practical scenario. Summary of the project and its finding. Future work suggests potential improvement or future direction for the project. Code repository. A GitHub repository should contain all the code and resources used in project. Repository structure is following those steps. README file provide an overview of the project including objective methodology and instruction on how to use the code. Scripts including scripts for data processing, model training, evaluation and deployment. Notebook provide Jupyter Notebook with detailed step and explanation. Data include link to dataset or instruction on how to obtain them. Model save train model and any other resources required for deployment. Requirements file list of all dependencies and libraries needed to run the code. Example of the step for end-to-end NLP project. First, we have to create an NLP project folder. Then, in between this folder, we need to create a subfolder called data. After that, we have need to create a raw file. Then we create a pre-process for file, and after that, in between NLP project folder, we need to create a notebook. In between notebook, we need to save some file with like zero point 0.1 eda.ipynb. Ipynb is a notebook extension for VS Code or any other ID used to develop our NLP model. Model underscore training dot ipynb evaluation dot ipynb. Then we need to create another folder called scripts. Here we can store our scripts. The preprocess.py. Py is an extension of Python scripts. Train.py, evaluate.py, deploy.py. Then we need to create a model folder. In between model folder, we create requirement.txt. In between requirement.txt, we need to write every dependence what we actually installed in our for our NLP programs. For that, we need to write some example like pandas, scikit-learn, any other visualization tools like Seaborn, word cloud. Every dependency we need to write in requirement.txt, and then we need to use dash e dot extension to connect this requirement.txt file with the setup.py script. The presentation and effective presentation should cover the key aspect of your project. Overview provide a brief introduction to the project and its objective. Methodology explain the problem definition, choosing NLP task and the approach uses. The data analysis EDA result share key finding from the exploratory data analysis with visualization, model development, model choice, discuss the model selection and why they were chosen, training processes briefly explain the training process, evaluation result present the evaluation matrix and compare the performance of different models. Deployed meant if applicable, demo showcase the deploy model and how it can be used in a real world scenario. Conclusion of the summarize the project finding and key takeaways. Future works mention any future work or potential improvements. Q&A interaction engaging with audience, answer question and discuss insight. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about assessment criteria. It's mentioned over here as technical proficiency, the depth of understanding and application of NLP concept, technique, and methodologies demonstrate in the project. Problem solving, the ability to define formula and solve a real world NLP problem using appropriate methods and technologies. Creativity and innovation, the creativity and innovation demonstrate in the project approach, solution design, and interpretation of result. Communication and presentation, the clarity, coherence, and effectiveness of the project report, code documentation, and oral representation. By following those outlines, students will have the opportunity to gain hands-on experience in solving real-world NLP problem, demonstrate their skill and knowledge, and contribute to the advancement of NLP application. Based on these mentioned details, we can say that when evaluation an NLP project, several key criteria should be considered to assess the quality and effectiveness of the work. Those criteria include technical proficiency, problem solving, creativity, and innovation, and communication and presentation. Here's an explanation of each criteria. Technical proficiency, the criteria assess the depth of understanding application of NLP concept, technique and methodologies demonstrated in the project. The components of the project should show a strong grasp of core NLP concepts such as tokenization, parts of speech tagging, and entity recognition, syntactic parsing, etc. Technique and tools, the use of appropriate NLP technique, example vectorization method like TF-IDF and word embedding like word to wake or bird. And tools, example NLTK is PACY Hugging Face Transformer. Methodologies, the implementation of suitable methodologies such as pre-processing, feature extraction, model training and evaluation. Code quality, the quality of the code including readability, organization and adherence to best practice in coding and software development. Problem solving of defining the criterion evaluation, the ability to define, formulate and solve a real world NLP problem using appropriate methods and technologies. Problem definition, clear articulation of the problem statement, objective and scopes. Approaches selection and justification of the methods and technologies used to address the problem. Implementation, effective implementation of the chosen approach include data collection, pre-processing, model training and evaluation. Result to the success of the solution in meeting the project object demonstrate through appropriate metrics and performance evaluation. Creative and innovation, these criteria look at the creative and innovation demonstrate in the project, approaches, solution design and interpretation of result. Component of approaches, novelty and originality in the approach taken to solve the problem. Solution design, innovation design of solution include model architecture, algorithm, use and any unique technique or enhancement. Interpretation of result, creative the insightful interpretation of the result, leading to meaningful conclusion and implementation. Additional feature implementation of any additional feature or functionalities that add value to the project. Example, interactive visualization, user friendly interface. Communication and presentation, the criteria assessing the clarity, coherence, and effectiveness of the project report, code demonstration, and oral presentation. Component of project reports, the comprehensive and clarity of the written report, including section on objective, methodology, data analysis, model development, evaluation result, and conclusion. Code documentation, the quality of documentation provided in the code base, including component, readme file, and use instructions. Oral presentation, the effectiveness of the oral presentation in communication, the project's finding insight and outcome to the an audience. Visual aids, the use of visual aids, example slide, chart, graph, to enhance the understanding and engagement during the presentations. In summary, a well-rounded NLP project should demonstrate technical proficiency, effective problem-solving skill, creative and innovation, and strong communication and presentation. Abilities by exciting in the those areas, student can showcase their comprehensive understanding of NLP and their ability to apply this knowledge to real world problem. This holistic evaluation ensure that the project is not only technically sound but also practically valuable and effectively communicated. By following the outline project structure, student can achieve several key benefits that enhance the learning experience and professional development in the field of natural language processing. Here is an explanation of the benefits of hands-on experience involve actively engaging with the material through practical application rather than just theoretical learning. Benefits of practical skills, students gain practical skill by directly apply NLP technique and methodologies to real world problem. This helps them to understand the nouns and challenge of working with NLP data and models. Problem solving, working on a real world project helps students develop problem solving skill. They learn to define problem, devise strategies, implement solution and overcome obstacles. Tools proficiency, by using various NLP tools and libraries, students become proficiency in the technologies commonly used in industries such as NLTK, SPACY, and Hugging Face. Demonstration of a skill knowledge. Demonstration skill and knowledge means showing the ability to apply learned concept effectively in practical situation. Benefits of portfolio building. Completing a comprehensive NLP project allows students to build a portfolio that allow showcase their skill and understand of NLP. This is valuable for job application and interviews. Confidence of successful finish a project boosts student confidence in their ability to handle complex NLP tasks, making them more proper for professional challenges. Feedback presentation their work and receive feedback helps students refine their skill and understand areas where they can improve. Contribution to the advancement of NLP application. Contribution to the enhance of NLP application involve creating solutions that add values to the field and have practical relevance. The innovation students have the opportunity to introduce innovative ideas and solutions, potentially advancing the state of the art in NLP. Real world impact: by addressing real world problems, student work can have a tangibility impact, improving existing application or creating new ones. Research and development: student project can contribute to ongoing research and development in NLP, providing new insight and approaches that can build upon by others. Comprehensive learning experience: a comprehensive learning experience encompassed both theoretical understanding and practical application, ensure well-rounded education. Benefits of integrated knowledge: students integrate theoretical knowledge with practical skill, leading to deeper and more holistic understanding of NLP. Critical thinking: the process encourages critical thinking and analytical skill as students evaluate different approaches, analyze result, and make the data-driven decision. Communication: preparing reports and presentation helps students develop continuation skill essential for effective conveying technical information. By following this project outline, students not only apply that they have learned but also gain invaluable experience that prepare them for career in NLP and related field. The process of solving real world problems, demonstrating their capabilities and contribution to the advancement of NLP application, ensure a rich and impactful educational journey. This approach fosters technical experts, creativity, problem solving abilities, and effective communication, all of which are crucial for success in the field of NLP. This can be said after reading out this part. Now we will go to next particular discussion. In this particular part, we will be discussing about additional resources and practice. Mentioned over here as recommendation: reading, research paper, and coding exercise for further practice and learning. This structured approach provides a comprehensive understanding of natural language processing, conveying both fundamental concept and advanced technique with practical application and real world example. Brief of this part, we can say a structured approach to natural language processing that converts fundamental concept, advanced technique, practical application, and real world example. Text pre-processing: learn about tokenization, stemming, lemmatization, stop word removal, and other pre-processing technique. Statistical method: using concept like TF-IDF, bag of word, n-grams, and their application in text analysis. Machine learning basic: brush up on supervised and unsupervised learning algorithms, feature extraction, and model evaluation metrics. Advanced technique: deep learning for NLP study natural networks, especially architecture like RNN, LSTM, GRU, and attention mechanism. Word embeddings: dive into word to vec, glove, and extensional embedding like word and understand their role in capturing semantic meaning. Sequence to sequence model: explore model like sequence to sequence with attention transformer architecture and GPT style model for language generation task. Practical application of sentiment analysis: implement sentiment analysis using various techniques like role based method, machine learning model, and deep learning models. Name entity recognition: build NER system using CRF, conditional random fields, BI LSTMs, or transformer based model like BERT. Machine translation: practice with sequence to sequence model for machine translation task using dataset like WMT or IWSLT. Text generation: experiment with language generation task using model like GPT-3, T5, or customized language model. Recommended reading and research paper: Speech and Language Processing by Jurafis and Martin, a comprehensive book covering NLP fundamental. Natural language processing with Python by Bert Klein and Loper practical example using the analytical library. Research paper from conference like ACL Associated for Computational Linguistic, EMNPL Imperial Method in Natural Language Processing, and Neuro IPS Conference or Natural Information Processing System. Coding exercise implement text classification using technique like TF-IDF plus SVM or deep learning model like CNN or LSTM. Build sentiment analysis system using a dataset like IMDb movie review or Twitter sentiment analysis dataset. Create a simple chatbot using rule-based approaches or more advanced model like sequence to sequence with attention. Would you like to more specific recommendation or resources on this topic? You need to research further on other social media site, and this can be said after reading out this part. Now we will go to next particular discussion. After learning this whole topic, now we comes to an assignment part. You have to write on your own word of those three questions. The first question is, what is text repulsing technique? You will get this answer somewhere around first five, in between five module. After that, what is TFIDF? You will also get this answer in between first five module. And after that, what is GPT? You will get this answer in the last part, five part of this topic. So you have to write on your own word after reading out from those module about this question.